perpendicular instead of parallel. It just I messed up. But yeah, that was my idea too. You explained it really well. That was the
Well,
same.
that's earlier when they were, I think it was DJ that was talking about those in the architectural field. And yeah, I've been in the architectural field for 30 years now, and that's exactly it. Like, we work in a realm where you have to be able to draw out what it is you're looking to do, or else your building doesn't end up looking like what it's supposed to look like. So when we engage with measurements and things like that, again, when you deal with measurements and things like that, these things that you see, again, require an explanation, just like our friend is sitting here kicking the chair demanding an explanation. Well, bro, you may be consuming it in a manner we don't just quite understand yet. Just because you have something doesn't mean we can run to you with the answer. Go ahead.
Let me have this question. So what I kind of feeling here is that light and the way we see things through light is something that is really hard to grasp. The way you are explaining it, it's something that's not something that you can trust.
I'm sorry, did you say flight or light?
Light, like light rays or
No.
photons.
Well,
If you
again, that you're going to have to first say, okay, well, I claim that light propagates in this manner. So if light travels, then light travels. Synonymous with light bending. But if I say that light propagates just like sound propagates on the same exact conveyor belt, just different things happening with that conveyor belt. Again, light propagating and sound propagating in waves versus traveling from a projectile, or sorry, a thing creating a projectile. Projector, that would be it.
So light is a really complex thing from your explanation. It's not something that we should take as the basis of anything as far as proof goes.
But I mean, I think it's pretty simple. I think we are engaging with an electromagnetic closed system, and with that closed system, you have this observance of gas pressure, 14.7 pounds per square inch, 1 bar at sea level, and with that gas, you have different the sparks that show up. So the sun would be a spark, the moon would be another spark, and when those two different sparks show up, the gases within that closed system do different things. One of the characteristics is light is created. We also know that the medium, again, that pressure we observe, 14.7 psi, is the thing that we breathe. It's also the thing that we know that trees wash, right? Because trees wash the air, so to speak.
I mean, yeah, we can say that, yes.
Right. So there's all these things that we have of all this evidence. Again, as I was saying earlier, evidence evidence that exists that requires explanation. Now, what's interesting is when you start connecting how gas works and all the amazing things that can do. Well, I'll then ask the question, what if the gas is literally the thing that's doing everything? It's just the different things that are being supplied that allows the gas to do the things that it does.
Isn't it just gas bends lights when the density changes? The density of the gas changes, it bends the light rays, right?
Well, again, you inserted the idea of light rays into the explanation, and I don't think you can do that. Right, you have to first take on the understanding of light propagating. Traveling.
If we are we able to think about light as rays? Is that something that can produce predictions in?
Well, think about a digital, or sorry, do you know what a digital measuring tape is?
I have no idea, but I will look that up. It sounds cool.
It's a thing that basically, I got to withdraw for this because I got another event in 16 minutes, but it's a thing basically that instead of using a formal measuring tape, you use a digital measuring tape. So you put the butt end against the wall, you press the button, and a laser emits from the...
yeah, I got that one, yes.
So hits the other wall and it comes back and it gives you the measurement. So we all know that like there's no thing that's literally like going out and physically touching it except for this beam. So we then have to take on the idea of, well, how does that work? Well, I can imagine it's like a ping rate, right? We know like cops out on the street can ping your car, how fast you're going, they can get a speed. So I'm thinking this probably works on the same manner. The ping rate is literally determining what the measurement is. So then from a standpoint, that takes on the idea of light traveling, light bending, right? That type of aperture that shoots a beam and the light travels and it doesn't bend. Then I look to if the light that gets emitted from the sun, if that works the same way, right? So is there a terminator line? Because we should see evidence if the light literally was a
but the digital measuring tape, I think you are able to prove that light can bend with the digital measuring tape if you put different density materials. Like if you put glass in front of a digital measuring tape, you measure a different distance to the flat surface behind the glass than you would without the glass. So that's literally proof of the like bending of the light.
So you would say changing it by introducing like well, if you say glass, it's not a medium, but you're changing, like you're introducing a lens, right? So when you introduce a lens, there would be a change that actually occurs.
Is glass not a medium? Like
No,
when I use my flashlight to light into glass and the light goes through the glass, like that's not a medium that the light travels in?
no, I would say glass is a solid object. Medium
but
is.
doesn't light goes through it? It travels through glass?
Yeah, just because something has the characteristic of translucency or transparency, if you will, doesn't mean it's a medium. A medium is something that is constantly seeking its level within the containment unit that it's located within.
Oh, sorry, I thought medium is something that stuff travels in or resides in.
No, that's a container.
No. I'm pretty sure that air is not a container, but when light enters air or water, it bends.
Okay, I got to withdraw, brother. Thank you for the chat. Gentlemen,
thank you very much.
Have a blessed day.
Hey there, DJ. Are you still here?
Hey, Jay. How's it going, man?
I'm quite all right, my man. How about yourself?
Yeah, good. Yep, I should be doing some work, but I've been chatting on here. I better get back to work shortly.
Yeah, I've been out working on a little project and had to go give some attention to. He decided to smack his brother, and so I had to kind of help him calm down a little bit.
Yeah, what's up? What's going on, Jay? DJ,
Oh, nothing too exciting. Sounds like there've been a real veritable mess of GTs in here this morning or this afternoon.
Today.
Yeah, a whole bunch of them came through just before. Just anti-flat earthers that are, they all came in. They were already banned when they came in.
Yeah, that's Sochi. Yeah, how come we just can't get rid of these people, like, in their entirety? How come, even though they get kicked, they can still come back in? I know something about the bot.
They changed. Yeah, it's because the server wanted their times of people interacting in rooms not to be decreased so much, so they made it like a permanent mute function, so the people can come in here, listen, but they're not allowed to talk. Yeah, a bit silly in my opinion. Every day we have to suppress them, and it's just crazy. It's the way the server does it, I guess.
Yeah, it's like that clown yesterday who for quite a while kept trying to get him and his buddy back on the topic of flat earth, and they'd be like, well, how is behavior different on a flat Earth versus a globe Earth and whatever else? And then he was trying to get you to expedite getting him image permissions, and then of course, for whatever reason, he's been stripped of that.
I think.
Yeah, he'd been stripped of it. I was just going to give it to him for a few minutes anyway, see what he had to post.
I didn't actually have any objection to him getting image permissions. Just when they start that, I usually just, when they get demanding like that, I just do whatever to put them on ice.
I mean, a lot of people join here and talk against Flat Earth because this is a debate server, and they assume that you are here to debate the Flat Earth position. And a lot of them are rude. I agree on that one, but that's their basis. And why do they join?
Yeah. We have no problem with people wanting to debate. That's fine. We prefer to share information and talk to people that are interested in looking to Flat Earth. That's the main purpose of this particular channel. But, obviously debates are going to happen, but there's a whole crew of people that are like obsessed anti-flat earthers. They've been following all the flat earth servers around for years. They have the same stale arguments. They're toxic, they're fallacious, and we just don't really want them around in this channel. So
I kind of agree with that. Like, I get your position where it's really, really uncomfortable to listen to someone who is so obnoxious about something they doesn't actually know a lot about.
Yeah, even if they know a lot about it, I mean, it's just, it wouldn't matter what we told them. They're just going to use fallacious tactics to weasel their way around it. And usually it's only people that are rude and disrespectful or passive aggressive, just people that are rude basically. If we have people like Matthew, who's a professor, he comes in here, he's been following, he's one of these kind of anti-flat earthers that's been following all the servers around, but he's more than welcome to come in here. He's very polite. We have great conversations with him. Just because he's respectful, the other people, they just have to be respectful. That's all it is. You just kind of get what you give here. And if someone comes into our house, acts rude and disrespectful, they're going to get kicked out.
Yeah, I completely agree with that one. Like, it's the first step would be for someone coming here is to infer your position, at least to understand it into some level. And mostly that's what my goal is, to try to understand as much about your position as possible.
But you seem to, our position isn't talking about the sky. We don't want to talk about the sky. We want to talk about the Earth, but that seems to be what you don't want to talk about.
I mean, we can talk about the Earth, for example, if you want to. That's something I would like to do. Like, a guy earlier in this server told me that parallel, no, not parallel, but the... sorry, words just doesn't come to me right now. What do you call the little bubble thingy with liquid in it to measure the flatness, or not the flatness, but the...
Are you talking about just a level, like a construction level? So when you're putting,
level. The word level just doesn't came into my mind. Sorry. So level. And the guy I talked with earlier said to me that levels are parallel everywhere. And that's his position. And then I wanted to ask him about why, what's the explanation behind that? Why do you think that levels are parallel everywhere? And he couldn't or doesn't want to give me one explanation for that. Why do you think that level is the same everywhere? Which might be a position that you doesn't hold. That was some question that I never got an answer to in the previous conversation.
So on a globe, you're talking about water level, right?
The level stick. It's the same.
Right.
As the water level.
That's why you would have the same rate of curvature over any body of water at sea level.
I think, DJ, if you don't mind, if you don't mind me kind of helping interpret broken English to my version of broken English, which isn't necessarily better. I think what he's saying is the previous guy said that if you take a construction level or any two construction levels, no matter where you take those levels,
Did you kill it?
and that they would be parallel. So if I took one here and I took one where you were, yours may be higher than mine, or mine might be lower than yours, but the imaginary line that would come out of that, of those two construction levels would be parallel. I think that's what he was trying to say. Not so much sea level. Yeah. Not so much sea level, but just two construction levels. I mean, DJ, am I wrong? Does that sound like a clunky way for the previous person to have explained that to him, if he indeed correctly understood what the previous person said?
I missed the first half of the explanation of the query. Sorry.
No worries. Oh, he said that. No, what I think he was trying to say was that the previous person told him that if you take two construction levels, no matter where they are in the world, that the lines will be parallel to each other. And he said the person wasn't really able then to explain to him more particulars as to why they would be parallel. And I was just saying that I think that if our friend here understood what the previous guy said correctly, that might be a awkward way to describe level.
Yeah,
and I was just asking if you would agree with that.
I guess that would probably only work over water. Obviously, the land is you can have level land at different elevations. There's not going to be a line that.
No. The point was that the line of level, like, when you take a level, there is like an imaginary line coming out of that. Like, that's the level where I'm standing right now.
Uh-huh.
And what his point was is that those lines, no matter where you are, will always be parallel to each other. And
but then at different elevations,
then they are still parallel. They are just at different positions.
Oh yeah, I mean, how are you going to test that?
Yeah, that was my question. Like, why do you think that this is the case? Because if he doesn't able to bring like any explanation or like proof for that.
If you don't mind me asking, my friend, what server were you in where the person used that?
This exact room.
Yeah.
Yeah, I'm not sure. I mean, did you ask them to validate the claim?
All I'm asking him is to explain me what's the explanation behind it. Like, why do you think that those lines, the level line, will be like parallel to everywhere? Like, they always be parallel.
Because maybe you're not understanding what we're saying, my friend. Is did you not understand what we've been saying the last several minutes about that?
No, I have no idea.
Okay.
Sorry. I might have missed that.
Yeah, look, I'm not sure. I mean, it doesn't make sense to me that, like, obviously,
DJ, it would only can you think of a flat earther in the room that would use logic like that? I mean, I'd be really hard pressed. I'd be really hard pressed to think that a flat earther in our room would use logic like that.
Yeah, I've never heard anyone make that claim before, to be honest.
So you're not claiming that the level line is parallel to her. So if I travel to another continent, the level line will be like to an angle to his level line.
No, I'm just saying you can't test that. That's not a good way to. Just a hypothetical, isn't it?
I mean, from his point of view, it probably were, because he wasn't giving any explanation.
Yeah, it's just like depends what you're meaning when you talk about level. You know,
Yeah, we would
So
need,
the globe
frankly.
Earth level
you're
has a
just saying
completely
that's not
different
something that is.
definition. Yeah, like we can talk about flat or curved rather than using the word level. So if you have a body of water, it has to curve at a specific rate over distance.
So what you were talking about earlier is that I always talk about the sky and it doesn't talk about like the actual surface. And like my question is what ways are there to measure the inclination or the curvature of Earth?
Right. So the Earth has to have a geometric horizon at a specific distance over a large body of water. Okay, so you can
Yes.
easily calculate where that is supposed to be on a globe, and then you can go out and you can do various experiments to try to find it.
Yes.
And then when we go out to do these different types of experiments and observations, it's absolutely non-existent, but it must be there if the Earth was a globe.
That's interesting. So you're saying that over a large body of water, the observations just doesn't match up with the globe Earth.
Right. So yeah, nobody's ever been able to find the geometric horizon using these practical demonstrations or practical experiments
And
or observations that were.
are there any
Mhm.
other ways that are you familiar
Yeah,
with?
sure. I mean, there's various different ways. I mean, you can use high-powered lasers and all sorts of different things to come to a conclusion or to use as evidence to stack on top of other evidence. For example, if you go to a 10-mile lake and you set up the camera at 1 foot observer height, geometric horizon has to be at 1.2 miles away, 1.225 miles away. But if you can then zoom that camera across the lake and see something that's 1 foot, off the shoreline, or if you can see the shoreline at the other side of the lake,
Isn't
you
that
shouldn't be able
experiment
to.
was done at least once?
Yeah, we've done tons and tons of these, and we can always see like thousands of percent further than you should be allowed to see on a globe, according to the globe method. We're not able to find any curvature, and we're not
But
able
wait, you
to
said
we're not able to find the geometric horizon. Geometric horizon, like the physical
Yeah, I get
place where.
that.
Yeah.
And you're
So
saying
when we look throughout history, from the globe side, nobody's ever actually been able to find the geometric horizon. Only calculate it using presuppositions. What we're claiming are presuppositions, like the radius value.
And you said we can agree on that horizon is highly dependent on your height. Like
Right. So you can calculate it like 1.225
yes.
times the times the sorry, my brain's not working for some reason. 1.225 times the square root of the observer's height in feet. So you can calculate where the geometric horizon should be using that formula, or you can just go to one of the globe Earth calculators.
Isn't that means if you are going higher?
Yes.
Like if you are not like eye level, but like 10 meters or 15 meters or sorry about the meters thing, I'm European.
It's all right. I use metric.
The higher you go, the more accurate you can take this measurement. Because like the problem is if you are really low, even like a small amount of change in your height will account for a large amount of like the change in the horizon. But if you're going higher, a small amount of changes in height doesn't. So I think a more accurate measurement of that would be if you would take like a really high object and calculate like a skyscraper that's able to look over
the Earth's round, buddy.
Yeah, thank you. That was very important. So are there any images online from the rooftop of skyscrapers that are near water?
Yeah, like I said, you can use all sorts of different methods to test for the geometric horizon, but you're not going to be able to. The problem where we're looking for it, but even when we've taken high altitude photography,
not flat.
like who is that? Spaz.
It's the Ziggy Spaz
makes
guy.
sense.
Just kick him.
As
Why do you say it makes sense? It's something in his
okay,
name.
So the world record photography, and it's even done using infrared, so it cuts through a lot of the atmospheric effects. We can see things that should be like a mile below the curvature of the Earth. Like, we've got observations from all different types of altitude, but we can see.
My problem is that the horizon is there, like either way, isn't it? Or on a flat Earth,
what a horizon is, according to us, and according to the definition of what a horizon is the place where the sky and the ground appear to meet. So it's an apparent location, fluctuates. It's a product of perspective, as well as atmospheric conditions and temperature conditions and other factors. Like if you're standing close to the ocean and you've got ocean swell over distance, you're going to have a false horizon due to ocean swell. So, all sorts of different atmospheric conditions can make the horizon jump around. Like if I show you a time lapse right now, you'll like a time lapse over water throughout a day, you'll see the horizon just jumping all over the place constantly.
Oh, I get that. But even that should be somewhat eliminated if you are taking the image or the observation from a higher elevation. Like you're not like like
right. So especially if you use an infrared camera.
I'm not sure about the infrared camera. Sorry, I'm not that familiar with.
Well, it cuts out a lot of the atmospheric conditions, so you're not going to have a distortion from here. You can see further, basically.
Yeah, but if you're going to something on top of really tall stuff, that should be more accurate. And I'm looking for some place that I can go and it's really high up, and you can make measurements from there.
I can show you some observations from height. Where
that would
we can see things. We can see things that should be like half a mile below the curvature of the Earth, but we can clearly see.
Yeah, can you show me that? Can you show me the actual study? And not just some guy's YouTube video? Yeah, not just a guy's YouTube video. Like an actual scientific study that's been peer reviewed. Can you show me that?
Okay, so where's your scientific peer reviewed study that found the geometric horizon?
I can give you so many.
Out of those so many, pick your best one and put it in the side chat. And secondly, I was talking with Taylor. So while you're looking for that study, I'll just finish talking with him.
No, you just committed a two-quote fallacy. Where's your study at, bro?
Just admit you don't have one. When did I claim that I had a study? Define what.
Okay, so what do you have?
Hold on a second. Don't talk over me. Don't talk over me. Right? Wait for me to finish talking. Huh?
What an ego, bro.
You're the one that came in hot. Look, I'm having a good conversation with Taylor because we have our egos under control and we're able to have a polite conversation.
Hey, bro.
Why am I not able to have that same type of conversation with you?
You are. You just have an ego. It's getting in the way. And you're not giving me a study.
What study did I claim to have?
The one where it says it measures flat. You can see objects that are supposed to be half a mile under the horizon.
I'm talking about observations.
Okay. That's what science is observations. So someone would have done a study.
An observation is step one of the scientific method. It's not what science is.
No, that's what scientific evidence is.
No, it's not science. Observing something isn't scientific evidence.
No. Well, that's how you get it. You have to observe something.
Sorry?
That's how you get
You
scientific
first you
evidence.
make an observation. We're not talking about that. We're talking about geometry right now.
So what do you actually have? You have a YouTube video of a guy, quote unquote, doing an experiment, and he left out all the variables coincidentally.
YouTube didn't make any of the. YouTube is just a video hosting platform.
Okay, I said a guy on YouTube.
On YouTube, what is on YouTube? That's just a video
A
hosting
guy
platform.
on YouTube made a video that quote unquote proves what you're saying, but he left out all the variables like air temperature, height, like everything.
You haven't even seen these observations. Why are you assuming things?
That's why I asked you. So
you sound like you're a little bit hostile, my friend.
Captain Cook, where is your research? Can you show it to us?
Yeah, so that's a two quote fallacy. So why don't you actually give me the study and then we can address that?
No, just give me the paper that proves the Earth is not.
Okay, I'll give it to you after you address mine.
I'm waiting for it.
Fallacy.
No, I'm not addressing anything until you send that. Okay, thank you. Just send it. I'm waiting.
I wasn't talking either.
I'm just waiting for you to
I'll send you the study, but I want to know where's your study because I asked you first. You can't commit a two.
I have no study. I'm just interested in yours.
And why do you think it's flat?
Hey, you're talking to a globe earther who's calling you out for the way you're acting.
And why do you think it's
happening? It's not even a flat earther.
Hold on, you're a globe earther, and you don't know there's studies to prove the Earth is a globe.
No, I'm just interested in your study.
Okay, so you're admitting our studies. When I show you this, what are you gonna do?
I'm gonna take some time and evaluate it and respond based on it. But we are not talking about studies right now.
Earth is round.
Right,
yeah, that's a trick quote.
As you're kind of like being super annoying, we can just continue our conversation without you.
Okay, so DJ, you were saying you having some having some video about observing this.
Yeah, just give me 1 second because once they get muted, they start chat skanking, as we like to call it. So I'll sort that out really quickly, then I'll get back to the topic. I apologize. Done. Thanks, Quetzal. Yeah, so what I was saying, okay, so there's a lot of observations where we can go up to a very high distance in altitude, and we can know the distance to what we're looking at, like a mountain, like Mount Canigou. There's a particular viewing spot. You can view it, you know how far away it is, and then you can do the calculation to work out where the geometric horizon should be, and how far the mountain should be, you know, above or below the curve.
Yeah, that sounds exactly what I'm looking for.
All right, so this is a really good observation because in this one, so from this viewing location, you can't actually see Mount Canigou. But on 2 days out of the year, the sun actually lines up with Mount Canigou. So as it starts to set, it actually goes over the top of Mount Canigou. And because it's so far away, the light rays aren't able to bounce off Mount Canigou and then go through all that atmosphere and reach it back to your eyes, right? So on 2 days out of the year, when the sun actually transits directly over the top of Canigou, it makes a silhouette, so you can clearly, you can see the mountain. Does that make sense?
Yes, I think. That's
yeah, because it's so far away, the light rays, you can't see it because the light rays can't push through that much. Right, but because the sun's so much, because the sun is so much stronger than the reflected light rays, it's able to make like a silhouette. I don't know if anyone else has that, the Canigou.
You mean the one the device used is
Yeah, the one where it's like turns into a silhouette.
Oh yeah, I remember that.
Can you
go on.
Show me the two locations, or?
Yeah, I can show you all of that. It's a pretty well documented observation. I can actually find the
Canigou
information. It'll just take me a moment.
Yeah, it's okay.
So you can find it on his YouTube channel.
Dude, the US is definitely on a grid. The whole country is a grid. I'm just zooming into random places in the US right now, and everything's on a grid. Okay, not everything, the hills are, but you can see it here. It's really funny.
On a grid, did you say?
Yeah. I just something I noticed now. I will post it in like the side chat.
You're looking on Google Earth or Google Map?
See, it's a grid. You doesn't get this kind of gridness in Europe.
So, my friend, that actually depends on what state you're in. So a lot of the United States is very flat. So, you get naturally a grid pattern, but then there's other places, oddly enough, like North Dakota, where you look at it and there's lots of tiny circles. But continue on, guys. I just wanted to put that in there that's all just state dependent.
Yeah, I mean, it's certainly not everywhere, but I zoomed into a few places like really far away from each other, and these grid
Yeah,
patterns.
like the state I live in, by the way, I'm about 1/3 the way up my state. Anything north of me is absolutely a grid, and pretty much most things south of me are windy and curvy and hilly. It is a really interesting oddity of the United States, but I just wanted to point out because it is so interesting that not all of the U.S. is that way.
Yeah, definitely. It's just something I noticed. Cool stuff.
Yeah, I was just looking in the main server for the Canigou observation because I can't find it on my. Got a video of it there. Here's just a still shot. Obviously, this isn't going to be good enough, but so you can get an idea of what we're talking about. From the viewing location, you can't see the mountain, but on those 2 days of the year that I was talking about, the sun passes behind it and backlights it. And the top of that mountain, it should be like 1,000 feet below the actual horizon. But there's a lot of observations like this.
Yeah, I'm just interested in the exact locations and heights. I'm kind of love to do the math by myself.
Yeah, that's fair enough. I've seen a lot of good videos that go over all of the, showing you the distances and the heights, all confirmed through Google Maps and all that sort of thing. But I just don't have it on hand. I'm used to showing different observations from lower heights.
Yeah, I mean, if you can show me a really good one from a lower perspective, that could be.
Yeah, I've got a really clear one here I can show you. I can try to find the Canigou stuff another time. I just second.
Yeah, I think I found it. It's on. I found it from the Jaron talking about it in the past.
Oh, awesome.
Through Davis White's channel.
Taylor, are you watching the video or?
Yeah, I'm watching the video right now. Sorry.
Okay.
It was 3,000 feet below the curve.
Did I miss it, or did he said where the video was taken from? Like where is the video taken from?
Canigou.
That's the.
It's on the.
Part.
It's on the video. You see the text. You can just Google that.
Yeah, I know where Mount Canigou is. I found that place, but where does the video taken from? Like, what's the perspective of the camera?
It might not be in that particular video.
Because that's I don't know.
It's a well-known viewing point. Yeah, I forget the name of it. It's not hugely familiar with this particular one, so I don't have the data to back it up on hand. I think I found where it supposedly is. I'll post in the chat in just a sec.
But if you have other videos or proofs like this, that's something I'm very interested in.
I'll just post this what I just spoke about in the chat, and then I'll go over one with you that has very good data to go along with it, where we can confirm 100% the distances and locations and all of that. I think this is the place it was viewed from, but I'm not 100% sure, and I can't prove it right now. So I just wanted to post that for you, so you get an idea.
I got that. So it's over the distance of 1,500. 223 miles. Interesting one.
That map might be in relation to this particular observation. I'm not sure. I think it's the same viewing point because it's a very popular viewing platform in the same location. But yeah, this one at the bottom, that's the world record photography, like the longest distance photography shot, and it wasn't done by a flat earther.
Yeah, I mean, my question is, okay, I might not be correct. I might have to do my own calculations on this one. But it feels like to me in these cases that from these images, it's pretty obvious that these hills that we can see are pretty sharp. But the sky, so it feels like the earth behind the hills is just not continuing on, it's just disappearing. Like if we are on a completely flat surface, I should be able to see this, the surface behind the hills if they are far enough.
No, because you have You have angular limits. You have like everything converges into a vanishing point relative to the limits of the focal length of the lens that you're using. Like as an example, so it can try to to make sense to you. Just say you're standing in a really, really, really long hallway. Everything will converge into a vanishing point. Not that far away when you look with your naked eye. Okay, so if you were
that's why I said I have to do the math on this one, because it feels like that, but I don't have the math in front of me right now. If we can assume that the lights are more or less traveling in the straight line, you can calculate the point of convergence and how high you need to be to see behind these hills.
Yeah, I think that's all. That's the whole point of the
because
problem, for the globe. After you do the math, the geometric horizon should be at a specific distance away, and that Canigou mountain should be hidden by a specific amount of physical Earth curvature.
My problem with that is that there are several counterpoints about like refraction and these kinds of complex
right
the light can do.
Right.
And I'm not saying that's the case.
Absolutely.
It's just making the whole thing more complicated, which I don't like. And
so the problem at the end of the day is being able to find that the geometric horizon exists in the first place, because it's always going to it's basically non-existent at this point. So the globe side needs to be able to prove that there is such a thing as a geometric horizon. We can't find it, and the globe side can't find it either. I think even NATO did a big experiment where they went looking for it, and even NATO admitted they couldn't find the geometric horizon. I could post that study. Well,
yeah, I mean, even if you're going to claim refraction or not, or without, you need to be based off the radius value that is claimed by the globe model. You cannot make any other excuses. So even if you add refraction based off the 7/6R, it's not going to help you.
But what do you mean refraction? Oh, sorry, I didn't get that.
If you think things are being uplifted and projected,
no, it's not uplifted. The refraction is like bending the light downwards.
Yeah, you think refraction. Do you think? Okay, I'm going to ask you. I'm not going to assume now. Do you think if I have something in front of me physically obstructing something is behind the physical object obstruction?
If the light is refracted,
you think the light's going to refract that object? That is, we can't see it all the way up. There's no such refraction. Sorry.
Yes, refraction can do that, and it's proven.
You have no proof of that.
It's not.
There's no model supporting that.
It's not proven that these videos that you are taking.
You have no model supporting that. There's only excuses.
If you are looking at water, and there is an object below the water, doesn't the light refract in a way that the object is seemingly somewhere else where the?
I didn't say we don't deny refraction, but the type of refraction you're talking about, it doesn't exist. It doesn't happen.
What do you mean it doesn't happen? I don't get that. Sorry.
Where do we observe, and as a natural phenomena, where can you show me?
I just make
something. Show me a human being behind a building being uplifted by refraction.
No. I want to do a different thing. Sorry, it's just like, do you mind if I draw?
Do you understand the concept behind that type of thinking? You want something behind a building to be uplifted around the corner or any.
Do you mind if I make a
any angle
about this?
You think that's refraction?
No. I'm just saying that with refraction, you can see things that are geometrically obstructed from you.
There's no model supporting that. You don't have any proof of that in reality.
Yeah, I have.
You don't have any proof of that. Which model will support what you're saying?
When you look at water, the light bends on the surface of the water, and there is refraction there, right? We can agree on that one.
We talk about distortions in the atmosphere.
No. I just want to prove you that with refraction, it's possible to see things that are.
Yeah, it's called distortions in the atmosphere. That's refraction. Not things being hidden and uplifted and projected as a projection up in the air magically. That doesn't happen.
Refraction happens when
it doesn't
the light
happen.
travels. Refraction is when light travels between different densities that's when refraction happens.
I
So
think
it doesn't matter if we are talking about different air densities or different densities of different mediums.
I don't think you're following the actual refraction model, to be honest. You're just talking about something someone taught you something else.
No. Refraction is happening when the light when the light goes through different densities of medium, right?
Air is one medium.
Yes.
Yeah, so you need two mediums for that refraction to happen.
Air, it is impossible for air to have different densities.
Medium. Medium air.
Yeah, but is it possible for the air to have different densities?
Still, it's not medium.
What are you talking about? Sorry.
In order for refraction index to change, you need two different medium, such as water or glass. That's one example. There's two different mediums. Air, water, or glass. Three different mediums. Right?
That's the simple...
It has nothing to do with density.
It has everything to do with density.
It has nothing to do with density when you talk about medium.
It has everything to do with density.
Why are you fighting back? I don't understand.
Because refraction is completely...
You making it up. There's no supporting cases. What you're talking about. Pull up one model of refraction right now that speaks of what you say. And mentions multiple mediums in there. As air being multiple.
Can we agree that refraction happens when air travels between different densities?
I didn't deny refraction, but the one you're talking about doesn't exist. Do you understand that?
So wait. When the air travels between water and the light, sorry, my bad. The light travels between water.
Yeah,
and
but
air.
we don't live underwater.
Yeah, I know. I just want to get the basics down so far.
Logical fallacy.
If you agree with that. So can I get down the basics? Or you are against that?
Air is one medium. Do you agree or not?
Yeah, I agree.
Okay, so how are you going to talk about things being uplifted then?
So
which model supports that?
Yeah, I would try to explain.
With one medium.
Yeah, okay. So when the light travels between air and water, how do you calculate the band? What that's based on? Like how much the light bends? What that's based on? The angle of the band. How do you calculate that?
Where have you been taught about refraction? Can you tell me?
In high school first.
In high school. So which one was it? Which particular refraction model?
You need to know the names.
They have names behind them. They're just called refraction. They have names behind them. Which model did you study?
All I'm asking you is how do you calculate the band?
It doesn't matter. So which model did you study in school?
Oh, look. I find a really good picture. So, can you show me the two mediums on this image?
How many mediums according to you?
Two. Can you show me the two mediums? Because on this image, there is clearly refraction on this image, right? Light bending between different densities of mediums.
Yeah, it's called turbulence.
What turbulence?
It's turbulence, yeah. The heat.
What do you mean turbulence?
Well, you don't see the heat?
Yeah, but why does heat refract light? Why does that happen?
Okay, so is it bending anything in the background, in the backdrop? I don't see any changes there.
No, I'm just asking.
It's still the same.
Clear.
Look at the bridge. Look at the bridge, the white part over there. It's not changing anything. Even if that density layer you're talking about is different from the air around it. It's not changing anything in the backdrop.
Can we agree on
how does this help your case?
Can we agree on that the light is bent in this case?
I don't see the light bend. Where?
No,
it's not doing anything in the backdrop.
It's just obstructing the view.
Yeah, it's more dense. I mean,
but why does it obstructing the view? It travels to the same air. What happens to it?
It becomes more opaque. You don't see through that.
But what happens to the light? It's what I'm asking.
It's not affecting what you can see. It's just making it blurry.
Yeah, but what happens to the light? I'm not caring about what I can see. What happens to the light in this case?
Just tell us what happens.
So in my interpretation, the light refracts.
And what is it doing specifically?
It refracts between the different densities because it travels.
Right. So is the pencil? Are you seeing the same thing happening with the pencil in the water?
Yes, I can see that. Yes.
Is that the same thing as what you're seeing in the image below it?
Yes.
Okay,
that's a really good image. Thank you. That was the image I'm looking for.
That's what I was trying to say. There's nothing, no changes in the air in the backdrop. That bridge looks fine. It's not changing any refractive index here.
Yeah.
There's no refractive index going on here. You have one medium. Mate, you're not understanding a lot.
No, I'm not. Sorry.
Yeah,
this is a
clearly.
really
how can I help you, man? You're not understanding. Like, you need two different mediums, like the pen he showed you, for that to happen, for the angle to change. You're not having angles changing in your image.
Yeah, I
nowhere to be
agree.
seen. No angles are changing in the air of any object in the backdrop. Or the train itself looks fine as well. Where's the angle changes there? Yeah.
Just wait a minute.
Called heat haze. What it is.
I don't understand, like, how
I have
you
to
thinking
open Photoshop because Paint is shit. Just wait a moment, okay? I just want to show you something.
I mean, if you can't be intellectually honest when you compare
I'm completely honest with you. Okay, this is my honest position.
When you compare the pen he posted and the one you posted,
is a really good example.
Not even the same, not even the slightest.
What do you mean?
They're not even the same. What DJ posted. What happens with two different mediums, the air and the water, and in your case, it's not changing any angles. The train looks fine.
More complex than that,
the bridge in the backdrop looks fine. Even the woods, the trees looks fine. Like what? Where are we going with this? I don't get it. Like, it's not helping your case. Or what were you talking about refraction?
In the train example, what happens to the light?
What light? It looks fine. It's just more opaque, dense.
Yeah, but why? Why does it more opaque? What happens?
How does it help your case in refraction?
It doesn't.
There's no angle of changes here.
Case.
I told you 3, 4, 5 times now.
I just interested in your opinion. What happens to the light in that image? It's clearly something happening.
So what? What's the point? Make a point. What do you mean? What I think? I don't care about what I think. What's your point in this case?
My point is that refraction can happen.
We don't deny refraction, but you're talking about something completely different. You're comparing it to a different case. This is not the type of refraction index we're talking about when you talk angular changes in the light.
Refraction happens because
it's still fine. Look, it's just air being more dense around that area because the train is releasing more heat. Clearly. You have heat. It's like the same with oil rigs. You have distortions.
If you went to
have you seen the Black Swan
and studied physics, you know that the refraction is completely dependent on the density of the medium because light travels
one
with different
medium
speeds.
Air. Then I don't know what they taught you in school, man. Come on.
Dude,
air is one medium. It can have different properties within that medium occurring, such as heat and cold mashing together, sure, and making distortions or turbulence in the air. But air is still one medium. What don't you get it? Like, what kind of school did you go to, man? I don't understand.
So
you understand what I just said? Different properties.
No, I don't.
In that air,
okay, sorry, I understand, but I doesn't agree with
can happen due to temperature changes, but that does not make it more than one fucking medium. Do you understand that? How many times do I need to repeat myself?
It has nothing to do with the amount of mediums. Light is not refracting because it's changing mediums. It has nothing to do with that. Light is refracting because it's going from one density to another density. Because
Taylor,
go.
If I showed someone the image I posted and said what's causing this effect, they would say refraction. And if you looked up the reason, it's because it goes from one medium, which is air, into another medium, which is water. That's what creates the refraction effect in this particular image that I showed. If I showed someone the picture of the train and said what's causing this effect, they would say that's heat haze. That's what that is. They're not going to say that's refraction. And also, it's going to work in favor of our argument.
No.
After I show you the next observation.
Wait a minute. So, let's start at the beginning, okay? So are you able to calculate refraction based on the density of the, let's say, mediums? Are you able to do that, right?
It's constantly fluctuating, so it's not possible to make it accurate.
What do you mean it's constantly? What is fluctuating?
It depends. Are we talking about?
I'm just talking about the pencil's
observations
case.
over
the pencil that
the pencil's refracting because it's going from one medium into a different medium.
But can you calculate the angle of refraction and where the light rays will go? Can you do a calculation like that?
Well, no, I can't, because you would have to factor in things like the shape of the glass and what effect is that having on what you can see and all sorts of different things. So
okay, so we are looking from above, so there is no glass in the way. We are looking from above. Can we calculate where the light will go? There is no glass. We are looking at the water from above. It's completely still. It's like a still.
Yeah, I don't know how to. I don't know how to calculate that. You
don't know how to calculate that?
No, I don't know how to do the math to calculate.
Because okay, so I do how to make that calculation. I do know how to make that calculation.
Okay.
And I did testing with that. And one of the major components of that calculation is the density. And if you're changing the density, it's changing the refraction angle. So what causes the refraction is not the different mediums, is the different densities. Can we agree on that one?
Yeah, but so to see this type of refraction level that we're seeing here is because of the different mediums.
But that's not because the refraction is not happening because of the
hold on a second.
Mediums.
Hold on a second. It's because the mediums are different densities.
Yeah, it happens because of that. But all I'm saying or trying to say here is that it's not like the refraction is not happening because of the mediums. You can have refraction in a single medium. It's just this very unique type of refraction that you have showed us is clearly visible because you are having two different mediums with two highly different densities. And that's why you are not getting these types of refractions in the air, because in the air density is something much more harder to it's dissolving, and there are all kinds of stuff that's going on. So this is why you are not seeing this sharp refraction in air. You are seeing more this fuzzy kind of refraction. Yeah,
of course.
That was all my point.
Yeah, but we were never saying that we see this type of refraction.
Sorry, I doesn't know how
Quetzal
to
wasn't saying that. Quetzal wasn't even saying that either.
No, Quetzal was saying that the refraction is clearly due to the change in medium, and there is no change in medium, then you cannot have that type of refraction or refraction at all.
When you get taught about refraction in school, this is the demonstration that they like to show, and they will tell you that it's because of the two different mediums.
I mean, it's okay that they don't teach you that in elementary school or somewhere, but refraction is clearly due to change in density and not change.
Oh my gosh, that's okay. Can we just go ahead and get the citation instead of you making this up on the spot? Because Snell's law has to do with the border of two differing isotropic media creating the refraction that we're talking about with two different isotropic media. If you're talking about atmospheric refraction, why don't you give me the formula and the definition of that with citation so we can be apples to apples comparison and be on the same page?
It's the same formula.
Go ahead and give me the citation that's the same formula. I'd like to see it.
Sorry, I don't get your point.
My point is, unless you're going to just continue to make stuff up on the spot, we're going to need citation.
No. So, why does refraction happen?
Okay, so what kind of refraction are we talking about? Be specific.
Any kind of refraction.
Oh, so they're all the same? So even though there's 5 different types, they're all the same?
Yes, they all work the same way. It's just some of them are more complex, so we need more complex.
Okay, so let's look at the complexity. So in this situation, depending on the observation that we're making, what is the observation, by the way?
What do you mean?
What are we talking about in terms of refraction right now? What does this have to do with the topic?
Nothing. Right now, it has to be
Nothing.
nothing.
So we're just talking about refraction for no good reason?
Yes, exactly.
Okay. So what kind of refraction are we talking about in
Any
this?
kind of refraction as a physical.
Any kind. Okay. So we're talking about, like, when you put a pencil in a glass of water, and it seems to shift.
Fine for me. So if I put a pencil
So
in
that would be Snell's law. So that would be the border, two different isotropic medias. That would be Snell's law, right?
Yeah, but my question is not how you calculate it, but why does it happen?
Okay. Well, you said you can calculate it, and it's because of the density. So I just need to see the formula with the density included and how you would go ahead and calculate for that.
I can give you the formula, but I'm not sure if that will bring forth the conversation between us.
No, I want to know specifically. Just give me the calculation and show me how the density affects everything, and show me where the border of the two different isotropic medias affects that. Because in the definition, it's talking about two differing medias, not one.
Yes, exactly.
Yes, right. Okay, so we're talking about two media. So in air, there would be no refraction because we don't have two differing isotropic medias or a border between them, right?
Yeah, but refraction doesn't happen because of the two media. It's just the way we simplify it for the calculation.
Okay, just give me the citation for the thing that you're talking about. That way we know that you're not making it up.
So refraction happens because of the speed of light. And here's
you're going to get me the citation and post it in the side chat. So I know that you're not making. Okay, did you put it in the side chat? Did you put it in the side chat?
Yes.
Okay.
It says clearly they're one medium to another medium.
Yeah, that's the simple explanation, but if you go down to the slowing of light, as described above, the speed of light is slower in the medium other than vacuum. The slowing applies to any medium such as air, water, or glass, and responsible for phenomena such as refraction. So the speed of light that's causing the refraction, and the speed of light is changing based on density. So if you're going from lighter air to denser air, you will have refraction.
We just go over the observation that I've been trying to show you, and then we could.
Yeah, of course we can do that too.
Yeah, I'll just look. I'll post it again, just so it's fresh in the chat there.
It's the second one, right? The one with the.
Yeah, I just posted it again, so it's right there.
Yeah, of course.
Okay, so that's just obviously I have the full video. This is just a clip from it. But the observer height is 8 foot off the surface of the water. And if you do the math on a globe, the geometric horizon should be at 3.46 miles. The oil platforms are just there as distance markers. We know how far we're seeing. And the second oil platform's 10.1 miles away. And that's easy to verify using Google Maps. And he does that in the video. So we can agree that we can...
You are saying this cannot happen due to refraction.
Oh, I'm saying that if the Earth's a globe, you have to have a geometric horizon. I'm not talking about refraction right now. I'm just showing you the observation and just going through the math.
So if I do the math...
And then you can try to invoke refraction, but you need to go over this first because I need to explain the point of this observation and the problem that you have, even if you want to make up refraction.
Yes, okay, go ahead.
Okay, so you have to have a geometric horizon if the Earth is a physical ball of 3,959 miles radius, right?
Yes.
So if you do the math, you can check later if you want, but it is correct that the geometric horizon has to be at 3.46 miles from an 8-foot observer. Okay?
Yes.
Okay, so we can agree that we can both clearly see the horizon behind the second oil rig, right?
Yes.
Okay, so the horizon on a globe has to be at 3.46 miles. So what we have here is an invisible horizon that's completely impossible to find on a globe, and you're going to have to claim that everything behind it isn't really where it appears and that it's all perfectly being refracted up to appear as if it's a perfect observation looking out over water. with no distortion or anything like that. It's all just perfectly rising up to eye level as if it were obvious reality. The problem that you're going to have here, hold on a second, just one more sentence, I'll be finished. The problem you're going to have here is if you try to say it's refraction, you're still not going to be able to validate that you have a geometric horizon in the first place. So if you go to any definition of what a horizon is, it's the place where the sky and the ground appear to meet. Okay? There's no definition of horizon that is a completely invisible horizon that can never be detected. If you want to claim that the Earth is actually a globe, it has to have a geometric horizon at 3.46 miles. Everything behind it has to be hidden by a certain amount. So that second oil platform should be hidden behind the horizon by around 30 feet, 29 feet, I think. But you can clearly see the horizon is behind the oil platform.
Can you give me the numbers so I can take the math myself? It's something I will be very interested doing.
The observer height is 8 foot.
8 feet, yes. The calculated horizon is 3.46 if we are not taking into account any
no, the physical... No, just the physical geometric... Yeah, the one that has to exist, not the apparent horizon.
3.46 miles, right?
Mm-hmm.
And then...
And the second oil platforms, don't worry about the closer one. It's about 6 miles, but the further one away is 10.1 miles.
10.1 miles away.
Mm-hmm.
And that's the numbers we are working with.
And and I'll post the whole... 1 second. I'll just post the full video as well.
Oh, that's
which is...
And do they mention the refraction in the video, or you are not sure about that?
I'm not making... Yeah, so refraction isn't mentioned in the video because it's not necessary because what we're trying to find is the geometric horizon.
Yeah, but
it's not
are we agreeing that the same as with the pencil, that refraction are able to bend the light such that you are able to see things that otherwise you are not shouldn't be able to
so
see?
even if you let's just say that we gave you atmospheric refraction. So standard atmospheric refraction or terrestrial refraction, which presupposes the very thing in question, which which has the radius value in the formula 7/6r, which is the radius value. So that's the thing that's in question. So it's already ridiculous, add to assume a globe in the thing that you're testing for in the first place. But let's just say that we give you that standard refraction formula. If you add that in, it still doesn't account for the discrepancy in any way, shape, or form.
Yeah, I mean, I'm sure it's not, or it will not, but I want to do the math by hand. It's something I'm really obsessed about. Like, it's it's something I love to do. Like, I just want to do it by hand and see for myself that it's actually
okay. So you've got one there, and I don't know how long it would take you to do the math, but I've got a more extreme example here that might be more fun for you to do the math.
You can throw that at me too.
Yeah. Let's just have a quick look at this one because this one's good. This is on a lake in Canada, and the camera is just 3 inches above the surface. Very still, flat lake. So the observer height is 3 inches. There it is. Once again, I have the full video with the location and verified distances and all that sort of thing. So you can see that when he zooms in, you'll see a little peninsula, and then on the right-hand side, and then you'll see another peninsula after that first peninsula. So that second peninsula is 13.8 miles away. So according to the globe math, the geometric horizon should be at 0.6 miles. And the little peninsula that we can see should be obstructed by 120 foot of Earth curvature.
Yeah, but we are agreeing that refraction is something that can take into account in these cases.
There's absolutely no refraction formula that exists that accounts for this discrepancy. It's 2,200% further than what we should be able to see on a globe. There is literally no...
I mean, it's the distance that I'm really basing my...
The distance is 13.8 miles to that second peninsula.
Yeah, because like these kind of refractive events, like refractive stuff, is really like it can be really magnified by distance, because you have a long distance where there are different layers of air and.
Right, but you have to have a geometric horizon. You have to have a geometric horizon in the first place at 0.6 miles.
Yeah, but like
it isn't there. It isn't detectable, and you're going to need that to be able to validate that a geometric horizon even exists in the first place.
But when you're
there's no definition. There's no definition of horizon that's an invisible horizon that can never be detected.
No. What I'm saying is that when you're saying detecting the geometrical horizon, you have to take like you will never be able to detect that for like 100% accuracy. Especially.
Okay, welcome to Flat Earth then. Thank you for conceding.
It doesn't mean the Earth is flat.
Well, if you have no geometric horizon, then what exactly you're going to measure to get the geometry?
Yeah, that's my question is. Like if I can.
Right, so there's no way to measure the Earth's geometry if it's always refracted, right?
There are other ways to measure it.
Such as?
I don't know, going to sending a satellite on orbit, for example.
Oh, wouldn't you kind of need the Earth's geometry before you send up any satellites?
I mean, if you succeed, I will assume you guessed right.
Wouldn't you need to have the geometry in order to do the satellite sending you're talking about?
Well, my point is that if you assume that the Earth is spherical, you assume that you doesn't know it. You assume.
Why would you assume it if it never presents
you
itself
just
that
assume
way?
it. You don't know.
Why would you assume it if it never presents itself that way?
Because you are crazy.
So you're crazy and you want to assume the Earth is a sphere.
Yes,
and so you assume it to be a sphere and you can't measure it to be a sphere. And so you don't even know if space is real. So you send a satellite to a place you don't know whether it's real or not because you're crazy. Yes. So you're saying that globe is crazy talk.
Yes.
Okay, so the globe is crazy talk and it hasn't been validated and it can't be measured. So where are we going to go now?
If you will allow me to finish my train of thought here. So you are crazy.
Is your train of thought going to be assuming something that doesn't exist and we've proven it to not exist? Why would we go down that line of questioning?
If you allow me to finish, so you are crazy and you assume that the Earth is spherical. And it works in a certain way that you are describing. You are not sure of it, you are crazy. And you are sending up a satellite. But if you're succeeding in sending that satellite and everything goes according to your calculations, wouldn't you say that that proves that your base assumption, it was completely crazy, it was bonkers crazy, wouldn't you assume that that was right?
No, because number one, I send up the satellite, it takes a picture of the Earth, which they haven't, being a sphere. I come back to the sphere, I measure for the sphericity of that thing, and it's not there. So therefore, the satellite that I send up to wherever is taking pictures of something that I don't live on. Maybe that's fraudulent. What do you think?
No. I'm just thinking of the from the point of view of the person who actually sent up the satellite, not your point.
Yeah, no one did that. No one did that. So what you're saying is the globe is crazy talk and it cannot be verified. And if we appeal to images from a satellite that you haven't produced yet, then maybe it's a sphere. Come on, dude. You can be more reasonable than this, can't you?
No. I'm not saying any of that. All I'm saying that the point of view from someone who did this. I'm not saying they did this, but if
why don't we stop with the hypotheticals and we just stick to what we know? So far, the Earth has only been measured to be flat for tens of thousands of miles, square miles, in all the forms of, navigation that we can conceive of. And yet you want to go down this road of, what if the guy's crazy and he sends up a satellite anyways into a second law of thermodynamics violation? I would say that's a big old waste of time, and there's no point in trying to go down this line of reasoning.
So do you believe in the second law of thermodynamics, right?
Of course, high pressure goes to low pressure, yes?
That's not the second law of thermodynamics.
Oh, what is the second law?
It's the entropy, right?
It's amount of energy transfer, right?
Yes.
High temperature to low temperature, it's the flow of energy. High pressure to low pressure, all the time, never is violated.
That's not true, actually, but that's a different topic.
Oh, so the second law has been violated. Let me know, unless you're going to beg the question of the high pressure gas of Earth not evacuating and filling the empty space that's called space. It's an ever-expanding vacuum. How come the air is not filling the ever-expanding vacuum and volume of space?
Nothing I'm talking about. So when I said that it's thought to be violated, the second law, I'm not talking about like gases escaping into space and that kind of stuff.
So what are you talking about? When is the second law being violated?
In quantum physics, there are a lot of cases where it doesn't seems to hold up.
Quantum physics, say that again, how?
There are certain cases in quantum physics where it seemingly the second law doesn't hold up.
Seemingly. Okay, seemingly. Great. Give me these examples.
It's really complicated. It not just give me. You have to actually.
I got time. I love learning. I love to learn. You're going to teach me something today on how somehow, seemingly, the second law of thermodynamics is being violated in quantum physics. Go ahead.
Yes. Do you know of these like entangled situations?
Quantum entanglement? So now you're going into pseudoscience. This is not physics.
Why is quantum entanglement pseudoscience?
Because you couldn't show me quantum entanglement if you wanted to.
What do you mean?
It's a theory.
I think you doesn't know how theories work.
Okay, show me quantum entanglement in action.
In action? Oh, of course.
Yeah, go ahead. Give me an example of
it. Do you have sunglasses that are polarized?
No, they're polarized.
Yes. Do you have those? You need 3.
Yeah. This is quantum entanglement?
Yes. You need 3 polarized sunglasses. And I can show you.
Okay.
You can do it for yourself, actually.
And what's happening?
So what are you doing is you're holding up 2 of these sunglasses that are polarized. If you are holding them parallel to each other, all the light goes through, so you can see through them. If you're doing like one of them in 90 degree angle to the other, they are completely black. You cannot see through. It's completely black.
Okay.
So what you are doing with the third one, you are inserting it between the first 2 and rotate it 45 degrees. And what it will do, you will be able to see through. And in terms of quantum mechanics, that's like entanglement in action.
So how would they isolate that as the cause? This is an effect. What's the cause?
What else causing it?
Oh, so now it's a burden of proof reversal. So you see an effect and you call it quantum entanglement, but you haven't isolated that as the cause?
No, it's the explanation for the effect. I don't know what...
Yeah, I know. I need you to give me an experiment that actually validates this. No, that's not an experiment.
Why?
No, that's not an experiment. You're just showing me an effect where you put 3 lenses together and they have an effect. Now, the cause is you're going to say quantum entanglement. I want to know what experiment you actually conducted to isolate quantum entanglement as the cause. That is not the experiment. It's only an effect.
It breaks, like this experiment that I...
This is an effect. You're giving me pseudoscience like I called at the very beginning.
Okay.
What cause did you isolate? What is the cause?
It was my bad. Okay, I don't know why I thought it's a good idea to go towards quantum physics.
Yeah, I don't know why you thought it was a good idea to come into a flat Earth server and spout nonsense and pseudoscience either. I asked you for the cause, not for the effect.
Okay, so here is my point of view. And you just have to let me finish, okay?
I don't need your point of view. I need to see what you can demonstrate. Your point of view and your opinions mean nothing to me.
So I came to this channel in good faith in order to learn more about your position, and I think I did that. I demonstrated that I'm not here in bad faith or to do like anything bad towards you.
No, I think you are here in bad faith because right now you just tried to bait and switch me on a cause and effect claim. You just gave me an effect and called it a cause, and you called it quantum entanglement, and you still have not demonstrated to me what that is or what that might be so that we can isolate it as a cause to the effect that you described to me. So your good faith is actually total bad faith and lies and pseudoscience. And I'd like an apology. I think everybody in this room deserves an apology for you lying to us and kissing down our back. Hey, by the way, can you go ahead and apologize to the entire room for lying to us?
No, we can go into it. We can.
Okay, how did you isolate the cause of the effect? Now we have the 90-degree sunglasses, polarized sunglasses. We have an effect. Now you can see through these lenses. What is the cause? Can you isolate it?
What do you mean isolated? What do you mean under isolated?
Do you not know what the scientific method is? What is the hypothesis for quantum entanglement? What is the actually observed phenomena for quantum entanglement? Polarized sunglasses?
No, not really, but it's the...
Okay, so what is the naturally occurring phenomena that we can study? What is it?
That I just said. Told you the glasses. That's
polarized sunglasses. Is that the only time this ever happens? When do we observe this in nature, other than the time that we get polarized sunglasses and stack them?
So it's not something that easy to just see in nature.
Oh, so we don't see it in nature. So this is a man-made effect using man-made materials, and then you want to claim quantum entanglement? You've got to be kidding me.
Wait, why does it matter if it's man-made, the glass? Why
because this is not natural science. All of a sudden, you've taken three man-made things, and now you have an effect, and then you go ahead and have an effect, and not isolate any cause, and then just ascribe quantum entanglement to it. It sounds like a big old scam. Did you get scammed, and are you trying to scam us with the same scam that you got?
Sorry, I don't know, man.
I don't know either. I don't know why you would come in here with the scam that you got peddled and then scam us with it. So you don't have a naturally occurring phenomena. Yeah, you're here to scam people. You're here to tell them that quantum entanglement is the cause that you can see through three polarized pairs of sunglasses, and that apparently is quantum physics and quantum entanglement.
Wait.
It's a boatload of garbage.
Right. You are correct. It's not quantum entanglement. You won. You are right. It's not quantum entanglement.
So back to the second law of thermodynamics. What does this have to do with the second law?
Wait a minute. Why do you think that happens with the sunglasses?
Who cares? This is your claim. You claimed an effect. It's a synthetic effect.
I care about
Okay, you care. So why don't you go ask the people that peddled you this nonsense as to why you don't see this in nature? But if you take three pairs of polarized sunglasses and you can see through them, now you have an effect that you can study, but it's not a natural effect, and it certainly isn't quantum entanglement, whatever that is.
But I explained to you why that's happening, and you are not accepting.
No, you didn't explain to me anything. What is quantum entanglement then? Tell me what it is.
It's fairly complicated. So quantum entanglement comes from the uncertainty principle. Are you familiar with it?
No. I'm sure you're going to tell me what it is, and it's probably going to be wrong, but tell me what the uncertainty principle is.
No, I'm not going to tell you and I'll tell you why. It's a really complicated subject. It's not something that I can tell you in 10 minutes or 5 minutes. It's something that you have to study for long hours in order to understand it properly. So it's not something that I just give it to you in 5 minutes. If you are interested in it, I can give you pointers and you can research it.
Of course I'm not. Dude, you've already showed me that you don't know what natural science is and you don't know the difference between cause and effect, so I'm not going to be learning anything from you today. The fact that you've been ripped off by a bunch of other people and then tried to come in here with the same nonsense shows me that you don't know anything about the topic, you don't know anything about refraction, you don't know anything about the second law of thermodynamics, you don't know anything about anything that you're talking about. So this good faith, if you're here in good faith, then you're in good faith quite ignorant of the topic. But I don't think you're here in good faith. I think you're here trying to give us a scam. Why are you trying to scam us?
Can I ask what natural science is in your opinion?
Holy crap, you don't know what natural science, anything occurring in the natural physical world that we can get cause and effect relationships with. That's the natural scientific method. And you have to go through a method. You have to observe a natural phenomena. You didn't have one for me. You had polarized sunglasses, but whatever. So the next step would be, I guess, nothing, since we don't have a naturally observed phenomena.
Yeah, we have. Like, if I rotate...
So it is what?
If I rotate the polarized glasses, they are...
So the polarized sunglasses that were man-made, but you can't get me a naturally observed phenomena. Show me where we see this in nature.
If I take glass, like regular...
No. I want you to show me in nature where we have this effect.
I don't know. Like, I think you're not familiar with natural science.
You don't know. You don't know. You don't know where we see this in nature, but somebody came along, they developed polarized sunglasses, they stacked them in 3 rows, and they told you the reason that you can see through them all of a sudden is because of quantum entanglement. That, my friends, is what we like to call a scam.
So, sorry, but first of all, I have to disagree with you on the natural science part. Natural sciences are not natural because they are not interacting with objects that are man-made. That's completely incorrect.
So natural science is a contradiction of itself? The fuck?
Sorry?
Is natural science a contradiction of itself? Is that what you say?
No. Why? All I'm saying
you just said that
something to be natural science, it doesn't have to be like removed from anything that humans can do. Like,
yeah, it is.
With the
naturally observed phenomena. It's in the title, bro. Natural science. Are there any polarized sunglass trees around here that I could pick a pair off of?
Can you give me the definition of natural science?
Just a moment.
And if you don't mind, says who, I want to just jump in here a quick second on this ridiculous nonsense of 3 pairs of polarized sunglasses.
Go ahead. I'm all in.
You know, for all of the years that I've spent in optics, it's obvious that you don't know anything about optics because the sunlight is circularly polarized. So when you turn your sunglasses against another one, what you're doing more or less is just changing how much of that circular light that you can see. And when you put a third one in the middle, it changes the light more or less. It doesn't change the light, but it just changes the angle of the lens because all 3 lenses act as one. And that's kind of the basics of how that's the basics of how motion picture photography works. Is that your lenses are based, so you have multiple reflexive lenses to achieve a look, and so this here is I hate to say it, my friend, because you seem like you're very respectful, you seem like you're a nice guy, but you don't know what you're talking about. That has nothing to do with quantum entanglement. Is you can get the same effect with radio because radio also can be circularly polarized. And that is and so changing the antenna and changing your dish, just turning it, rotating it, can affect your reception. So long story short is that has nothing to do with quantum entanglement and everything to do with optics. But go ahead, says who, back to you, my friend.
So, from Wikipedia, natural science is one of the branches of science concerned with the description, understanding, and prediction of natural phenomena based on empirical evidence from observation and experimentation. So there you go. And natural phenomena.
Where does that say that I cannot use man-made objects?
It says natural phenomena.
And natural phenomena
sunglasses a natural phenomena?
Natural phenomenon cannot happen to man-made objects, right?
If you take 3 pairs of man-made polarized sunglasses and you create an effect, would you call that a natural phenomenon?
G.A. Barrington, can I ask you something real quick? It's really important.
My friend, you have nothing to ask me. You're in the conversation with says who. I was just pointing out your ridiculous nonsense.
Yeah, I agree with you.
In fact, I have actually used my circularly polarizing lens on my cameras, and I have actually put polarizing sunglasses in front of them. And that has nothing to do with quantum entanglement or anything else.
You're right. You are completely right.
It's merely, so where you come up with that, I mean, I just don't know if you just made that up on the spot, but obviously you've not worked with not worked with optics. So go ahead, says who, back to you, my friend.
Can I ask you
something? I'm gonna hand it back over to DJ because I interrupted him mostly because it was not going very far. It seems like we were denying simple tenets of the scientific method and observation and citations and definitions of terms.
just give
But
me
I'm
a
going to hand it
minute.
back over to DJ. Thank you.
So I just wanted to ask Barrington a single thing, if he's listening. And he's left. Okay, that's sad.
Yeah, I was just wanting to know, like, you said there are other ways to measure that there is actually a geometric horizon. Like, would you agree that there's no, like, observations that you're aware of that validate there's a geometric horizon?
I completely agree with you. Yes, hands down.
Why are you suddenly conceding everything now?
What about the huge discrepancy in how far we can see? Like, even the refraction formulas and stuff, they don't account
I have
for...
to do the math. I have to do the math by hand, and I can say stuff about that after. Because I still think that refraction can explain most of that. But I'm not sure until I did the math by hand.
Right, but so you're still stuck without having a geometric horizon in the first place to use as a baseline to check your refraction calculations. So like, here's the problem. It's like, okay, so there's a 2,200% discrepancy.
Yes.
And the discrepancy is directly in relation to where the geometric horizon has to be. So first things first would be to... Hold on one second. First things first would be to validate that a geometric horizon exists in the first place, because otherwise it's just maths based on a presupposition.
I mean, yeah, but we are both agreeing here that refraction is making this problematic, right? So either way, refraction is making this case harder. So you will never be able to see the exact location of the geometric horizon, even if there is one, because of refraction, right?
Well, the key word is even if there is one.
Yeah, of course. So you cannot.
We need to validate that there is one to be able to make any further calculations, go anywhere.
Like, based on this, it's like this way of figuring out the horizon is not a effective one, because even if there is one or there is not one, you are based on these kind of researches or looking for it. It won't be efficient either way.
So if your math doesn't add up with refraction added, if you use the geometric horizon as a concept in your case, what then? Are you going to concede?
I mean, I am ready to my problem is I would be conceding, but my problem is that my idea of spherical Earth or global Earth, round Earth, is like standing in so much more than just the how far we can see kind of thing.
What if you count out the things that you can't validate yourself?
Like, one of the things is that I'm still not convinced on is the sky, which is, I know you doesn't want to talk about the sky because you want to talk about the surface, but the sky is still looking to be very much like as you would see from a spherical Earth. And the second one is I used to look at a lot of planets, and I still thinking that like what we are on is just another planet. Like,
right, but if you consider that the stars rotate around the North Star, they move east to west, and then they reset into the same positions each year. That's why we've had the same zodiac symbols, for as far back as what we can validate.
Yes.
So if the Earth is spinning at all these speeds and vectors at millions of miles per hour through space, never to return to the same spot, and the sky is still acting like a perfect clock.
What do you mean the sky is acting like a perfect clock?
Well, it runs in cycles, and the stars reset back into the same positions each year.
Not like
everything in the sky runs in cycles that reset. So if you're on a globe and you're spinning millions of miles per hour, never to return to the same position. Okay, and the globe side, their only explanation to this is to place the object so far away that you wouldn't notice a change.
And wait. Okay, you said a lot of things at once, but we can engage any of them. So, why do you think that the stars cannot be far away, for example?
I don't know what the stars are.
Yeah, but I do.
You do know what the stars are?
Yes, exactly.
How did you validate what the stars are?
I mean, there are a bunch of different ways to, like... So, are you familiar with... Okay, wait. Are you familiar with light bands? Sorry, I learned this stuff in Hungarian, and it's sometimes hard to translate into English. So the point is that different elements in the periodic table can give off different light, like ranges. And
right, but you're not able to validate the medium that the lights are traveling through in the first place.
But do you know of any medium that are able to shift these ranges of light? Because I'm not. And it's okay. Wait. The medium doesn't even count because these ranges of light are respective to each other. So it doesn't matter which way you shift them. You are still receiving the relative ranges of these light bands, and from that we can calculate back to the what's the process that the star is doing far away that's emitting this type of light.
Right, but look, if I want to be really annoying right now, I can hold you back to the fundamentals of your claim, which is that you can't have outer space in the first place because you can't. It's impossible to demonstrate that it's possible in the first place.
Yeah, but we can make inference. Like, we know stuff that we can do, and we can just interpolate that to other places, and it works out.
Right, but you have to make assumptions. You have to make assumptions that would invalidate the entire mathematical model.
Wait, so no, I'm not saying that doesn't have to make assumptions, but if I experience something here, like with the moon, like we talked about the moon and how I came to the conclusion that the moon is spherical and not flat, and I use the same kind of idea here, and it turns out that the Earth is not flat but spherical, and I just used the same kind of stuff that I used on the moon. I didn't change anything.
No, but it was a direct observation that you were talking about on the moon, being able to see the shadows of the craters. That's
and we
not
can
really
see the same
good
here.
to. Not really. It's not really fair to use that as an example in regards to the stars.
No, I'm just saying that we can infer things without having to go there and check it. Like, if something smells bad, if something smells like shit, I'm pretty sure it's shit. Like, if you see what I mean. Like, if the stars giving off a certain pattern of light that we are only giving from a certain element of the periodic table, then I wouldn't see why that wouldn't be the case.
Okay, let's try something different. Even though you're trying to associate actual spectroscopy with stellar spectroscopy, which is not an apples to apples comparison, let's say for the sake of argument that maybe something is burning hydrogen and helium in the sky.
Yeah.
It still doesn't tell you how far away it is unless you create an infinite distance to it without any such measurement whatsoever.
Wait, what do you mean it doesn't? It actually tells how far away it is.
Okay, so you're measuring angular size, which is apparent size of
I'm not.
a light. You're not. Okay, so
Yes.
what is the size of Jupiter?
I have no idea.
Well, how would you get that information? How would you get that size?
How do I get that size that I have no idea?
Right. You just told me that you do know the sizes of these objects, and now you're telling me you have no idea. No.
I never told you that. I told I know what they
You
are.
didn't just say to me you know the size?
No.
Is anybody else in here hearing the same thing I am? I just heard the guy say I know the size.
I told I know what they are made of, what they are.
No, you don't even know what they're made of. You have to validate that. In this case, you're only going on assumption. You see yellow in the gas chamber or in the spectroscopy chamber in a very controlled environment. So then they say, oh, well, I see yellow from the star. Must be burning hydrogen and helium.
That's not how it works.
Oh, okay. So how does it work? Since you're seeing the same bands of light, the same spectrum of light being emitted by a gas when you burn it in a chamber, why are you assuming that if you see those same bands out in what you think is a second law of thermodynamics violation, that it's the exact same thing? How would you validate that?
Because it's not the exact same light that we are seeing. It's actually shifted in a direction. So we are seeing a different
It's shifted
light.
in a direction.
Yes.
And therefore what?
What we are seeing, okay, when you burn this gas in the chamber, what we are seeing is a pattern of bands. Like not a single light, a very unique pattern, which you doesn't see anywhere else, except in the stars burning that gas.
Okay. Awesome. Show it to me. I want to see the data.
Yeah, of course.
Yeah. And of course, we've compensated for the Earth's atmosphere that we're looking through. We're looking for the sun's atmosphere, the star's atmosphere that you know the composition of, right?
The fun thing.
Wait a minute, don't go back. I just want to make sure that all the data is going to be there. I want to see all the different atmosphere layers of this ball Earth that you think you live on are being compensated for. I want to make sure that all the elements that the light is passing through in the trillions of miles, in some cases, of the star's distance to the Earth is compensated for. I want to make sure that the atmosphere of the star you think is a big burning ball of gas trillions of miles away is compensated for. And then we can go ahead and conclude that these are the same things.
Okay, so why do you don't have to compensate for these things? Do you know why you don't have to do that?
Why not?
You don't have to do that because what we are looking for is not an exact spectrum of light. What we are looking is a pattern of the wavelengths. Like there is a pattern.
So we're not looking for the exact same thing. We're looking for similarities, and then we make an inference from that.
It's the exact same pattern. Like, it's look, I can send this to you, but I can send the whole Wikipedia page. So in the middle image here, you can see the pattern. The middle image. Right? That's the pattern.
Yeah.
And when it goes through these different mediums and stuff happens to it, that pattern...
Well, I don't care about the spectrum. I want you to show me the data from the observations in the stellar spectroscopy. I don't need this. I know what this is. I feel like you're trying to rip me off again. I feel like you've been trying to rip everybody off again. I don't think you're here on good faith.
Still haven't received that apology for the quantum entanglement bullshit.
I'm still upholding
you made up
because none of you was able to disprove me.
You made it up. Holy shit!
You didn't prove anything in the first place. You stacked polarized sunglasses, and then you said this is quantum entanglement. That's an absolute ripoff. And now you're saying, oh well, he didn't disprove me. Burden of proof reversal fallacy.
No, I'm not.
I don't have to do anything. Huh? What?
It doesn't say you have to prove anything. I'm just saying that's...
You said I didn't disprove the thing that you didn't prove in the first place, which is like, that's talking shit. Why are you talking shit?
I haven't proved it. I agree with you.
Yeah, you haven't proved it, so you made it up, and we're asking for an apology.
Why? Because
you made shit up and tried to pass it along as evidence.
No, I never did that.
Why would you bring it up unless you were trying to prove a point? You called it evidence.
I'm not sure, man, what you're talking about.
I'm talking about the fact that you started talking about quantum entanglement and polarized sunglasses as evidence for that, and then you didn't prove your point, even though you were trying to prove it. And I want an actual apology from you saying, I'm sorry, I brought something in here that I didn't know anything about, and I tried to pass it off as evidence for a claim I was making, and it turns out that I don't even know what I'm talking about, and that was a pretty shitty thing to do. That's the apology that I want.
Explanation for why the light cancels.
You didn't explain anything. You called a cause, or you called an effect a cause.
The explanation.
What is the explanation? Explain to me with evidence, with proof, with the scientific method and a valid hypothesis that quantum entanglement is the cause for the reason that you stack three polarized sunglasses together and you can see through them. Explanations don't mean jack without demonstration. It would be akin to me saying the reason that, what is it, Sirius is so flickery at night is because of the unicorn farts that kind of make it shimmer like that. That's my explanation as to why Sirius is such a flickery light. That's my explanation. And I'm sure you wouldn't be settled with that. You'd be like, first of all, let me see that frickin' unicorn. Second of all, I want to see the farts doing what it is that you say it's doing. Good faith, my ass.
Dude, sorry, it just doesn't want to engage with you because you're cutting me off at like the first sentence.
Yeah, I know. Now it's the last bash and the last, escape hatch for people who are dishonest to come in here. Guys just don't want to engage in good faith. Meanwhile, you've already pissed down our backs and gave us, basically causes when they're actually effects and explanations without demonstrations. And we're the ones in bad faith? Yeah, I will cut you off because you're pissing down our backs and wasting our time. Or you could just concede that you don't know what it is that you're talking about and get that apology from you that we certainly deserve and you've doubled down on. I don't want to engage with you either, my friend. Wasting DJ's time, wasting my time.
Why are you so angry?
I'm angry at people who come in here and bullshit us, and you are a bullshitter. Should I not be upset that you're trying to rip us off?
What do you mean, man? I don't get anything you're talking about, okay?
You don't get the fact that you tried to call, in effect, a cause without in an explanation, without any demonstration whatsoever.
Okay, so if you are so good on that point, please explain me why that happens, okay? I'm all
exactly. Now we have a burden of proof reversal fallacy that you just committed. Oh, well, then why don't you tell me what it is? Because you have just told me and conceded you don't know what it is.
You are not allowing me to talk. You are not allowing me to do anything.
I'm not allowing you to talk because every time you open your mouth, there's a fallacy coming out and you're bullshitting everybody. Does that make sense?
Dude, I'm not the one claiming the Earth is flat, so talking about bullshit.
Yeah, and what about that? You are the one that's claiming the Earth is a ball without demonstration. More bullshitting.
Okay, so can we get back to an actual point, or you just want to talk about you?
Yeah, let's go back to the actual point. Where was the Earth measured with curvature? Can you show me the curvature that was measured?
What do you mean the curvature that was measured?
Yeah, you're supposed to be living on a ball. I want to see where the curvature was measured.
What do you mean the curvature that was measured?
Is anybody else having a problem understanding this? This guy sounds like he knows English enough to know what measurable curvature should mean. Where was the curvature measured?
So, for example, radar is able to measure really easily the curvature.
Okay, show me that.
Explain it as well.
It's really simple. Radar is a line of sight, yeah? Radar, it's line of sight. Yes?
Okay.
Yeah.
So, if you doesn't see something with radar, it means that's obstructed. Yes?
We have transcontinental radio signals.
Yeah, of course.
Where's the curvature? Yeah. So how come that line of sight transmission is not being blocked by Earth curve?
No. Wait. So we are jumping so many things here so fast. Transcontinental radio, do you know how that works?
Yeah. They put a tower, they broadcast the signal across the Earth, line of sight, and receive it.
No, not at all.
No?
You're completely
Okay,
wrong.
so how does it work? They don't put towers up and then broadcast a radio signal line of sight across the across the ocean? No. Not at all. Okay, show me. What's wrong about what I just said?
Wait. So what's wrong about what you said is that cross-continental, so when you are going really big distances, what they are doing is they are changing the wavelengths to really long wavelengths, which are able to bounce off from the atmospheric pressure. And it's bouncing back and forth from up to top, and that's how it's able to go further than the curvature.
Oh, okay. So they're aiming them up at the sky. So Marconi, back in the early 20th century, was bouncing radio signals off the firmament or off the sky. That's what you think?
Probably, I'm not sure.
What do you mean, probably you're not sure? Marconi was the first one to do this, that just put a tower up and broadcast a signal across the Atlantic Ocean. There was nothing about bouncing it off the sky. It was line of sight.
I mean, sure, man, I have no idea what you're talking about, but sure.
Yeah, you don't have any idea what I'm talking about. Meanwhile, you're going to say that they're bouncing the radio signal off of the air.
Yes.
To get a radio signal across the ocean, right? Can you show me air reflecting radio signals like you're talking about? Okay.
Yes, you can look it up.
Without begging the question, by the way.
What question?
Do you know what begging the question means?
No, I'm not native in English.
Okay, it's a fallacy. It means you're going to use the thing that we're trying to prove in the first place as the evidence for the thing that you're claiming.
No,
so in this case, when you say that they're bouncing off the ionosphere, the ionosphere would have to be something that exists that we could bounce radio signals off of. So can you show me the ionosphere?
Wait a minute. I want to show you one thing at a time, okay? So let's go back to the wavelengths of bouncing them back from the... that's the first thing, okay?
Yeah, that's the claim. I don't need the claim. I need the demonstration with the evidence doing what you're talking about.
It's hard when you're bouncing around with these topics so fast.
I'm not the one bouncing around. I said, let's prove curvature. You went to radar. Now we're talking about radar. Isn't this you bouncing around?
Okay. So first of all, I came here to understand more about the flat Earth point of view. I wasn't really ready to disprove it. I doesn't want it to disprove it. I doesn't want it to do anything like that. But you are the one pushing. You are the one pushing me towards this direction.
You want to know the flat earther's point of view? No problem. The flat earther's point of view is that we measure the Earth flat, we use it practically, build on it, navigate it, fly over it as flat. It's observably flat, and we use level in our everyday lives to, basically operate. If I hang a picture on the wall, I'm going to use water as level. So 70% of the Earth is water. That means 70% of the Earth is level. Now, you're claiming that water conforms to a sphere. You're creating a tangent point out there at the horizon, which must be at 1.22 times the square root of the observer's height in feet. So when it's not there, you come along and you say, oh, it's refracted. So now we can't measure to it because apparently it's always a hologram. So then we go to radar, where you're making another claim but not demonstrating it, only giving me the claim over and over and over again. And that's kind of where we're at.
Okay, so I linked the propagation. You can read through it. You can look it up. There are citations there. And if you did that, you can come back and say to me, what's your problem with this? Is that...
My problem is that it's just a claim.
Yeah, but you can read it up. All the citations are there.
I'm reading it right now, and it's just claims, not demonstrations.
They are citing.
They're just telling you how it happens, but they're not telling you why and how they proved it.
It works. We are using it daily.
Okay, so now another pragmatic fallacy. So because it works, the claim is true.
No. You wanted to know how we proved it. We proved it by using it.
Yeah, I want to see how you proved this ionosphere and that we're bouncing things off of gas, like a radio signal.
You can call up any like long-range radio tower and ask them how they do it.
What are they going to tell me? Are they going to tell me because it bounces off the ionosphere, and I'm going to ask them for a demonstration of that? And they're going to say, well, it just works, so it has to be true, like a pragmatic fallacy.
Wait. So you are asked, how did we prove it? Yeah, right? That was your question.
Yeah.
We proved it by using it.
I'm asking you to no. You don't understand. I need to see the ionosphere doing what you're talking about. What is the ionosphere?
No, okay, like we can skip the ionosphere. All we know that the radio waves are bouncing off of something. Okay, we know that because we are using it.
What's something? All right, you say something.
Do you know why we know this? Do you know why we are certain of this?
That's not what I'm asking for. How come you're not getting this?
It's because it's more complex than you are making it out to be.
Yeah, everything so far that we've talked about it's more complex, and then you don't actually go into the complexity because I know that you don't know it.
I will go into the complex things. Okay, so this effect that we are talking about, this effect of bouncing back, only works with like certain wavelengths. If you are using different wavelengths, it's not working. You can try it; it's not working.
Yep.
So that's why we know how it works because of the wavelength.
What? That proves what?
That the math that we are basing it on is correct.
The math that you're basing it on. So,
yes.
So the math is correct. What is the math?
I'm not certain of the exact math because I haven't did it in like the last 10 years. But if you want it, I can come back and show you the exact math for this exact thing.
Okay, so great. The math works. Terrific. What if I could describe what's happening with math after the fact? Could I do a post hoc calculation or a post hoc formula? Okay, so the math doesn't prove anything then is what you're telling me because I could just make up the math to describe it.
Wait.
Oh, shit. Right.
Why does it matter if the math was first or the math was... Why does it matter when the math was...
Because math is just a description. It doesn't tell me how it works or why it works.
What do you mean that it tells you exactly how it works? That's the math.
So the math describes. What is the math describing?
How does it working exactly?
Can you give me the formula for what is the mathematical formula for the radar that we're talking about?
Like this effect? You want to?
No, I'm just talking about the radar itself. Do you think you can get some math to describe the radar? You said that this happens from radar. We're bouncing radio signals off of an ionosphere. You said.
There is no math for. You don't know how math works?
Now there's no math for it?
For radar? No.
Oh, so this is insufficient to describe the effect that you're talking about? There's no math to describe radar?
But I'm saying that radar in itself has no math. Like things doesn't have math in itself. Like effects and phenomena have math. Like how they work, that has math. But radar in itself doesn't have math. How radar works has math.
So phenomena in nature have math. So when I see a tree growing, what's the formula for that?
For a tree?
Yeah, tree growing. You said things in nature, or effects in nature, or phenomena in nature have math. So okay, the tree grows. What's the math for that?
For a tree, it depends on the tree, I guess. You can do research on it. Like you can do like mathematics with biological systems. I don't know what.
No, I'm asking you for the math on the things that you're claiming, and then when I ask you for the math,
so
the things that you're claiming, you go, oh no, it's insufficient. Like the radar. Show me the radar. Show me the radar in math.
You want the math for this radar effect exactly? Is that correct?
Yeah.
Can you give me a moment, like 5 minutes, for me to look it up?
Sure, go ahead. I'll be fascinated. This will be fun.
What do you need to get this? Like, do you need a picture? Do you need a link? Do you need a citation? What do you need? Or I just posting the math here and you are accepting it and doing the calculations by yourself? Or what?
I need the mathematical description, like you said, for radar. No, radar.
What do you mean radar?
Well, you said that the math works when we, apparently bounce things off of an ionosphere. So I'm assuming that you're talking about radar, since that's where you went in the first place.
Yeah, but radar doesn't have math. How radio waves work has math, but radar doesn't have math. I don't get what.
So how radio waves work? So are you talking about like the Hertz frequencies?
Yes.
Okay. So you have a number associated, that wavelength pattern.
Yes.
You have a number associated with that. So you've given a convention, a number, to describe a wavelength.
Yes.
And that's it. Okay.
What do you mean that's it?
What,
no, there's like.
What does that help us do? What does that help us do? Giving a number, a value to something.
Like it helps us predict what it will do. Like okay, wait. Just to get the basics down. Okay, so math works, right? We can agree.
No, not always. No, math doesn't work always.
So, for example, like if I'm 50 kilograms and there is a guy who is double that, and if we both jump from the same height, he will exert more energy, right? And you can calculate that.
Okay. Can you show me -9 apples? Can you do that?
Yes, of course. I will just bring in 9 apples and eat all 9 of them.
No. -9. -9. I want to see -9 apples in reality. Can you show me -9 apples in reality?
Yes, I'm eating 9 apples. That's -9.
Bro, honestly.
Like, I don't get the problem with that.
Is this where you've abandoned? So this is where you've gone into just being a total piece of shit. You're eating apples, therefore it's -9 apples. I want to see -9 apples in reality, please. Not you eating. I mean, if you mute me, I kick you out. That's how it works. Okay, you're done then.
I'm not done.
I'm not going to have people pissing down our backs with -9 apples being you eating them. You know what I'm saying?
No.
So if you're going to mute people, I will mute you. That's how it works. So you're not going to mute me. You're not going to tell me that you eating apples is -9 apples. That's silly. Just because you know that I basically showed you that math does not always work and that conventions don't describe things perfectly, we're not going to say me eating apples is -9 apples. Capiche? Are people not aware when they're actually just totally wasting your time and treating you like an idiot? Anybody else want to talk to Taylor? Tajlor? I don't know how to say it.
Taylor, it's Taylor. I just it's intentionally mistyped. It's something that stick with me from like earlier years, childhood. But I still want to talk to you, but I don't want you to just call me shithead and asshole and that kind of stuff. It just feels bad, man.
So you're saying that when somebody insults your intelligence, that's offensive?
No.
Kind of like me asking you to show me -9 apples, which is a very simple question, and you know what I mean. It cannot be done, and you go to the lengths of saying, when I'm eating them, it becomes -9. That pretty much is a big old slap in the face. That's shitty behavior. Wouldn't you agree?
Okay, here is a different, like, if you want to talk about negatives, I can bring different point of views. Like,
yeah,
for
great.
example...
Okay, a different example. -10 trucks.
Oh, that's good. So there is this guy who wants trucks. And has, I don't know, he has apples. And you are saying to him, like, okay, give me your apples and I will bring you 10 trucks. Now you have -10 trucks because you are owning that guy 10 trucks. It's a concept of negative.
I used to have 10 trucks. How many do I have now?
I don't know.
Yeah, see, this is how you are a piece of shit, right? Because you won't answer the question honestly.
But, sorry, what?
You heard me.
What was
your
question?
I had 10 trucks. Excuse me, I'll ask it again. It was very simple.
Okay.
I used to have trucks. Now I gave them away to somebody else because of the apples, right? In your dumbass scenario. Now how many do I have?
You had 10 and you gave all 10 to that guy, then you doesn't have any more trucks, right?
Yeah, would that be 0 or would that be -9 or 10?
0.
0. So -10 still doesn't exist.
Yeah, but if you are owning him 10 trucks and you don't...
Yeah, you're talking about debt, which is also just fiction. Debt does not exist. Debt is a concept.
Yeah, I agree with that. But
yeah, so it doesn't exist in reality, which means math is insufficient to describe things, especially when they don't exist. So I can give a number, or even a negative to a number, and then say, this is the problem, or this describes a certain thing. But in reality, it doesn't actually exist. So math is insufficient to describe a lot of things, and it certainly does not deal with how or why propositions in nature.
I agree with you completely.
Right.
But
so in physics, they use a lot of math, and that math, those conventions, are insufficient a lot of the time to describe anything. So I don't want to hear about maths. I want to hear about cause and effect relationships in the actual reality that we live in.
Okay, so this is how math works, if you are interested about that. Or I can give you the cause and effect for the...
No, I don't want to keep talking about math. I want to talk about the fact that you claimed we can measure the Earth with radar, and you have yet to do that.
I mean, we can do that, but like only with like certain frequencies. Like, doesn't all frequencies produce the same kind of effect? And for you to understand that, it's very important that you understand how the math works behind radio frequencies and how they propagate. And
how come you can't do it in actual reality? I don't need math. Why don't you just show me in reality? What's the problem with reality with you? How come everything has to go to math?
Because that's how you show things. That's how you work things out.
No, you demonstrate things in reality with reality.
No, like that's not.
No?
Yeah.
So you don't demonstrate cause and effect relationships in reality with...
So what happens is that we work out the theory with math. That's what the theory is.
No, you don't do that. No, we don't do that. You do that, and then you get ripped off. We don't do that here. We want to see demonstrates in reality.
So when you are having a theory, you can like do tests on it. Like,
is it a scientific theory?
It doesn't have to be. It can be any theory.
Oh, so this is just a colloquial theory. So this is like a thought experiment where we're not dealing with things that exist in reality, and we just kind of do it in our heads. We use math, and we describe conventions and numbers to things that don't actually exist, and it all works out in the end, right?
Why are you so aggressive towards me?
Why are you even bothering with why I'm so aggressive when I can just ask you a question about the things that you're claiming and you can answer them concisely instead of making things up or going to thought experiments? Why are you even bothering with my attitude? See, my attitude wouldn't be like this if I was getting straight answers from people with things that exist in reality and demonstrations that exist in reality, and they don't want to give them to me in reality. They want to go to imagination land and concept land and abstract land.
So, can I finish my sentences maybe sometime?
Do you want to start making it about me and my attitude and just give me the demonstrations in reality that I'm asking for? Or do you only want to live in the abstract?
You can do this stuff. It's what I'm telling you. You can demonstrate the curvature with radio waves.
In reality, right?
Yes,
okay.
In reality, you can do that.
Let's go.
The problem is that you said that radio waves can travel further than the curvature. And you are completely right on that one. But those radio waves that travel further than the curvature are not traveling in a straight line.
Okay, just show me that they're not. Just show that to me.
How can I show that to you? Do you see radio waves?
You just made the claim that these are apparently taking some kind of arced path or a zigzag or something like that. So just show me that they're doing that.
What form would you like me to show that to you?
Well, I want you to demonstrate that these radio waves, that a second ago you said you couldn't demonstrate it, but now that you say that you can, I want you to show me in reality how you can demonstrate that these radio waves are taking a curved path. For the distances that we're talking about, we'll go with Marconi, right? 1901, transatlantic radio.
Okay, can I look up that Marconi stuff? Marconi.
It's in the side chat. There's a whole article about it in there.
Radio frequency. So what was the radio frequency he was using?
I don't know.
Don't you think that's important?
Why would I care?
Because like different wavelengths act differently.
Okay, do they follow arced paths along the surface of the curved Earth that you haven't measured yet? Are you going to beg the question again?
I mean, they follow in terms of like they reflect from the atmosphere back.
Oh, so they're aiming these radio signals up at the sky.
No, that's not happening.
Oh no. So what direction are they aiming these radio signals that you say take some kind of zigzag or curved path?
The problem is that aiming is a bit different with these radio waves than what you would perceive aiming like a bullet. Because they're not really aiming that at one point, they are aiming them into more like a direction, like it's like that 180 angle direction, and that way goes out. So these wavelengths, just give me a moment. It's complicated stuff, and it was so long ago that I done these things. So I'm a bit slow on them. I wasn't expecting this much like numbers and research flowed out of me. I was more here from the flat earth stuff, but I'm willing to do this. You just have to give me time to look stuff up and actually look at the answers that you're asking for. But I'm all up to them. I just need a bit time. So what we are talking about right now is Marconi, right?
Mm-hmm.
Would you give me 5 to 10 minutes to look up all the stuff that I need and come back with why Marconi's experiment worked?
Totally, man. I mean, if you want to explain post hoc how it worked, I mean, that's the beauty of this. Do you think it's going to be evidence if you figure out the frequency? Just think about this for a minute.
Yes.
You figure out the frequency and you think that's going to help you. So what you do is you rewrite history and you go, okay, so this transatlantic radio transmission, it worked because of whatever story that you were told, whatever they made up, right?
But
and then
when they did this, when they did this,
okay, I'm just asking you. We're going to get back to the same point I was asking you before, which is you're going to take some kind of abstract formula, or someone's going to tell a story that, yep, it turns out that Marconi and the frequency that he used bounced off of the ionosphere and actually it wasn't a line of sight situation. It was a bouncing situation. It's just a story and it's just a claim, and there's still nothing to support the claim.
Wait, how do you want me to demonstrate that? Do you want to build the radio itself? We can do that. If you provide the money, we can build a radio and do it for real. But I don't
Yeah,
know
no
how
problem.
else.
I mean, this is your claim, so if this is your claim, I think you should pay for it.
Yeah, but I doesn't have the money for it, sadly.
Oh, so what you're saying is this is not going to be demonstrated by anybody.
Yeah, you can demonstrate it. I mean, what we could do, we could call up radio stations and ask them to show us a presentation of how they work.
Uh-huh.
But I don't know. So my problem here is you want me to demonstrate stuff, but I don't know what kind of demonstrations do you willing to accept?
Well, it sounds like your standard for evidence is really low. Like you're okay with somebody just telling you a story and then you never ask questions afterward, especially if there's math involved. Yeah, if the math is involved, then it should be fine, right? So no matter what explanation they give you, they just give you a convention or a formula mathematically, and you go, well, there it is. Totally proven. I mean, there's a formula right there.
Wait.
It's gotta be right.
I did my own part of experimentation back in the day at
Okay.
roughly, and I know how radio waves and light waves work, and I'm able to like infer that information and add to it. Like I know the basis of how they work, and then I will be able to just add to it. Like for example, with the planets and the spectroscopy.
Uh-huh.
Okay,
yes.
I know that works because the basis of those experiments I did myself. Not the actual experiment, but the basis.
So you just got a cursory education on some of this stuff, and you may have been in a lab, and you may have even seen one of these spectrometers in action.
No, I never seen a spectrometer in action.
You never even saw a spectrometer?
No, never.
So you were just told a very cursory level about this, and you were educated. Someone gave you a good amount of education, probably for a fee.
I actually worked with radio.
Okay, great. So with the radio that you were using, how did you tell that it was bouncing off of the ionosphere?
It was really easy to tell from the wavelength.
So wavelength equals bouncing off ionosphere. Did you aim the transmitter?
I can give you a really good example. Like from certain wavelengths, for example, the wavelengths that are like small walkie-talkies are using. If you are standing behind a building, you won't hear shit because the building is blocking the wavelength. But if you are using longer wavelengths, you can hear each other even if there are a building or like huge like hills between you because it's reflecting back from the atmosphere.
So it's going all the way up to the ionosphere.
Yes. And
bouncing back down. How would you prove that?
What do you mean, how would you prove that? So in one case, I can hear the other guy, and the other case, I cannot hear the other guy.
That doesn't mean it's bouncing off of the fucking sky.
Why? I don't get that.
What do you mean, why? That's affirming the consequent.
But
if wavelength, then they hear me. Hear me, therefore wavelength. It's affirming the consequent.
Yeah, but it's like pretty obvious that what else could they happen? Like where does it bounce?
There you go. That's a good question to ask. What else do you think it could be?
Like it's pretty obvious because if I go inside the building, that it's not working.
That doesn't mean anything. It's
not working.
Let me ask you a question.
From the sky.
Are X-rays a certain frequency of light?
Wait, X-rays?
Yeah.
I don't think so.
Okay, what is an X-ray?
I have to look that up, but I think that's like alpha or beta radiation.
So it is some sort of radiation. It's a frequency,
sorry,
right?
You are right. Sorry, my bad. X-ray is light wave. Okay, sorry, I just mixed it up. Okay.
So that particular wavelength of light can penetrate through skin and bone.
Yes.
Help you figure out whether or not you've broke your frickin' arm.
Yes.
So why are you assuming that because of a certain frequency, this signal is bouncing off of an ionosphere that we have no evidence for, and then coming all the way back down to hit the receiver when it could just be passing through objects?
Because it doesn't go through objects. Okay, if you put it inside the building, it's not working.
Great. So we eliminated that possibility. What are the other possibilities, do you think?
What do you mean other possibilities?
I mean, is it possible that the strength of the signal could be bouncing off all kinds of other things instead of going all the way up to the sky and all the way back down?
Yes.
Oh, okay. So there's another possibility.
Yes.
What is another possibility? There's a lot of possibilities other than this thing just going up to the sky.
Yeah,
So instead of us affirming the consequence,
wait. When I'm sending a wave several kilometers, what can it bounce off of?
A lot of different things.
From the sky, and
why would it be the sky? You haven't even shown me the ionosphere yet. But you're assuming that there's an ionosphere and that this radio signal is bouncing off of an ionosphere.
Look, my problem is that it bounces off the ground, right? The ground is there; it can bounce off from the ground. It doesn't bounce off the ground.
I suppose it could. Sure, why not?
Yeah.
Okay.
So we know that happens. Okay, we can test that. We know that happens. It goes up. It's going upwards. What does it bounce off of?
I don't know. Does it bounce off of anything?
Yes.
What does it bounce off of?
The sky.
Okay, so the sky is okay. So that we know that these radio signals bounce off of physical objects like the ground, the earth, the dirt. So then it bounces up. Do you think that it's hitting air or hitting a physical object?
No, it bounces off from air. We know.
Okay, so now you can demonstrate to me that these radio signals are bouncing. Okay, how do we know that?
Because it only works with certain frequencies. It doesn't work with
okay. Okay, so show me
specific frequencies.
Great, no problem. So you can show me in a lab that we are bouncing this frequency off of air to get the radio signals that we need.
It might be hard, but it's possible to do that in a lab.
Well, just get it for me. You just told me that this is how we know. So all we need is the experiment where we bounce certain frequencies of light or radio signals off of air to get it to bounce in a certain way that you're describing. No problem. Get me that experiment.
We can do that.
Okay, get me that experiment.
It's hard. You need a lot of money and a lot of preparation. But
get me the experiment that has to have been done to do the thing that you're talking about.
Okay, sorry. Don't have to be angry all the time, man.
I'm asking you for something 3 times and you're like, oh, it's too difficult. I'm like, no, this should have been done already, right?
I misunderstood you. I thought you wanted to do the experiment.
No, I just need to see that somebody has bounced these radio waves off of air to get the effect that you're talking about.
One moment. I don't know the experiments by head. I have to look them up, okay? Okay, I found the exact paper that is describing the experiment and how they did it. I think this is fairly explaining the topic. Just let me know the issues you are having with this. And it actually tells you how to repeat it. So if you want to do it yourself, it's all written how to repeat the experiment.
Okay, where is it?
I just linked it in the slide chat.
Yeah, no, I know that. I want to see in this paper what the actual experiment is.
Dude, it's fairly complex. It's not just...
Motherfucker, don't start that shit with me. Don't start that fairly complex bullshit. I want to know what they did.
Okay, you are just being mean to me again.
Yeah, I'm being really mad because so far, every time I've asked you for something, you just answer with, it's very complex. I want to see the experiment. Don't elephant hurl this nonsense, apparently to you, evidence in here and not give me the context and the experiment and what they did as it pertains to the claim that you made. I'm sick of this shit with you.
Can you repeat the question?
Holy cow, you don't even remember the question? You gave me this paper?
I just... No, not that one. The one that before you got really angry.
Where is the experiment to prove the claim that you made?
Not that one. Like within this paper, where
that's the most important question that we need right now answered. Is you made a claim that they're bouncing radio signals off of air to get it across the Atlantic Ocean. Yes. I want to see the experiment where they bounced that specific radio frequency off of air to get the effect that you are claiming. Okay, where is the experiment? Where is it? Don't elephant hurl that shit in here and get me the actual paragraph or the line or whatever it is to explain what they did.
You cannot just remove paragraphs. It's the whole thing.
Okay, so you did an elephant hurling fallacy is what we call this.
Sorry, I read through like half of this stuff and it's all written in there. Like, I don't know what else do you wanted from me. This is how they done.
I want you to show me the actual experiment. What did they do? Why is it so hard, dude?
Man, I'm not sure.
You don't know, do you? I want to hear out of you. You don't know. This is the second apology we have come to us. You don't know. You elephant hurled this gosh damn paper in here. You don't even know what the experiment is. And so when I asked you for it as a cop out, you go, oh man, it's very complicated. You don't know what's going on, do you?
I'm not sure what you want from me exactly. So what they did
ignorance. I don't know what they did.
I took the time and read the introduction.
Okay, you just tell me what they did.
Do you understand the experiment, Taylor?
The experiment that they did?
Do you understand what's going on in the
mostly
paper that you've read?
The exact details of the experiment is beyond my understanding, but I'm mostly understanding the social science behind it.
You for admitting that. So why are you posting it when you don't even know what the hell's going on? It's just
I understand the surface level stuff, but not the every detail of it. Is that a fair assessment? Like, you can understand.
No, it's not, because you can yet to describe to me even a slight detail of what it is that you claimed is in this paper and how they proved it and what the experiment is. You haven't even scratched the surface. You just elephant hurled this whole paper in here and thought that it was going to bail your ass out and I wasn't going to ask for the details. And now that you've told us that you don't actually know the details, I guess we can just throw this out.
No, wait. What you wanted for me is a way to do this phenomenon in a laboratory, which is a very, very complex thing. Like, you doesn't just do...
There we go, back to the complex. I don't need your complex appeals. I need you to show me how they proved that they're bouncing radio waves off of air as you described.
Okay, I'm sorry. I presented this without reading the whole thing beforehand because I thought you are able to do some research for yourself, but that's not something that you
This is your claim. This is a burden of proof reversal. This is your claim, and now you're asking me to do the homework that you didn't do to prove your claim.
Sorry,
That's a shitty thing to do to somebody.
I doesn't come here to teach you stuff. I come here to teach me stuff. Sorry.
You came here to make you made a claim, dude. I don't care why you came here. You came here and then you made a claim. I asked you how we measured the curvature, even though we experienced the Earth as a flat, motionless plane.
Okay,
and you said, no. Curvy. Okay, radar. And then I described to you that we have line of sight transmissions across the Atlantic. And you go, no. It's because we bounce radio off of air. I say, prove it, because you made a claim and then you didn't support it. You elephant hurled. That's where we're at. Everybody here heard it. Everybody here is witness to this. That you're wasting our time for reasons I can't figure out.
How many hours has this cat been in here?
Too long.
I don't know.
If you don't have any claims to support, just don't make any more claims, bro. Don't make any more claims. You will not support them, guaranteed. Because that's all we've dealt with.
We can do
so
it.
I've already given you the thing that you look for. The Earth is, by demonstration, flat and motionless. You don't have any curvature measurements. You certainly don't have any radio waves bouncing off of air. So until you give me anything to the contrary, the Earth is flat. Yeah, I know you can, even though you can't demonstrate it. I don't want to hear about all the things that you can. Those are baseless assertions. I'm not going to dismiss them out of hand.
If I make you a step-by-step explanation of how to do this.
No, I don't need a step-by-step explanation. I need a demonstration. Your explanations mean nothing to me. I want demonstration only from this point forward.
How do you want me to demonstrate this? Just give me the way.
I don't care. You make a claim, you demonstrate it. I'm asking you to demonstrate it, not go ahead and elephant hurl a paper in here that you don't understand. I want demonstrations of radio waves bouncing off of air. That's what I want.
5 pages long, 10 at max.
Yeah, great. So then you can go ahead and go read it, and then you can explain to us the experiment that was conducted, the naturally occurring phenomena, or how they engineered, whatever they engineered, this experiment to show that they can bounce radio waves off of air, most specifically the ionosphere, in this case, so you can support your claim. But I'm not going to go do your research project for you. I'm not going to read this elephant hurl. I'm not going to have you reverse the burden of proof on me. I'm going to have you demonstrate the thing that I wanted.
So I already stated it's my bad. I'm sorry. I'm sorry for trying to. You are right. I shouldn't have just posted in. I still think that the answer to your question is within this research paper, but I have to look more closely. It's my bad. You are right. You're completely correct. I give it to you. No problem.
Thank you.
Oh, do I catch right that he posted a big, long research project for you to read that he hadn't really read himself?
Yeah, but it's okay. He apologized for it. It's under the bridge. We're not going to worry about it.
I was just asking. I'm not judging. I'm just asking.
Right, no problem. So he may later go on and read this, and he might just prove me wrong. So far, I have not had anybody demonstrate to me that they're bouncing radio waves off the ionosphere. Have never been demonstrated. It's usually just an assumption, or it's a claim that was made, and they repeat it.
That's not what you asked for. Sorry, that's not what you asked for.
They made up that excuse.
I didn't ask for you to demonstrate radio being bounced off of air, as you had claimed. I didn't ask for that.
No. Wait, you're saying a different thing again. So what you're saying is that you want me to demonstrate bouncing radio waves off of ionosphere.
Well, that would help, but I'll take air.
You said in a lab, and you cannot do that.
Yeah, no, I'm talking about. We will start at the beginning where they just bounce radio waves off of air in the way that you described. The next step is to see if that correlates to something called an ionosphere and how we would prove that. See, the first step is just to show me that it's even possible what you're talking about. The next step is to figure out if it's happening in the way that you're describing.
It's simple to do the experiment. You just put the gas that exists in the ionosphere. You put it in a container, and you put a radio signal transmitter in the same container as the gas, and you will see that there is no propagation because of that
That's
gas.
incorrect. That's completely incorrect. The problem is not with the gas. The problem is with the distances and the distances and the wavelength distances are much larger than what you can do in a lab. Like you can bounce off radio waves from air pressure and a lot of different things in a lab, but to do the exact same things, you need much vaster distances. You cannot do it in a lab setting. There are no large enough lab to do the exact same thing what's happening outside. So that's why this is a tricky thing, because
how are you able to validate that it's bouncing off specifically spherical gas?
It's very easy if you block the upward going wavelengths. Like if you block the upper side of the antenna, then it doesn't reach the destination.
How do you know what's at the destination, though, in the first place?
What do you mean, how do you know what's at the destination? So if I talk into the radio and it doesn't block off the top side, it will bounce off the sky and reach the destination. If I block the top side...
Right, but how do you know what's up there? How do you know there's
I don't know what's
spherical
up
gas layer up there?
I have
so
no
why
idea
are you assuming it's a sphere in the first place? On a sphere.
It's a sphere. I never said the word ionosphere, or I wasn't the one saying it first. Seizwu said it first, the ionosphere. I never mentioned the ionosphere. All I said is that it's bouncing off the sky. I never said sphere or anything like that.
Which part of the sky? I mean, you were saying it's due to density,
no idea.
But the air's more, it's less dense as you go up, so...
Yeah, it's the density change, exactly.
Do you know that excuse was made up after the Marconi test? When Marconi sent radio signals...
No, I'm not... I didn't know that one.
No, they made up that excuse that radio signals...
Yeah, but it's working.
Bounce
like,
from the ionosphere because the Marconi could transmit signals till 10,000. How much was it? 1,000. I will check it. Yeah, it was 10,000. 2,000 mile for the first attempt, and it worked. They received the signal, and he transmitted the signal horizontally. He didn't check for any bouncing and the angle of bouncing, because you have to have a ricochet from the sky till that receiver that you have in this in specific place. They never checked for any ricochet or made for an angle, precisions for any type of angle. He just shooted the radio waves horizontally, 2,000 mile first time, 10,000 mile second time. So for them, because they know that the radio waves will propagate horizontally on a plane, so they made up that it will just ricochet from the sky, because if it goes just in a straight line horizontally, it will, if it's a globe, it will escape the surface.
Explain me why it only works with certain frequencies and doesn't work with others. Like,
I'm sorry?
If it's just traveling horizontally, it should work with all frequencies, right?
The whole what?
Frequencies. Like different frequencies of radio waves. Not all of them bounces back off. So certain wavelengths are not traveling far enough. Why is that happening?
We know that the certain wavelengths won't travel that far. Just for example, light waves won't travel that far in atmospheric, in normal atmospheric conditions. They will degrade, and like light, the radio waves are submitted to what's called the invert square law. So they will decay on certain distances, and not all the waves can go through some obstructions that you have in the atmosphere
but the
around
problem
you.
is that from what we are measuring from these lighter wavelengths, the distance is not enough for them to fizzle out. They should be able to go much farther, but they are not going. So it's not the case that they.
It is a problem with the propagation of that specific signal or frequency of waves.
No, it's the other way around.
Still, we have radio waves that can go to 10,000 miles.
Yeah, but it's the other way around. There is a very specific range of radio waves that can go that far.
Yeah, it's because it has its own specific potential or something like that that can help it travel more distance than the others. For example, like a wave in the beach, a big wave is not like a small wave that's dependent to the frequency of the wave. A big wave will travel more distance than the small wave in the water.
The difference is that
sound also, if it depends to the frequency, so some sound waves won't travel that much as other signals. But
in your case, like the energy of the wave is correlated with the distance it can cover. But in this case, it's not correlated. If you're going higher energies, it won't work. It doesn't go farther. It actually doesn't go like as far as the lower energy.
Yeah, because it's not the same medium. It's not water. You're working with another type of medium where the propagation of those type of waves are happening. I won't talk about any specific thing, but the propagation is not the same. Like, for example, water expand in low temperatures and contract in high temperatures. So
but in general,
opposite to the other elements.
In general, with radio waves, what we are experiencing is that the further you go, they die off relative to their energy.
Yeah, okay. But if you get the specific frequency that can travel more distance, yeah, you will have the possibility to let that frequency or that wave travel as long as you want. Like, for example, 10,000 miles, where you had to create an excuse. Wait, guys, it's not like that. It's just bouncing from the sky.
When we measure these specific radio waves, they die off the same way as any other radio wave. So they are not special.
Okay.
Like, if you just put up different listening devices in 500 meters, 1 kilometer, and so on, you will see is that these light waves are dying out relative to their energy. Like the small energy ones die out faster and the large energy ones going further. But then there is the specific wavelengths that are able to travel much, much further than any other wavelengths.
Yeah.
And why is that?
I don't know. That's the property. Is it a property of that specific way? Maybe.
Like the theory
it's an
behind
attribute
it,
in that specific way. But that won't help you.
Why?
We already reached 10,000 miles using radio waves. So even if you have some radio waves that won't reach those distances, that's the problem with that specific radio waves.
It's and the other way around.
Radio waves,
most of the radio
how
waves
the radio waves behave. That's a problem dependent to how the radio waves behaves and dependent to that specific way that can't reach long distances.
Yeah,
it's not a problem with the we already did the test with the specific radio wave signal and it did work. It traveled long distance. So it means that we have signals that can travel long distances.
Yes.
It's not a problem. That's not a problem.
Yeah, but the problem is that most of the frequencies doesn't do that.
Okay.
But why? How that can be?
Because it decay over the distances?
No, they don't.
Loses
It's shown that they
over the
don't decay.
distances?
Like, you can easily show that they won't decay over the distance.
Oh,
Like,
if they are
they
not
can go much
submitted,
further. They can go
they are not.
much further.
No, I'm talking about the radio waves that doesn't go very far distances.
But they can. It's shown that they can go farther.
Okay.
It's just, for some reason, if they are traveling in the Earth, they just cannot. But if they are traveling in like different, like if you shoot them up in the space, they can travel much further, but not on Earth.
That's a test in fantasy. You never did the test of radio waves in space.
Yeah, we did. We bounced them off the moon.
No,
we bounced off radio waves from not radio waves, but light
back
waves
to the
from the
question of saying the question and assuming distance to the moon and that the moon is in outer space.
No, I'm not assuming distance. It's just we did that.
You don't know what medium it traveled.
Okay, wait. So if I do a measurement of radio wave decay, like as I said earlier, 500 meters, 1 kilometer, and so on. If I do that with a radio wave, can I infer from that how long that radio wave will reach?
Can you what?
So what I'm doing is I'm setting up every 500 meters, I'm setting up a listening device. And I'm sending radio waves in different frequencies. Can I calculate from that how long those radio waves will reach?
Maybe if a wave will stop reaching a certain receiver that you have, you will know that it stopped in between the two, or just stopped.
No. It's not stopping. It's just the strength of the wave. I can get the strength from the wave. How strong it is when it reached the listening device.
I don't know. You have some type of devices that can help you measure the strength of the wave when you receive
can. It's called a voltage meter.
Nice. So you can. There you have the answer.
Yeah.
Now I don't know why you were asking
the problem is we are doing this. Okay, we are measuring how long or how much decay is there with the radio waves. But then when we are trying to send them over a certain distance, only specific wavelengths will go further, and the rest will just stop.
Okay, that's a study, nice study for radio waves that lead you to that answer. That only certain radio waves will be received in that specific high or far distance, and the other will not. Nice. That doesn't have anything to do with the topic that we were talking about earlier. Like I told you, we already used those. We already used those radio waves that can reach far distances, like for example 2,000 miles to 10,000 miles. Marconi did it, and we could receive the radio signal on the other side where there is the receiver, 10,000 miles, and it worked.
Yeah, but so my suspicion,
the excuse is there was no repeater in between.
Wait. Can I ask you something? So, can we agree that what Marconi did is only possible with certain wavelengths? So you cannot do it with any wavelength. Can we agree on that? Or that's something that you're against?
Yeah, I agree. No one talked about that.
No. What I'm talking about is that there are certain wavelengths that go that distance, right?
Yeah, we know that. Yeah, we know that.
Do you think that
I never said, for example, that he sent a laser and it could reach that distance? Oh no.
Okay, so do you think
so I talked specifically about radio waves and a specific frequency of radio waves.
Okay, so do you think it's a coincidence that they sent that wavelength, or they knew that certain wavelength will travel that far?
I think they knew.
And how do they knew that? Like,
who knows? You can ask Marconi. Die and go to hell with him. Ask him and come back to us if you can.
So, like, you get my point here. They somehow knew that only these specific wavelengths will travel this far.
It's already irrelevant to the topic. Yeah, they already knew. They got that sorcerer who told them, "Oh, look, that those type of radio waves will travel 10,000 miles and will debunk the fucking globe." So the globers will just cry about something else, and forgetting that radio wave signal traveled horizontally from the surface 2,000 miles first attempt, 10,000 miles second attempt. They were all worked first test. Yeah, they found it in the Bible. Jesus told him or something like that. It doesn't matter. Yeah, they used radio waves that can travel long distances, and they received them 10,000 miles, the maximum for the test, debunking the globe, for letting the globers come with stupid excuses like radio waves, those types that Marconi did predict, and we don't know even how, like you are doing now with the excuses. We even don't know how we predicted that those type of waves will go that far, but still we know that it bounces on the ionosphere. What?
Yes. So all I just wanted to tell you is that they knew ahead of their test that those certain frequencies will travel further away. So it's not something that they made up after. And I'm not talking about like the like reflection stuff or bouncing stuff. Well, I'm just saying that they knew beforehand that those wavelengths are special.
Yeah.
So it's not something that they just like realized after. They already had a working model that described them, that those waves will go further away.
Yeah, no one said that they realized that after.
Yeah, but how did they knew before the testing that
Tell me.
So my idea is they knew it because we know how those like electromagnetic waves work. We know a lot of like science about them, and we were knowing those even like in Marconi's time, I assume.
Mm-hmm.
And they were able to like infer these models and make calculations based on those.
Mm-hmm.
To know how to send these wavelengths so far away. Would you agree with that?
So he knew that he will just send a radio wave in the direction of the receiver horizontally. And with coincidence, it will bounce it will bounce horizontally. You put the sheet of material horizontally, not calculating for any angle toward that ionosphere. Listen, but that same horizontal the direction worked for 2,000 mile and 10,000 mile without any correction for the angle.
That's
the
not
two
how radio waves work.
receivers were in different distances.
You were talking about C waves earlier, and what I want to point out that the sending horizontal is not how radio waves work. Like when you throw a rock into the lake, which direction does the waves go?
Horizontally?
No, like
horizontally. It will go vertically.
It will go like everywhere, like
horizontally.
all directions.
Horizontally.
What do you mean
horizontally? No. Horizontally. When you create a wave, when you throw a rock, it will make circle, horizontal dinner plates like they are getting bigger and bigger, and they are circular, horizontal level. They are not vertical. You can't have have it vertical or create that circular wave in a cascade where water is vertical. You can't create that circular wave in a cascade where water is vertical. You can create that circular wave when you hit water with your hand or a rock only in a horizontal surface of water, like in a lake, in a pool, in a bucket of water, even in a cup of water, but that the surface is horizontal and you never see those waves going to the bottom. You just see them in the top going.
Okay, but we are agreeing that when I throw a rock into the lake, the waves are not going right, they're not going left, they're going all around the circle, right?
Yeah, I'm creating horizontal circle.
Yeah, it's the same thing happens when you send radio waves.
Creating a horizontal circle.
No, they go all up, down, right, left. They are going three-dimensional. Yes.
No, that's your assertion. You made an analogy with the water. If you hit the surface of water, the waves that you will see, they are in a circle, horizontal circle.
Okay, so
not
when
all directions.
When I turn on a light bulb, which direction does the light goes?
When you turn on the light bulb, you're talking about the light?
Yes, because it's the same as radio. It's electromagnetic waves, right? Just different frequencies.
Yeah.
Okay, so when I turn on a light bulb, which direction does the light goes? Right or left, or up or down? Or is it horizontal? Like it stays horizontal, right?
Light and dependent to the light bulb, because you are using light bulbs, not radio wave transmitters, which is
they are working the same way, man.
No.
What do you mean no?
The radio wave.
You ever heard of a flashlight? Just points in one direction, man. Spreads out a little bit, but I mean, it's just still going in the. It's not going to shine light behind you.
Is that happening? Is that happening because the stuff that's emitting the light is only sending it forwards, or because the rest of the part is blocked by the flashlight?
And you can do that with radio waves, yeah.
Exactly. Yes, you can do that with radio waves. Yeah, I agree with that. But that's not what they did.
You put a parabolic transmitter, and it shoots the signal toward that thing that receivers that you want.
But the point is, right? So they told Marconi, right? You will never do that. That's impossible. The curvature of the Earth will get in the way. And the moment he did it, he started looking for an ad hoc rescue to explain why he was able to achieve.
Yeah, but the problem is that I wasn't there.
When they adamantly asserted, no, the curvature of the Earth will get in the way.
The problem with this,
so next thing, we have an ionosphere, right? Oh, that must, because they cannot move, they cannot deviate away from anything other than Earth being a sphere. Right?
The problem,
they're not going to let go of that. So anything that contradicts that, they will desperately search for something to explain it, even if they can't demonstrate it. And it happens with radio waves. It happens with long distance observations. It happens with not being able to measure or detect any motion of the ground. I mean, it just happens over and over and over again. It's excuse after excuse after excuse after excuse, when all we do is measure this place to be planar in nature, and we observe it to be planar in nature, and we use it as if it is planar in nature.
I mean, that's not 100% correct. For example, when you're building long bridges, you have to calculate in the curvature of the Earth, otherwise the bridge will be not stable.
No, they don't.
Yes,
no, they don't. There's no evidence for that. There is absolutely zero evidence for that. Never seen anybody provide any evidence to indicate that that is the case.
I mean, I cannot provide evidence from here, but I'm pretty sure you can.
You believe. You just believe, brother. Trust me, you just believe.
I mean, I'm not just believing, but
no, you never. You never witnessed it in reality. Any engineer making the
So I'm linking a bridge here, which is actually famous from this exact effect that they had to do.
What's your point with this?
That when they built this bridge, they actually calculated in the curvature of the Earth because it's on that long. It's 4 kilometers long.
Where? Over 4 kilometers.
Where they say I'm on the article where they say that they took account of the curvature.
It might not be in the article, but I know for the fact that this bridge.
No, don't tell me about what you believe. We are talking about reality. Something you know it means something that you can show. So where for this bridge,
because of the height of the towers, 211 meters, and the distance from each other, the curvature of the Earth's surface had to be taken into account when designing the bridge. The towers are not.
No, that means it would not have to be taken into account because naturally, right? If that was the case, naturally, if you just naturally leveled it off, right, just used some sort of leveling device, right, it would naturally be that way. It would just be a natural consequence of using level. You're saying they deliberately did it. They wouldn't have to deliberately do anything. They just go about their job and it would just naturally conform to the surface.
Sorry, it's just I'm not.
Okay, so somebody in one city builds a tower, and they build it dead vertical, right? It's dead vertical. Right?
What you can show.
And someone in another city builds another tower, and it's dead vertical.
You
right?
are
now on your ball, right? The natural consequence of that is that the top is a further distance away from the bottoms of those two towers.
Both of the tops.
That's just a natural consequence of building a vertical tower.
Both of
two vertical towers, right? So why would you need to deliberately take anything into account if you're on a ball? That's just the natural consequence.
So the thing is that the tops of the towers both are level, okay? And the tops are further away of the two towers than the bottom. So the chain that
they didn't take it into account. They just went about their job and did their job, and that was the natural consequence, right?
No. The chain that's between them have to be measured. Like the distance from the bases are shorter than the distance from the tops of the towers. So the chain measurement have to be taken account this difference in distances from the tops and the bases.
So did they deliberately build them to be those distances apart?
So what they did, they built two towers. Both towers are level. Okay? Both towers are in level. But what you experience is that the tops of those towers, although both of them are level, are different distance away than the bases of those towers.
But did they deliberately build those towers with tolerances in mind?
What do you mean tolerances?
Tolerances for movement, shifting,
no,
weight.
I'm not. No, it's not. It's not the
they
towers.
Don't.
It's the chain.
Do they not?
It's the chain.
Do they not build bridges with tolerance levels?
Yeah, I mean they probably have tolerance levels.
Right.
Yes.
They need to be able to like stand certain conditions which might affect them, wind and stuff, and pressure and weight from traffic on the bridge itself and all that stuff. It's not going to be just perfectly rigid, is it?
Yeah, of course. I don't get your point, but yeah.
They're going to deliberately build those towers to have that compensate for any sort of movement, distribution of movement and warping and like different conditions which will affect the way. So they might have to do it that way deliberately.
That's just your ignorance.
No, they do build bridges with tolerances, right? So that it can handle certain conditions.
Yeah, but they don't build it to withstand the rotation of the Earth, just like you build your house and it's not built, so it's like, you know, not going crazy. I don't know what your point here is.
Well, it says the bridge is 4,000 foot long. So it would have 5 inches approximately of curvature, that distance.
Did you measure that?
5 inches.
Yeah.
Yeah.
And you can measure that.
Oh, wait.
Negligible.
Laser
This
device.
chain is 1 link short.
You can
Is that
measure
what
it
happened?
with
Did they?
a laser beam. Did you just
Yeah.
say you can measure it with a laser beam? So when
Yeah,
we
one
use
of the
30,000, so when we use a $30,000 laser and shoot it across 10, 20, 30-mile lakes in 17 different locations, and it hits the target every time just off the surface of the water, is it how's that work?
You don't know how. You don't know that laser beams curve or something. Or?
Well, why is he saying laser? You can measure this 5 inches of curve with a laser beam then.
Yes, the distance you can measure accurately. Like the same way that you just said.
Who did
You
that?
can measure
Who
accurate
did that?
distance. No.
Who did that, Taylor?
Sorry,
No,
what?
who did that? Made a
What?
claim. Someone used a laser beam and measured the 5 inches of curve over the bridge.
Yes.
Who did that?
What do you mean? Who did that?
You just claimed okay, so there's 5 inches of curve. You're saying that they took 5 inches of curve into consideration.
Yes.
The bridges warp all over the place. They have huge
Okay,
tolerances
that's
like
just
T-dubs.
hold on. That's just a lie. When we build bridges, no one really takes the curvature. Why are we saying? It's a lie. Blatant lie.
It depends on the type of bridge you are building.
Can you show
Well,
me?
hold
Show me a
on.
manual?
There should be an easier way
Can you
to
show me a
settle
manual?
this. There should be an easier way to settle this. Is that bridge going over water?
Yes.
Presume so, yeah? Okay, so did anyone measure the water to curve?
This isn't going to go well. This isn't going to go well. Are you going to make a water flat argument?
It depends. Is he making a water curved argument?
No, I'm not.
So the water
Take a
isn't.
seat,
We're talking
Matt.
about bridges.
I don't care about
Take
the
a
water.
seat,
in
Matt.
this case.
Take a seat, Matt.
So you're not
Take a
arguing
seat
that the
so I don't
water is
destroy a
curved.
cyclone or what?
I don't care about the water in this case. Like you can have the water the way you want.
Okay, so we can have the water flat, yeah?
Yeah.
Okay, welcome to Flat Earth.
Thank you.
So they built a curved bridge on a flat Earth. That's fine.
Yeah. Maybe
Anything
when you repeat it long enough, cyclone, it might be true one day. But the water is definitely curved.
And they built that bridges like that, and they, like he said, they took consideration of the curvature of the Earth, aka the surface of that water in underneath the bridge. So because they took consideration of that 5 inch of
No, he
drop,
changed his mind.
he said that the water is not curving. Yeah, I heard him.
So that's fine. We're all in agreement. The water's flat.
Yeah, except we're not all in agreement though.
Oh, right. Okay.
Mhm.
Well, feel free to provide your measurement.
I don't need to.
Yeah. So it's just a
Measurement of what?
baseless claim then. That can be dismissed.
So can yours.
The
No,
measurement of curvature of water.
his argument. He said, no, the water's flat, so we're in agreement.
What's your evidence to support that?
Okay, so tell me one thing. We have two towers. They're 4 kilometers apart. Okay? 4.5. They are measuring in. Oh wait, I just circled.
How much would they be tilting away from each other?
Yeah, that's the question.
That should be the calculation involved as well.
Yeah.
Well, rather than just a calculation, did anyone measure this?
Yes, I'm sure.
Okay, can
They
I
are not
see the measurement?
What do you mean? You can see the measurement?
Well, you're saying there's a measurement of the.
Yeah, it's stated in Wikipedia.
Okay, what measurement does it link to?
Wait a moment. There is a bunch of citations on here. The history of Verrazzano Bridge, 50 years after its construction, 2014 citation.
Just pull out the bit where they tell us about the measurement they did for this.
They just state the distances and numbers.
So it's just theoretically calculated. It's not actually been measured to be the case in reality.
I mean, they might have measured it.
Well,
but
for your argument to have any merit, you would have to provide that.
I'm looking for the citation where there's anything about that kind of stuff.
That'd be good. But the water would still be flat, right?
What about
Of
any?
course.
What about any evidence for the horizontal plane water cyclone?
Go outside, man. You still not done that?
Wait, so you think because you see a horizontal surface on the surface of the Earth that
Oh, you
the
agree?
water must be
You
horizontal?
see the horizontal surface. There you go. So you want to try and disprove this horizontal surface that you see?
That's like a first grade geometry type of argument I'd expect from a flat earther. You'd know that a
Go ahead
horizontal
then, bro.
surface on
The
the
horizontal
surface of a
surface that you just
ball and
observed.
a plane is supposed to look pretty
So you
horizontal.
agree? Horizontal surface. There you go. You lose.
I think you're very confused, or you didn't pass geometry.
Buried yourself already, Matt.
No, you buried yourself.
You just agreed.
On the surface of a
surface.
sphere. On the surface of
It
a
is the
sphere. and
measurement.
surface of a
Okay. I found the measurement part. Okay.
You found the measurement.
So, yeah. It's not something that they measured out actually. What they did is the cable they hang between the two towers. They know the exact length of that cable.
I love how you sound excited. I have the measurement. Oh, it's not a measurement, but just.
Yeah. Sorry.
Holy
So
shit.
they know the exact length of the cable and they know the inclination of the cable. And from that, they can just, with basic like geometry, they can calculate back the distances. And it turns out the distance of the top of the towers is different than the bottom because the cable length.
The cable length.
Yes.
So did you post that?
What?
What you've just said.
Here is the wall thing. Oh, it's too long. I will cut out the. I'm just
They ordered the perfect amount, right? We don't want it to be any shorter or any longer. They would have ordered excess, right?
Yeah, I'd be interested to know what the tolerance plus or minus was with that cable over that flat water.
When it's saying that they had to take the curvature of the Earth's surface into account.
Right, so it's saying the towers are not parallel but are blah 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 farther apart at the tops than at their bases. And it's got a bunch of citations after that. So do any of those citations have the measurement of that?
I'm not sure. I'm looking through them, but I haven't found any of yet. But I can send this full stuff, and you can go through them too. I'm looking for it, man. I cannot tell you more.
Also, it says in that paragraph that you posted, the Earth's curvature had to be taken into account, right?
Yes.
Do you have any evidence for the Earth's curvature?
What do you mean?
Well, saying that in that
No.
paragraph
What they're
isn't proof of
saying
it.
is that they take that into account.
Right, but
It's
if it
not
doesn't
saying
exist,
that it's
then it's
there.
just
It's not
theoretical.
saying that
Right.
it's existing. They just took
Right.
it into account.
Okay, so they theorized it in their
Yes,
calculations.
exactly.
Okay. Is there anything beyond theoretical calculations
No.
that proves there is a curve?
Then you cannot prove anything ever.
Okay, so why'd you believe it?
What do you mean?
Well, if they've got no evidence for it, why would you believe it?
I wouldn't go as far as saying I believe it. I'm just saying that all the mathematical models that we are using to predict an awful lot of stuff are pointing towards, like, assuming and pointing towards a spherical Earth. I'm not saying that I believe it. No, God, no. Well, I'm saying
So when
that
the
all
teachers
the...
in school are telling all these kids, "Hey, you live on a spinning ball," definitely. They didn't
I
mention
don't
that
think
it was just
teachers
a
do
spin.
that. Teachers say that beyond a
They don't.
reasonable doubt, it's the most
You
possible.
weren't taught at school that the Earth is definitely a spinning ball.
I don't think so.
What else did they say it might be?
So what my physics teacher said to me, that most of our research, not research, predictive models, like most of our predictive models are pointing towards a spherical Earth that is rotating, and that's how we can predict a lot of stuff.
So he doesn't believe in all the space pictures and the NASA stories about a ball Earth.
I mean, you don't have to believe in them. They are still cool, and if you think they are I think they can be true. Like, I don't think they are all fake. I actually think
your physics teacher obviously wasn't impressed with them because he says they don't have anything for the globe other than theoretical mathematical models.
No, I mean, the problem is that you can always say that something is fake, and oh, it's fake, that's fake, and that's why.
Well, you can always say that something is real too without having any evidence for it. Doesn't mean
No,
it's
but
real.
I'm not saying it's real or fake. I'm just saying that assuming that the Earth is spherical, you can do much more accurate measurements, or not just measurements, but predictions.
So you don't believe the Earth's a globe?
I mean, I believe it into like a reasonable point.
But you don't think there's any actual evidence for it other than mathematical models?
The problem is that evidence for me and evidence for you means different things.
Well, what does evidence mean to you?
I mean, if there is a predictive model that can show me a lot of stuff and I can look into the sky and prove it to myself, then it's evidence enough for me. But for you, evidence is something like, I don't know, that you can try at home.
So you're thinking, so you've looked at a model which has convinced you the Earth's a globe?
Yes.
Which model?
No, not one model, multiple models.
Oh, multiple models. How many?
Yeah. There are so many models that like point towards the Earth being spherical.
Why isn't there just one model of the whole thing?
Because the problem with models is that they are like only accurate over like certain fields. Like they are not like all accurate. Like you cannot calculate fluid dynamics with astrophysics.
So could you model the whole Earth?
What do you mean you could model the whole Earth?
Well, you're saying a model has made you think the whole Earth, is something because of a multitude of
No.
models.
It's because multiple models point towards a spherical Earth.
Like what?
For example, like astronomy,
astronomy isn't a model.
Like, okay, models within astronomy. So, for example, the way we predict stuff in the sky, if that's making sense
Like
to
what?
you. I don't know, solar and lunar phases, how the stars will move.
How would that tell you?
What I will see if I'm standing at a particular spot on the Earth. For example, GPS and how GPS works is one thing that.
How does looking at the stars, or the sun, or the moon's cycles tell you that you live on a ball?
It's something that we already debated here a few hours ago.
And what was your answer?
A video.
Of what?
I just looking for the video and I'm just linking it again.
Well, just describe it because I don't need to watch it.
So what the video shows, it's a point close to the equator, and what they did, they planted a 360-degree camera, and you can see both of the poles at the same time rotating around.
You can see what rotating?
Both of the poles, like the South Pole and the North Pole.
What do you mean when you say you see a pole?
Like the point which the sky rotate around. If you
So you
get what
see
I
the
mean.
stars moving.
Yes.
Okay, so how does the stars moving tell you that you live on a spinning ball?
No. It's like you are near the equator. You are looking right. The stars rotate clockwise. You are looking left. The stars rotating counterclockwise.
Okay, how does that tell you you live on a spinning ball?
I mean, it's the spherical Earth explanation is simple. You are just on a sphere that's rotating, and it's so easy
Okay.
to understand.
That's just an
And
idea, though. Could be
yeah.
anything else.
My problem is that there's the flat Earth explanation doesn't really. It's not really convincing to me. It's not able to make like good predictions of what will happen if I go north or go south, that kind of stuff.
Well, that's no reason for you to assume that what you're seeing is due to a spinning ball Earth.
No, that's what I'm saying. Like, this is one model that points towards the spherical Earth because it's simple.
No, but
to
it doesn't
explain
point
the
towards
spherical
a sphere. It doesn't point.
Yeah,
towards
it
a spherical
is.
Earth.
It is.
You just said it makes more sense to you.
Yes.
So that doesn't
So it's
mean that doesn't
pointing
mean
towards that. No, it's not just making
no,
more
it doesn't
sense
mean
to
it's
me.
pointing towards
Making that kind of stuff.
It just
is-
means that you see the stars moving in a particular way. It doesn't tell you anything about there being curvature or motion of the surface at all.
Yeah, but if I assume that
It's a
the Earth is
logical
spherical,
fallacy.
wait.
You understand this is a
Yeah, it
logical
might be a logical
fallacy?
fallacy, but wait for a minute. If I assume that the Earth is spherical,
Yeah, so
it makes
begging the
sense. It's
question,
easy to
fallacy.
explain. But wait a
Begging
minute.
the question, fallacy. That's a fallacy, dude.
It might be a fallacy, and I agree with that one. But what if
Right,
I
so your
go?
worldview
What if I
shouldn't be
what if-
based on a fallacy.
No. I'm not saying I'm basing on that, but they are like this stuff, and there are
This
a
is your
bunch of
argument.
other stuff. A bunch of other stuff.
Okay,
that's
could you give me one
pointing
that
towards
isn't
the same thing.
fallacy? Could
No.
give me one that
You
isn't a
don't.
fallacy?
You are not going to get it until you get this one.
No, yeah, I got it. It's a logical fallacy.
No, you are not
just
getting it.
agreed.
You are not getting
Yeah,
it.
I get it. It's a logical
No, you
fallacy.
don't.
You're assuming the Earth is a ball, and you're
No.
looking at the sky, and you're saying that makes
No,
sense.
you
If
are
I'm on a
wrong
ball,
with that.
therefore Earth is a ball. That's exactly what you're doing. If Earth is a ball, the stars will move like this. The
Yes.
stars move like this. Therefore, we live on a ball.
No. The second part is not. The second part is not correct. The first part.
Okay, so it doesn't tell you live on a ball.
Yeah, exactly. I agree with that one.
Okay, perfect. Right. I agree. It doesn't tell you live on a ball.
I agree with that one too.
I asked for something that tells you live on a ball.
No. You are not getting it.
You're not getting it. I asked why you think you live on a ball, and now you've just given me something that you said doesn't tell you live on a ball.
No, it points towards it.
No, you just agreed it doesn't. It's a logical fallacy.
No, it points. You said it.
Okay,
Like,
so because the stars move this way, Earth
let me
must be a
finish.
ball.
Yes, let me finish. So, if I'm standing on a ball, this is what I would see. And you are correct. It's not working on the other way around. Like, you cannot prove.
So then you go. I see that.
But
therefore, I live on a ball.
And there are like
it's a logical fallacy.
10, 1,500 different things
It's a logical fallacy. Yeah.
If there are 10, 15, 100
No,
different
we're not doing
things,
logical fallacies. Give me one that isn't a logical fallacy.
Okay, I'm sorry, guys. I'm here for like 4 hours. I'm really trying. You haven't told me anything about the flat Earth, and
Okay, so you've only got logical fallacies.
Yes,
Fine,
I am. So DJ, you were the nicest so far. Necros, you are big points out to you too. DJ, you are too. You are great guys. I really tried. Sadly, you haven't been able to brought up any points that would convince me otherwise.
Well,
So,
that's okay because you're
thank you for
convinced
the
by logical
conversation.
fallacy.
I am going to go now.
Fallacy, so of course, what are you going to do?
Cyclone, I'm here for 4 hours. I don't know what you want from me. And I'm the
4
only one.
hours,
And
all
I'm
you
the only
thought
one.
of is a logical fallacy.
I'm the only one engaging with you guys on this topic, and I love to debate
That's
this
all right.
topic. I would
Go
love
on
to
mute
do it in
anyway,
the
so you
future.
can talk to someone else. Enjoy.
Sorry? I'm just trying to be nice here, okay? It's not. You don't have to be. You don't have to be like mean to me all the time.
Oh no, I wasn't being mean to you. I just pointed out to you that was a logical fallacy, and you agreed with me. So don't say I'm being mean to you when you agree with what I've said.
Okay, so
anyway,
can I
need
say
to go
a
on
question
mute. I
to
need
you?
to go on mute. No, I need to go on mute now. I'm just going to be listening for a little bit. So it was nice to talk to you. Keep asking questions, and don't rely on logical fallacies for your worldview. That's not a good idea.
I'm not doing that. So, Cyclone, here is the explanation why I'm not relying on logical fallacies. I'm not saying that I'm believing on a spherical Earth because of this one thing, but when you're having hundreds of different models that describe the Earth and describe things that they're making great predictions about what we experience, and all of them are pointing towards a spherical Earth. And yeah, all of them are logical fallacies, but everything is a logical fallacy. You cannot prove anything by your standards of fallacies. Like, we cannot be 100% certain of anything, to be frank with you. But the case is that hundreds of different models and predictive mathematical models are pointing towards a spherical Earth, and zero of these are pointing towards a flat Earth. That's why I'm believing in a spherical Earth.
No, observable reality tells you that you live on a flat Earth, and hundreds of fallacies don't tell you that you live on a globe
Could you
Earth.
show me a model, a
No,
predictive model?
I'm not gonna commit logical fallacy like you are. You just said, and yeah, all the models will be logical fallacies, dude. Slap yourself in the face. Wake up. Logical fallacy means
Can
not
you
an
show
argument.
me a model, a single model that points towards a flat Earth? Just one.
Okay. All right. Horizontal and vertical. There you go. There's my model.
What do you mean horizontal? What prediction does that model make? What's the prediction there?
I will need to use that. I will have to use that as reference to do anything in practicality. Anything at all.
But what's your prediction? Like, what things can you predict with
And
that?
I will have to reference either horizontal or vertical, which are intrinsic to each other. They're perpendicular to each other. One is parallel with the plane of the horizon, and one is perpendicular to the plane of the horizon.
What event
so,
in the real
I'm
world
going
are
to
you
have
predicting?
to use like actual way we observe and measure and experience reality. Right? I'll have to reference that. Do anything in reality, practically, like to build or
what
navigate.
What event does that predict?
Well, I can predict that I will use horizontal, for example, from mean sea level to get the height of or elevation of the top of a mountain peak, for instance.
Is that an event?
That's what people do. That's how they determine how tall.
What kind of event your
are.
model can predict?
Horizontal and vertical from mean sea level.
But what's the event? What's data that's predicting?
That I'll have to use that. That's my prediction. I'll have to use that in order to get the height of the mountain.
How does your model predict that? What are your inputs and outputs? Like, what data do I put in?
Well, it's predicting that the top of that mountain, right?
Yes.
If its base was sitting perfectly on the water of the ocean, well, that's how tall it would be above the ocean. I use a horizontal reference plane of reference, a horizontal plane of reference to get that right above sea level.
I get it. So you're measuring stuff from sea level, right? And what tools do you use to measure that height?
You'd use theodolites and other leveling instruments, to make sure that your optics are nice and level, right?
Yeah, you are using levels, but that doesn't really give you height. So what are you doing for height?
For height, you get distance, right?
How do you get distance?
And you measure it.
How?
They've got instruments. You can walk it with a those
yardstick
thing. Like you push it along and it turns every meter. Clicks, makes a click.
You use that to measure what exactly?
Well, distance.
From where to where? Like, what's the model here? What's the predictive model?
It's just using horizontal and vertical as references to get distances and heights and angles, things. Yeah, measuring things.
And how do you know?
In reality,
how do you know that that's working above a certain distance? Like, could you accurately predict those things when you are talking about, like, I don't know, 6,000 kilometers, for example, or 4,000 miles?
I don't think anybody's making those sort of observations and taking those sort of measurements.
Yeah, that's what I mean. Like,
It's a step-by-step process. You have to like do segments at a time, right?
so you are saying your model can only
Because of limitations to your optics.
Yeah. So you can only do like local stuff with it, right?
Only what?
Like local stuff. Like, I don't know, measure your like house, but you cannot measure like hills and
the military use like optics and lasers and things over huge distances, like not thousands of miles, but like really long distance, maybe into the hundreds of miles.
Yeah, and that points to a flat Earth, right?
They're always going to be referencing horizontal and vertical. I mean, like, what else would they want? What else could they use?
Yeah. I just not getting how that points to a flat Earth. Sorry, it just might be my bad.
Well, for one, you can't have horizontal on a globe. There's no such thing. Doesn't
Why
exist?
Why you?
Because at any point on a horizontal line or plane, right? Because horizontal means zero slope, right? Has zero slope. There's no curvature, no slope, no slanting.
Wait. Zero slope.
Not going diagonally. It's perfectly horizontal, right? It's horizontal.
Zero slope doesn't mean zero curvature. By the way, like you can.
Yeah, it does. Yeah, it does. Yeah, slope is a rate of change of slope. So that's what it is.
Yeah, but it's the rate of change in the like according like it's the rate of change of your like
slope.
Your like
deviation from horizontal. Deviation
what I'm
from
saying is
in the vertical
if
from
you are
horizontal.
Grabbing,
yeah.
If you are grabbing a level, right, and you're measuring the slope, and your level is always showing like zero level.
Globers can't use horizontal because it doesn't exist for them. See, horizontal is having no slope and no curvature, right? It's perfectly straight line or plane, right? Or surface, right? So at any point on that line or plane, right, perpendicular to that will be 90 degrees. But as soon as a glober establishes what they want to call level or a horizontal plane,
yes, it changes.
A reference, it changes along that. It's only at one point that vertical will be perpendicular on that line. At any other point along that line, vertical won't be perpendicular to that line. So it's not horizontal. By definition, it's not horizontal. That means it's a slope. And horizontals don't slope. So
yeah, but you
just literally can't exist.
You're aware that they are different geometric models, right?
But horizontal never changes. You don't get to change the definition of horizontal. Horizontal is horizontal, and if it's to be used as such, then that's what it is, right? If you want to start saying it's something else, then you can't call it horizontal anymore.
What you are talking about
horizontal has a definitive definition.
In what you are talking about right now is Eulerian geometry, if I'm pronouncing that right.
I sure think so. I was going to make it, but all right. Sorry, go on.
So what you were talking about is Euler. I think you pronounce it Euler. And what you're talking about is Eulerian geometry. That's what you're talking about. That's why your idea of horizontal and vertical and perpendicular.
Horizontal is just horizontal. It's not. It's impartial to anybody's ideas of any other sort of geometry.
Like in order to define horizontal, you have to have an idea of geometric. Like you cannot have horizontal.
It's a standard. Yeah, it's an absolute standard by which we operate within reality. It's how we experience reality, and it's how we operate and function within reality, and it's how we do things as we use it to achieve things in reality. Physical reality, yeah.
Yeah, but would you agree that there are certain like constructions that are more complex and you cannot use these like really simple geometries? Or you have to use
people want it to be more complex because they think and believe that they're on a giant spinning ball. But when it comes to practical reality, they don't use any of that. They're just using horizontal and vertical. It's really simple. You don't need to go into all the spastic ideas of being on a spinning ball.
Are you know that because you worked on larger constructions, or you are just speedballing?
I've never seen any compelling evidence that nobody's ever come in and said, no, I definitely have to do this or that. Oh, you said earlier, they had to account for curvature on some bridge or something, but you can point out the measurements. I mean, so.
I mean, the measurements are in the chain length, but yeah.
Yeah, look, the surface of liquid at rest is horizontal and level, and it's a standard. I mean, like,
yeah, I agree.
Physicists have studied it in ideal conditions, and said, "Yep, it's horizontal. I can't find a tangent point on there."
Do you believe that?
And so it gets used as a standard for establishing horizontal planes of reference.
I will circle back to an earlier point. You might have been there already. So do you believe that all the levels, like when I'm having level, is as a line, as a horizontal plane? Like all the levels are parallel to each other, right? So no matter if I'm in the US, I'm in Europe, all the levels are the parallel.
All horizontals are parallel.
How can you prove that?
How can I prove that? Just look at the horizon. All horizontals are parallel with the plane of the horizon.
How can you prove that when I have a level stick here and you have a level stick like halfway across the world, they are the same level? How can you know that for certain?
That's what horizontal means. That's horizontal. That's part of it being horizontal, that it doesn't deviate in the vertical.
But how do you know that? Like, what led to you to that belief?
That's basic math. That's just what horizontal is. That's how we reference changes in the vertical. Using horizontal.
So you would say that's an assumption, right?
Not an assumption.
But how can you?
It's literally how you determine changes in the vertical.
Wait. If I grab a level stick right now, I'm in Europe. You are in the US, right? You're living in the US.
Oh, I'm in Australia.
Oh, you are in Australia. Okay, it doesn't matter. It's far away enough, right? We both grab a level. How can you prove that it's the same line for both of us? What point of reference?
What do you mean?
Have?
It's horizontal. It's just horizontal.
Sea level,
horizontal
bro.
is the same for me as it is for you. Why would it be different? Why would your horizontal be different to mine? You're going to use horizontal some sort of different way?
Yeah, I mean, I can use it differently from like a spherical Earth point of view. They can be different.
We established that spheres, globe Earths don't have, hypothetically, theoretically, they don't have horizontal.
Yes, they do.
No, they don't. That you can't call it horizontal if there's only at one point on that line or plane.
It's not a point.
Vertical is
like
perpendicular to the horizontal to your line.
You can have a large
it has to be at all points.
You can have all the Earth horizontal. If there's only water on Earth, it's all horizontal.
Not on a sphere, it's not.
Yes, it is.
No, it's not. You can't. If you're going to establish what you're going to call horizontal level, right? All points on that, all points anywhere on that line or plane must be treated as if it is still horizontal. You can't just stand at one point and then look out and imagine that it's still horizontal.
No.
Right? But it's not really, right? No. It is horizontal, right?
Okay, so
that means that at any point on that line or plane, perpendicular to that line or plane, will be vertical. You will say, whoa, it's not. It's not. There's an angle change here. It's not 90 degrees anymore. But I've never seen that shown or demonstrated in reality either.
Can I state you my my definition of horizontal? So horizontal for me is something that is perpendicular to the gravitational force. That's something you can agree with, right?
That's what you want to call horizontal, but that's not the definition. That's not how it's treated, and that's not how it's used. That's not how we think about it.
Like,
we just know when we establish a horizontal plane of reference, we're treating all parts of that.
No, wait.
Yes, at any point on that, perpendicular to that will be vertical, will be 90 degrees.
Okay, but you were talking about sea level. Somebody was. And sea level is like, it's always like the surface of the sea is always perpendicular to the gravitational force, right? That's how a level stick works, is it not?
Sea level is just simply you're going to use a point of reference to extend out a horizontal plane from that point, and see how the land deviates in the vertical plane, your horizontal plane of reference. It's just a standard, right? So that will be considered zero elevation. So anywhere along that horizontal plane is considered to be at zero elevation.
If I have a level stick and it shows horizontal, and I walk 4 kilometers away, and I still have that same level stick, and it still measures horizontal, but the two lines are not parallel to each other. How that could be? And both horizontal, like the level stick is both accurate in both situations.
If it's horizontal, then they're parallel. Horizontals,
But
all horizontals are parallel.
You can show that they are not.
Go and do that then. Show us. Give us a demonstration how parallels, horizontal lines aren't necessarily parallel to each other.
That's a good one. I haven't expecting that one. No, I'm just saying that isn't that a situation that is, I'm not saying it's the case, but isn't that possible? Like, isn't that something that's possible, at least?
We understand that's the belief. That's the belief system, but it's not used in practicality like that, is it?
It's used a lot, by the way, but it's a different topic. Like, the curvature of the Earth is used in so many places. I'd
say it's imagined in so many places.
But it works, is it not?
What do you mean it works?
Like, stuff works. Like, how does GPS work, man?
No, I don't know about GPS. You'd have to ask someone else here that might have a bit more knowledge on that. Me, I don't.
Anyway, guys, it was a good 4 or 5 hours. I'm really gonna bounce now, and I really appreciate your patience. Those who showed patience, and again, no hard feelings. I think we had a really progressive talk here.
Yeah, man. Nobody's here like to take this personally. I mean,
and some
it's not,
of.
No, nobody's here to convince you either. Like, I mean, look, we're just encouraging people to question and to go out into reality and observe and do their own observations, do their own tests, do their own measurements, and do whatever they can to try and confirm whether what they've been told or their life is true or not. I mean, that's all we're doing. And what you do with any information that we provide you with is purely up to you. You walk away, you do with it as you please.
Yeah,
you can ignore it, you can test it, you can do whatever you want with it.
That's my
and you
problem.
can never come back, and nobody here is going to be like, upset or anything, like have any emotions about it. I mean, like it's we're just here all being, trying to be adults and just have a conversation. I mean, it doesn't have
Yeah,
to, like, sometimes it gets heated and sometimes we get frustrated. Everybody gets frustrated. Everybody
I agree with
expresses
that.
frustration in some form or another. But at the end of the day, it is nothing personal towards you yourself as an individual.
I think not everyone would agree with you. Like, what was that guy's name earlier? He was really angry at me. But it's okay. I don't mind.
So, like I said, people express frustration. I mean, it's gonna happen, and you're gonna get maybe called names and things like that. But I mean, like, it can be justified too. That frustration can be very justified if the opponent has been very unreasonable in some manner.
I don't believe I was very unreasonable. But as a wrap up, I was taught a lot of things and I learned a lot of things in my life. I went after like every piece of knowledge I could. I'm really interested in physics. And I joined here in order to learn more about like the flat earth and what it can provide in terms of like models and predictions, propositions. And so far, I haven't seen any particular evidence or like any progressive model that's adding anything to the scientific field.
Have you ever been
It's not
outside
about
though?
models.
You ever been outside though?
Yeah.
Yes, I am.
You ever noticed how it's all flat and motionless? There's some evidence. Could you disprove that somehow? Anyway, quickly, is anyone else catching this Matt nuclear meltdown in the chat? It's quite funny. He started off saying, oh, you should read back. He started by saying, because he got mad at me because he said the water that we observe is horizontal. And I said, okay, well, that's it. There you go. See you later. Unless you got something to the contrary, which of course he doesn't. And he said, we've been given a true doctrine and it's reasonable for me to have that doctrine. And then Donald C, of all people, pointed out to him the definition, which was something taught by a church or a group. So I was like, hey, Matt, you've got your true Church of Globe doctrine that you love, and then you just start spiraling from there.
So again, to wrap up, I haven't heard any points that would go against.
I just told you, observable reality.
No, the problem is that the science I have learned throughout my life, it's working. I know how my phone works. I know how GPS works. I know how radio wave works. I know how. No. It's all working on the spherical Earth, and it's not working on the flat Earth.
You don't have a spherical Earth. Remember, you go
okay,
outside,
so one last question, and I will. If you can do this one, I will concede my position. How does GPS work?
On a flat Earth.
On any Earth, like just describe the GPS.
No, it only works
any.
on the flat Earth. No, just
I don't
know what
care.
it is. We've only got a flat Earth, so that's all it works on.
Okay, how?
Wait, before you leave, Taylor, is it Taylor?
Taylor is okay. Yeah, of course.
Are your DMs open? Can we send you a link to join our home server?
I'm in your home server.
We've got a plethora of information channels there. Got a library basically, which is it's all information channels. So you could go down the list and like look for things that are relevant to any questions you have, and you could browse the information inside those channels at your own leisure. If you don't feel that any of our answers have been sufficient enough,
I already
if you like.
I tried to gather information from that channel, but the things I have found are not really like. Many of them are not connecting, and even the ones that are making some sense are not explaining.
You got some GPS citations in the chat with a link.
Oh, that's cool. That's cool.
So have a look at them
in the home server. Oh, good. Sorry.
In your spare time.
Thank you very much.
Matt said he's going to write in his diary about me.
Shut the fuck up, dude, man. You retard. Yeah. With your little pincetti cock, how do you find it? Yeah. You have a little tiny cock, like an Asian one?
Whoa. Quickly. Who are we talking to? Just Matt.
Sorry about that.
Out.
That was some other guy I was talking to.
Oh, poor Matt.
Okay, so I looked through this citation, but it's not explaining how does the GPS work according to a flat Earth model. Or at least
it tells you the reference, what it needs to use. I mean, if you cannot deny that, that's your problem. You know. But that's how it works.
I don't know what
Flat
where
plane
does
of
it
reference.
say? Where does it say what signals that my phone receive?
The fuck? You asked how it works on flat Earth.
Yes.
There you have it. The citation's backing it up. I don't know what else you want. You want
signal.
I don't think he heard you when he
Fuck.
said the flat plane bit. I don't think he heard you. Maybe you need to repeat it.
Retrievers finds its location using subpoints and crossing azimuth lines where the lines cross. Time to receive signal. Every GPS receiver.
Yeah, well, you can read it through in your own time, bro.
No. I'm looking for the.
Hear me.
But this is not explaining how does it work. It's just some random citations from random places. Like most of them are not from the same place.
Does it say it's going around a curved ball Earth?
No. But it also doesn't say how GPS works.
Oh well. Well, if you think it's going around a curved ball Earth, you would need to.
No. All I'm saying for that on a flat Earth, how does GPS work? Because I know how it works on a spherical Earth. But these citations doesn't
work
tell
on a
me.
Spherical Earth though, because you don't have a spherical Earth.
Okay, then how does it work? Just explain to me.
Like,
just explain to me how does GPS work, okay? And I'm gone.
Well, how do you think it works?
Yeah, it's very simple actually. They send up satellites, like these GPS satellites. They are like I'm not sure about the exact number, but there are plenty of them. So at any given time, your phone tries to like what these GPS satellites do.
Step one. Yeah, let's start with step one. So the satellites, where are those?
Like on orbit around the Earth.
Right. Are they in space?
Yes.
Okay. Could you show me a photograph of one of them?
You don't have to. You don't need a photograph because your phone.
So how do you know they're there?
No. Wait. I'm just telling you.
The phone doesn't tell you where the signal's coming from.
That it tells you exactly, but that's a different.
No, it doesn't. No, it doesn't tell you.
Yes.
Where does it tell you where the signal's coming from exactly?
So what is happening? Okay, that the satellites that are going around orbit, they
you don't
know
have any
they're.
evidence for those. You still.
Yeah. I'm trying to get there. So what they do is they're continuously sending out signal about their position and about their onboard time.
Okay, if I say no, they're not, how will you disprove me?
Yeah, I'm getting there. I'm getting there. So they are constantly sending their position and they are like onboard time. And when your phone are able to receive these signals from at least 3 of these satellites, then your GPS works. You are able to locate your own position by these 3 reference points.
How would you know whether it's coming from a satellite in space or a high altitude balloon or a tower on the Earth? How would you tell the difference on your GPS?
It could come a high altitude balloon. I can agree with that.
Right, so it doesn't prove anything about satellites around a ball Earth to look at your GPS.
I mean, balloons are not like stable enough.
Not just balloons; it could be ground towers as well.
No, ground towers wouldn't work.
Why not?
Because the problem is that did you ever go to nature with your phone?
Yeah, it drops out.
Yeah. So
yeah, where there's no ground towers, it drops out.
Yeah, but GPS still works.
When there is not necessarily. No, it doesn't.
Yeah, GPS still works. If you have a clear sky
out in the wild.
If you have a clear
even just out of a city.
If you have a clear sky, GPS will work without any like towers or mobile connection. And if you can get into the, like, I'm sure there are apps for it, but you can actually like read up the information that the GPS satellites are sending towards you.
No, but you still don't have satellites yet, remember? You haven't proven this.
Okay, so you can, the point is that you can read out the exact GPS information that your phone uses
Yeah, but
to locate
it doesn't
yourself.
tell you that it's coming from a satellite in space.
No, but the information is there. And even if there are no towers,
Yeah,
there is
the
no...
information doesn't tell you that it's coming from a satellite in space going around a ball.
Yeah, but first, it's... So my
So it
first
doesn't
point...
prove that the Earth is a ball, again.
No, it's not, and that's not what I'm saying. I'm just saying that...
Right, so this is what you did last time. I asked for evidence.
All I'm saying that it's not working on a flat Earth. It's not working on a flat Earth.
It is, because that's all you have.
Where do you receive the signal from?
Where do you observe or detect any curvature of the flat surface that you see every day?
Where do you receive the signals from? From the GPS.
Well, GPS
That's what we are talking about.
It doesn't tell you where you're receiving them from, necessarily.
Yeah, but you receive them from somewhere, right?
Yeah, you're just seeing your location. It's not showing you.
No, you are not. You are not. You are not, like, your device not seeing your location. Your device is seeing the location of the...
Yeah, it's showing
satellites.
Your location on the map. It's not showing you the location of the satellites. What the fuck are you talking about?
I mean, it doesn't show that because that's not the information that you want.
No, it's because that's not what's happening.
No. Your phone knows very well the location of the satellites.
All right, so this isn't a proof of the globe. Your last argument wasn't a proof of the globe. We get it.
No. All I'm saying is that how does that work on a flat Earth?
I know what you're saying. You don't understand how things work in reality. That's fine.
No, I'm looking for you to explain me. Like, explain me, please. How does it work? I'm looking for the explanation.
I'm just telling you that the Earth is flat. However it works, what it does.
Yeah, but how does GPS work?
I don't need to explain how GPS works.
Why? How does GPS work?
Because whether the Earth is a ball or not does not depend on GPS.
Yes,
GPS
it
works
is.
on a flat surface because a flat surface is all you have.
No.
Yes, it is. There's no curvature.
Dude.
There's no curvature.
How does GPS work on a flat Earth?
Well, the signals are being sent and received.
Where does the signals coming from?
Well, it depends what technology is being used. There's various technologies.
No, GPS is using a single type of technology. And you can show that. You can actually show that.
There's aerial technology.
No, GPS uses a single type of technology. And it's actually developed by the US. And the US is the US. No, man.
Yes, you are just coping. You are just coping. You've already conceded the Earth because you've already conceded the Earth is not a ball. You're just now desperately trying to say, I don't understand how this works on a flat Earth, therefore the Earth is not flat.
How does
You've already
GPS
conceded all your
work?
arguments are fallacies.
Just tell me how the GPS works.
It works on a flat Earth.
How?
I already told you. The signals are being sent and received above a flat Earth.
What does send? What do send?
It depends what technology and where you are.
Yeah, so for example, I'm out in the hills. What does sending me the GPS data?
Well, I would say the most likely source of the signals they're receiving would be ground-based technologies.
There
may be some aerial technologies.
There is no mobile.
There's certainly no satellites in space going around a ball. That's for sure.
There is no mobile connection. I cannot receive any ground-based.
Okay, I guess that means there's no satellites then, because satellites would be able to get to you wherever.
No, but I receive GPS information.
Oh, well, then must be a different source that you're getting it from then.
Where do I getting that from?
Go and ask your local telecoms provider.
It's not provided by telecoms. It's provided by US, like United States.
By United States. Okay, go and ask the United States then if you don't understand where your signal's coming from.
I know where those signals coming from. I'm asking you that.
Oh, where are they coming from?
They are coming from the satellites that the US
installed
somewhere around the 60s.
No evidence for. Could you show me a photograph of one of those that you're talking about?
Yes.
Let me see it. This should be good.
So here is a GPS satellite, for example. Here is another one.
In space, you said.
Yeah, these are in space. I mean, like,
no, let me see
these are launched into space.
Let me see it in space.
They doesn't make photographs about them in space. They doesn't have camera on them.
Right, so you've
There's no
never
camera
seen one of these in the place that you claim it is.
No, I never.
Right, so your whole argument then is pointless.
No, because I receive signals from them.
No,
Like,
you don't.
Anywhere, like anywhere I go
think.
in the world, I'm out like somewhere where there is like no reasonable like.
Yeah, so you don't have any evidence that they're in space.
Yeah, I do. I can
So show me
actually
a
track their
photo.
movement. You know, they're sending a signal, and you can track their movement, how they
Show me a
like go
photo.
across the sky.
Show me a photo.
A photo of what?
A satellite in space, the thing you're claiming.
Like, did you never looked at the ISS at night?
That's not what you're claiming. Now the ISS is what gives you GPS.
Yeah, because the ISS is
Yeah.
something that you can see because it emits lights.
All right.
These does not
you've
emit.
never seen. So you've never seen this thing that you're claiming. Right?
No, never. I never seen any of this.
Okay, well, I guess there we go then. We can just dismiss it. You've got no evidence.
But how do I receive GPS signal then? How does
Well,
that work?
Ask your GPS provider.
I know they told me they are satellites.
Okay, maybe you should ask them why you can't see them ever. Ask them for a photograph.
They doesn't
Why haven't
emit
they given
light.
you a photograph? Why haven't they given you a photograph?
Look, there is a photograph. It might not even be real though. Yeah, it's an illustration. Sad. Okay, so
Oh, it's just an illustration. That's convenient.
if I'm receiving signals from them,
I
why
wonder
do I have
there's
to?
no photographs. Usually, when things are real, there's photographs of them. Anyway, I gotta go on mute. Enjoy.
Okay, so you just give up on the GPS stuff. Anyone else want to go up with the GPS stuff, or are you just giving up at this point?
GPS proves absolutely nothing. If I give you a two-way radio and I call you out, it does not change the shape of the ground underneath us.
Yeah, but doesn't you agree
Not
that
yeah,
GPS?
but that's factual. There's no yeah, but in that, my friend. A radio signal does not affect the shape of the ground.
Sorry, I doesn't get your point. Can you repeat or elaborate?
It does not affect the shape of the ground below it. It doesn't prove curvature, my friend.
Yeah,
That's
but
what you're using that for.
Wait. Just to have a point of basis. Do you believe in satellites?
I've got no problem with satellites. The issue
How do
is
they work?
what you depict as a satellite and what I see as a satellite may be two different things.
Yeah. That's really good. That's what I'm looking for. Thank you very much. How does satellites work? That's what I'm looking for.
I don't give a shit how they work. That's up to whoever
What do you mean
designs
you
them.
did? Yeah, but people who design them say the Earth is spherical and they are orbiting around it.
And you believe them because they say so. How do you know that they're not just circling above? Orbit means to circle around.
I believe them because that's what I'm experiencing. Like
So
I
it's
see
just
them.
a belief. It's just a belief then. That's all.
No. I see them orbit. Like they come into my field of view and they go out.
No, you do not, liar. I'm calling you out. You see them do a complete circle.
I see them go in and go out, and then they come up from the other side. Like
so
they go
you
around.
assume they orbit.
Yeah, of course. I assume.
Okay, so if we've got a flat plane and something does a complete circle above it, that would not be an orbit?
I mean, it could be, but then I'm seeing it all the way.
There
like,
you go. See, so now.
But wait. I'm seeing that thing like going around.
You're
like,
seeing
all
it
the
come
time.
into the left. No, you're not seeing it go around. You're
Why?
seeing it come across to the from the left, going out at the right, or vice versa. That's what you're seeing. And
Why?
if something
No.
was circling across a flat plane or across a topographical plane, you would see the same thing.
No, I disagree. Like
What
if
do you
I'm on
mean?
a flat,
when you see that light in the sky, how do you tell how far away it is?
it's really easy. From the travel time of the signal. I know the light speed, and I know how much time does it take to reach me.
So.
Sorry?
So you can't tell its distance.
Yeah, you can from the light speed. Like from the time it needs to reach me, the signal.
What?
Like the GPS signal, it takes time to reach me. It's not an instant. And from that time, I know its distance.
Show me your calculation.
What do you mean, show me your calculation? It's like the time divided by the speed of light. It's the time
when you see a light moving in the sky, you're claiming you're measuring the speed of light to figure out how
No, not any light.
How far away it is.
I'm talking about satellites.
So you see a satellite in the sky.
No. My phone receives a signal
so
from
you
that
don't
satellite.
see the satellite.
I mean, I could see it, but that's not the point. My phone receives
Okay,
a
so
signal.
when you see it, how does that tell you how far away it is?
What do you mean? I don't get that. So
what's the distance between you and that light in the sky that you're calling
it's very
a satellite?
simple. So the satellite, when it sends me the signal, it sends me the time, and I just divide the time of travel with the light speed.
Show me an example.
GPS is an example. That's how GPS works.
Of your
By calculating the travel time.
distance.
Like calculating
Yeah.
the travel time, you are able to triangulate your position. That's how GPS works.
Okay, show me an example. Show me a demonstration.
GPS is an example. Just turn on GPS, turn off any other data, go out. There is your example.
It doesn't. When I turn on the GPS, it doesn't tell me the satellite is this far away from you.
Yes, it does. It just doesn't show that information to your face, but it does.
Yeah. Okay. Well, that's
with
what
that.
Show me.
Okay, so I'm sure you can download some app that shows the actual satellite data,
well, you said
and you can look at that.
Is that what you're saying you did?
I mean, I used to use like GPSs before smartphones.
I don't know why you're lying, by the way. You've
No.
this. You've never done this.
I done this. Like I used
You've not done
GPSs.
this.
You know those big GPS devices back before from the smartphone era. I used a lot of those.
How far away a satellite is from you? You're a liar.
Why?
Why are you lying? Why would you lie?
I'm not lying.
You are lying.
Didn't think it was two-way communication. I thought it was just one-way communication.
It's one-way communication. It's not two-way. It's one-way.
One way, right?
Yes.
So you don't know the time. You don't know the moment the signal was received or sent.
No, I know the satellite sends the send time of the signal. That's the signal, the time when it was sent.
Yeah, so it's just data that. So yeah, it's just data you're told. Like so, it literally.
Yeah. But the problem
anything,
with that,
right?
the problem
so
with
you
that,
can't confirm. You can't.
No, you can confirm.
You don't have first-hand knowledge.
Yeah, you can have because
you never even did this. You're a liar.
Let me explain. So why
no, I don't listen to your lies. I have no interest.
It's not a lie. The time is very important.
Okay, well, then show me a screen. Show me a screen cap of the program you're using that tells you the sent time and the received time, and then show me the calculation you did that works out the distance to that.
I will do that tomorrow if you are still interested. Not today because it's already really late.
Well, until then,
we'll talk later. So my point is that I know it's real data because that's how GPS works. That's how my phone knows where I am. There's no other way of knowing where you are in a GPS standpoint. You can have cell data.
That's just what you're told.
No. That's not how it works.
You're told.
I can show you tomorrow all this stuff.
You're told that's how it works. You're told that's how it works.
I'm just assuming that you're just talking shit. So
no.
Your claim, then drop it. Move on to another one that you do have evidence for.
I will stick to GPS because it's really cool. I think you can do this in Google Maps too. Wait a minute.
This guy must be really lonely. He's been here 4+ hours.
Yeah, I'm having a field day today. Okay.
Yeah, he's figuring out the Earth isn't a ball. That's why.
Yeah.
I'm not sure. I just can't... Can you pull up GPS information in Google Maps?
I just can't imagine having such a life to where I've got 4+ hours just to sit around on Discord and hear people that I think are wrong tell me something that I disagree with.
So
yeah, man, it's hard. I can agree with that one.
So for him, we don't use triangulation for getting the position of person when you use GPS. For him, you just need one single satellite, and you can figure out the position dependent to the distance of that satellite.
No, one distance is not enough. You need at least 3 to have an accurate position.
You just use cell towers.
But cell towers are hard to install and have limited range, and GPS works anywhere, anytime.
That's the claim. But still,
no,
use cell
that's
towers.
the case.
No, no,
That's the claim,
still,
that's the case.
that's the claim. That's why the GPS don't work
Do you
everywhere.
guys have Android or iPhones?
I'm on Android, but I mean, so is it going to involve angles at all?
What?
GPS.
What do you mean
systems.
angles? Yeah, uses a lot of like triangulation, trigonometry stuff.
It's a problem.
Why? That's a problem.
What's the angle between?
The angle is between you and the satellite, and the like.
That's just 2 points. You need.
No,
you're
no,
gonna need at
so,
least 3.
Yeah. So the third, like, it's you and the satellites. Like there are three satellites at least, and that's why you can get height. With 2 satellites, you can get like location, but not accurate height. With 3 satellites, you can get accurate height and location.
But all the communications are undersea cables, 98%.
No,
it's not by
not
your
for
satellites.
GPS. Not for GPS.
No, yes,
Like
it is.
No.
Like I told him,
Cellular towers, triangulation.
No. GPS doesn't use
ground positioning system. Wake up,
Yeah.
man! You're still
Correct.
sleeping.
we use cell towers, we use
GPS
buoys
doesn't
with
use
speeds,
cable.
we use helium
98%
sending helium
of the
balloons.
world's communication undersea cables.
Can you show me one source that says that GPS uses cables? Like one source, a single one.
I thought you knew this.
What?
Undersea cables.
Yeah, I know that undersea cables are existing, but GPS has been nothing to do with them.
Yeah, but I'm saying the communication comes from that. 98% of the world has nothing to do with your satellites.
Yeah, but wait. Undersea cables are internet, right?
In communication, yeah.
No. It's internet mostly, like 99%. It has nothing to do with GPS.
Yeah, but
like,
still,
there is no
cellular
GPS
towers-
communication going through undersea cables. Can we agree on that one, right?
And cellular towers communicating with each other.
No. It has nothing to do with GPS. Nothing.
Ground
Like
positioning
turn off,
system.
just dismantle your phone, grab the parts that doing the. Okay, this might not be working, but you get what I mean. Like turn off like cellular data, turn off everything on your phone, and just leave GPS on, and it will still work. Go to the most remote place that you know with a clear sky, and GPS will work for you.
That's what you believe, man.
No, that's what happens. You can try it. Just go there.
No, I'm sorry, man. I don't know. You just believe things. I'm sorry.
Yo, dude, hold on.
You can try it.
Let me say something real quick. Look, a few years back, I'm gonna make it short. A few years back, when I was in Florida, we had a hurricane, and we had to leave the state, right? So on the way out of Florida, right, at some part of the town, right, we went through the small town and stuff. GPS didn't work, right?
Yeah,
and not just a little bit. There's a bunch of fucking time. So yeah, no. So
yeah,
you claim GPS will work all the time? No, bro. That's
no.
Yeah,
What
I don't
did
know
I
where
say?
you get that information
What did
from.
I say earlier, dude? What did I say? You need a clear sky.
How convenient, right?
No. You cannot, like, the problem is that the receiver in your phone is weak, and unless there is a clear sky, it cannot really receive the data. Because
so how do you know this so-called satellite in outer space? How are you going to verify the distance?
Like, that's the main data. That's why you know your location, because the main data that you are calculating with is the distance between you and the satellite. That's the core of the data. That's the only thing you need to triangulate your position.
So let me clarify with you 1 second. Okay? Like, look, we don't have no problem with the satellite technology, right? We know there's drone, there's airplanes, aircrafts, jet, satellite on balloons, right? High altitude stuff, right? And we agree to that. But what we disagree with is that we don't believe they in the outer space just like you imagine.
Yeah, but
right? That's where we disagree on. That's where we disagree on. We don't have no problem with the technology, dude.
Okay, so if you are okay with satellites, why doesn't they just fall down?
What? Oh, they do. They do.
How?
They do.
Yeah.
There are thousands of
Oh my God.
satellites. There are thousands of satellites in orbit without any propulsion. Why don't they fall down?
That's you
You're asking
believe that,
us?
right? That's just a story. You
He's
believe.
asking us.
Okay, so different question. I'm sending up a satellite, right?
He's asking us, why does it fall on the globe?
How much proportion do I need to
They
keep
fall
the
down
satellite?
all the time, bro. You never seen those those picture, those memes?
Wait. How much fuel do I need to keep it to stay in the sky for like 100 years?
Look, the one that on balloons, right? Yeah, I think they're just on balloon. That's it. And when they come crashing down, they just come crashing down. You never seen the videos or pictures before.
Yeah, cell triangulation works, but it's not GPS.
Yeah, like we've got no problem with system, positioning systems being utilized over a plane. I mean, why can't it work on a plane? Are you saying that you can't use trilateration over a plane using technology?
No,
in
I'm
the sky?
saying that all I'm saying is, and it has nothing to do with GPS, by the way, that the orbit that the satellites take doesn't make sense on a flat Earth.
But you think they're in orbit. That's the thing. You think that they're going around a big ball. We could get. I could just simply go to. Well, that's going to require knowledge of, because of the claimed functions involved, the equations and the knowledge that's required. You will need.
Look, guys.
You will need to know the distance. Yeah, dude. You'll need to know the distance between two masses, which would mean you'll need to know the radius value of the Earth. So if if you can't verify that part, then you can't verify anything.
No, I don't want to verify shit. I know the globe Earth explanation for these things. I know how they work. I know how to calculate.
Yeah, explanations are great and everything.
Okay.
But they require evidence, right? And the evidence would be in the form of a radius value. Right?
How do you explain the same thing? How do you explain the same thing?
No, I don't need to explain anything, right?
But they work. They work.
Listen, dude. If the basis for the claim, right, isn't true, then the claim isn't true either. And the basis of the claim is knowledge of the radius of the Earth.
No, the basis of
if you don't have that, and if you can't verify that, then you can't verify the claims which are based upon that.
Dude, the basis of my assumption or I don't know, idea, I don't know, the basis of it is that there are a bunch of technologies that are working, and the way they are working are explained through a spherical Earth. Okay?
Yes, that's what I just said. Radius value, exactly. Radius value. And if you can't,
no. Wait a moment. Wait. Let me finish, please. Let me finish my idea, please.
Okay, go on.
All I'm asking for is to explain the same things with flat Earth.
No.
Why?
It's not our responsibility to have to explain anything.
But these things are working.
It's your responsibility.
Okay? No. These things are working.
If you're going to defend this position, then it's your responsibility to validate the claim.
No.
Claim is that there's knowledge of the Earth having a specific radius value, right? 6,371 kilometers or 3,959 miles. You can't validate that claim upon which all the other claims are built upon, and you got nothing.
No, it's working. The systems are working.
How it doesn't care if it's working. I don't care if it's working. You're told a story about how it's working, and the validation for that claim would be in the form of verification of the radius value of the Earth.
But, no.
I'm not validate that.
Wait.
You can't validate that. Then every other claim that's built upon top of that single claim is not verifiable.
And that's called circular reasoning. What he just said, that thing, if that thing works, so the Earth is a globe. So that thing works, therefore the Earth is a globe for him. That's his reasoning.
No, that's not my point.
Also, a fallacy of pragmatism.
That there are in-depth explanations with models, with mathematics behind them for a spherical Earth and how things work on there. Okay, there is like in-depth explanations for everything. Okay? Can we agree on that?
That's wonderful. You're told a story about a technology which you benefit from, which
Yeah,
you
but
can't replicate
there are
and you can't achieve.
there are
Right?
in-depth
You can't
explanations
verify.
about these stuffs, right? Or did
What?
agree with that one? Like, so there is in-depth mathematics as an explanation for all the phenomena that we experiencing.
There's in-depth mathematics for how Superman can fly too.
No, they're not, by the way. But
yeah, there is. People have done it. People have calculated or given all the equations for how Superman's able to achieve flight.
Wait, how does that work? If you can show me the explanation.
Yeah, I don't know if anybody's got it. I've seen it before. I haven't saved it. You could
but it's
do
not
a quick
working.
Google
The
search
point
on it.
is, you can make calculations about
But
Superman's
it works for
flight.
Superman.
It's not working. No, is Superman real?
Yeah,
Is the
like
globe Earth real?
that's what he said. Matt, you can use math just for telling even stories in a book, in a literature book.
Yeah, but I think there is a
you
difference.
can use math, and that doesn't say that
No,
the
I agree
book is
with you.
scientific because there was math. You can use math
The problem
to
is
describe
that
anything
stuff
that you
works.
want.
Like planes,
And that depends.
fly, GPS works,
No,
and it's all
that
based on a
depends.
globe Earth.
Oh my God. And I can show you.
No. I'm not saying that's the case. I'm just saying that I doesn't see the flat Earth explanation for these things.
I can show you.
Don't need one.
Why? I need one. I want one. I want to see one. I would like to engage with it.
Pilots are trained to treat the Earth as flat and stationary, and the aircrafts are designed for a flat, stationary Earth that discounts gravity.
Yeah, but
So,
the mathematics behind the planes are not assuming a flat.
Wait, if I show
they
you
are.
now from NASA website a PDF from NASA where they say that the models that they usually use are flat Earth non-rotating Earth models.
Yeah, they are simplifications. I can agree with those.
That's NASA saying that for their
they are
explanation they can use, and they usually use flat Earth models. For example, another example, flight dynamics. They assume a flat, non-rotating Earth, so flight planes. That's completely no. You don't agree because that's completely opposite of what you just said.
Yeah, but these are
earlier.
simplifications. The same way you can simplify.
You don't use explanations. You throw some bunch of excuses to say that that thing can work on a globe, but it's not the reality. We use flat, non-rotating Earth assumption to make anything. Fly a plane.
No. You're taking things out of context.
No, I'm not taking things.
Oh, here comes the Mr. Pilot guy to rescue. Come on.
I am a pilot.
Yeah,
you are a pilot.
So
And
what?
in the flight dynamics system summary, in the first page, you have to assume when you fly a plane, Mr. Pilot, or we will crash it. You have to assume that the ship that you are flying above is a plane.
No.
That's why it's called an airplane, because it's dragging on the air above a plane.
Wait for him to finish talking, or I mute you.
It's not an air.
You don't know what you're talking about.
It's not an air sphere. You don't fly an air sphere. You fly an
You're
airplane.
taking words out of context.
No. I don't take words out of context. We are talking about planes, airplanes. They are not air spheres. And in the first page, you have to assume that you are flying on above a flat, non-rotating Earth. Is it correct or not? In your flight dynamics system summary that I can put for you if you never read it, I can show you that you have to assume a flat, non-rotating Earth.
I've read it.
Let's just give him a chance to respond.
They also assume that the mass of the aircraft is constant. That is impossible for any fueled aircraft. The mass of an aircraft, as it flies, it consumes fuel, and the weight change, the mass changes. They're talking about simplifications to complex equations to make them more understandable and implementable in models. They also assume flat Earth for pilots in their beginning to keep their training simple, because their early flights are very close to an airport and things do appear to be flat Earth. But in fact, intercontinental flights take into account the spherical nature of the Earth. You guys are just wrong, cherry picking, and taking things out of context.
Nah, us. You're wrong.
The plane have a.
You never dipped the plane, though.
The plane
Are
have.
any of you guys? Do any of you guys have a license?
Listen. The plane
Do any of you
has a
have a
fixed.
license to fly a plane?
The plane have really a fixed mass. We don't talk about. No, we don't talk about the people on the plane, and we don't talk about the carburant in the plane. We talk about the plane itself.
What about all the tons of fuel that a commercial airliner uses?
Do you understand?
And they have to
When we
account
talk
for the
about the mass of the plane, we talk about the plane itself.
No, that's where you're wrong.
Yes.
Absolutely
Hold on a second. I've
wrong.
got a quick question for you, atheist. Including the accounting for fuel loss, do you change your angle of attack when you're doing a long distance run?
In fact, I don't fly commercial jets, but I know that they actually pump fuel from tank to tank to maintain center of gravity, so that the angle of attack doesn't have to be changed substantially. So they're always accounting for loss
to keep
of
their plane
fuel
flat and
weight.
level. That's what they're doing. They're accounting to keep it flat and level so they can continue their appropriate angle of attack. They don't pump fuel to fly around a ball.
They pump fuel from tank to tank to maintain center of gravity. What you're doing too is you're taking the phrase flat and level out of context. Level in surveying and aviation does not mean what you think it means. It actually means constant
Let's just segue
elevation.
into something else awesome.
It means
so what's eye
constant
level mean
elevation.
then? What's eye level mean then?
Say again?
What's eye level mean then?
What's the context? Give me a sentence.
In surveying, you said surveying. In surveying, level doesn't mean what we think it is.
I said level. In
level.
surveying, level means a line of constant elevation above the ellipsoid.
Oh.
Yeah.
Oh,
so
so
what's eye level?
When they use a
eye level mean?
I didn't say eye level, so you're going to have to explain your meaning of eye level.
No. When you use
level.
When they use, you said level. Yeah, when they use a bubble sextant.
Correct.
And it's not a clear day. That line coming from the sextant, is it a level line or a curving line? Because they use a tool that help them have established the level for the sextant. So that line that you have, that baseline where you will start measuring your angle, elevation angle, that baseline, is it curving following the curvature of the globe, or is it a straight line? Because you said that they have different meaning of the level as than us. So it means that.
But now we're discussing the difference between level and horizontal.
No. We are discussing the difference between level and level, because you said that level is not just level; it's another level, which is curving.
Can he finish his sentence, maybe, please?
Level is a line of constant elevation over the ellipsoid. Go read any surveying book, and that's what you'll find. Horizontal, when you bring in bubble levels, what you're talking about is a horizontal line that's perpendicular to the vertical. What the bubble level shows you is
at
the
all
vertical.
points. At all points along that horizontal. At all points along that horizontal. Yes, otherwise it's not horizontal. Otherwise it's a slope.
That's correct. It's a horizontal line.
No, it's not horizontal. Horizontals don't slope, dude. Horizontals do not slope.
Well, again, with all due respect, go read any book on surveying. We are talking
Yes,
about
I know
the
what
shape
they
and
like to
size.
think horizontal is, but what they term as horizontal isn't what horizontal is and isn't how horizontal's used.
And you are wrong. We are talking about the shape and size of the Earth. That science is known as surveying. We should use surveying technical words.
The fundamental part of surveying is establishing a horizontal plane of reference, level.
Correct. And for small projects, for small projects under about 10 kilometers, it's called plane surveying. They worry about horizontal. Beyond about 10 kilometers, they do geodetic surveying, where they take the curvature of the Earth.
Normal surveyors just upload their data to geos so they can then fuck it around and turn it into a ball. Don't give us your shit because one of the other blokes has already looked into it.
Yeah, you guys are believing bullshit. Go read a book on surveying. The first 3 chapters of Surveying for Engineers will set you straight. But right now, you are wrong.
Okay, so how many of these 10-kilometer flat sections make up a ball tide? Just out of curiosity.
The answer is infinite.
Now we know how special you are.
Right, but the 10-kilometer range is for where they use plane surveying for building buildings to make sure that floors are level.
You've got a completely level 10-kilometer range, and you still believe you live on a ball. How many of these 10-kilometer ranges linked together to make a ball?
You can have a much larger level area than 10 kilometers. You can have huge level areas. They are not happening in nature, of course, but the level area...
So how did you get level then? Hold on, Taylor. You just stepped up to the plate. How did you get level if it doesn't happen in nature? You've got your theodolite out there. You've measured an entire area off level, but it's not level. Well, is it level or not?
There is no distance change from the center of mass of the Earth. That's how it's level on a
And yet you've still got to prove this. So we're back to circular reasoning, begging the question.
No.
You're using the ball to prove the ball.
No, why does...
Yes, you just did. You have not proved curvature. You're using these tools going, these prove a ball,
why
and it's
are you
proven
so
nothing.
angry, man? Why?
This is
why
normal
are you
boring, I just got out of bed.
We are talking on a normal...
Don't worry about his demeanor. That's just Matrix. Matrix is Matrix. You take him or you leave him.
Yeah, I'm assuming you are very...
You are confusing horizontal and level. Go read about them in a surveying book.
Okay, post
I will show you. I will show you that the level is horizontal. I will show you the test that you can do by yourself, just to make sure that horizontal is level and it is perpendicular to vertical.
It's only perpendicular to vertical at the one vertical. As you change positions, horizontal will change. Horizontal lines.
That's ridiculous. That's absolutely. That's ridiculous, dude.
Hey,
full story.
Don't argue with me.
Fucking
change. Don't argue with
parallel.
me. Go look.
Dude,
go look.
You're not even talking about horizontal by definition.
No, I will show you the test done by a surveyor. You can go and talk to him, and it's not a flat earther neither, neither a globe earther. I think the guys here knows him. It's Bevice. Try thinking, you know.
What's the experiment?
He is proving that horizontal level is horizontal, perpendicular to the vertical, 90 degree to the vertical. I will show you that.
Okay, I'm waiting for it.
At one location.
No, all verticals are perpendicular to the plane of the horizon. So anywhere on that horizon, perpendicular to that, 90 degrees, is vertical, and they are parallel.
Yep.
But they're not parallel. To each other. Don't argue with me. Go study some surveying.
No, stop.
Never do.
How do you have parallel verticals? How do you have parallel verticals on a ball?
Parallel, you don't.
You do. Apparently you do, because at any point along that horizon, perpendicular to it is 90 degrees vertical, right? That doesn't exist on your ball, but it does in reality.
No, Parallel. So if you were to look at pillars in a building, each of those pillars are.
I'm talking about at
vertical
any
and-
point on the horizon.
Yeah, but you gotta let me finish. In a building,
Yeah, you can't have that.
local
You
or-
can't have that. How do you have a horizon?
in a building using local surveying, they worry about establishing a baseline horizontal for the project for the building, and
How the
then all
fuck
the
do
vertical.
you have a natural reference to horizontal nature in reality on your ball thing
It's
upon
called a
which
plumb line.
any
It's
point
a plumb line.
90 degrees to it is vertical. Those verticals are
It's a-
parallel.
No, they're not.
Yeah, on the horizon
plumb
they
line-
are.
How can you
plumb
prove
line
that they are parallel?
establishes vertical at a point.
What experiment that can we do that proves that they are parallel?
Show me the measurement of the slope of the horizon.
No. What experiment can we do?
Where the word horizontal comes from, right?
Yeah, but that's circular reasoning.
No, you're.
No, it's not. It comes
you're
from
conflating
the
words.
horizon. Horizon itself, a marine horizon, is a reference to horizontal.
Yeah, but that's not
All
level.
horizontals are
How do you
parallel
know-
with
how
the
you-
plane of the horizon.
How do you
There's
know
no
that's
plane
level?
of the horizon. Does the plane of the horizon not exist?
Wait, how do you know it's in level?
Maybe you should go
It's a
to every
tangential
fucking
line.
dictionary in the world and tell them they're wrong.
Yeah, but dictionaries are not like experiments.
Go
You
and
can
tell
say
them they're
anything.
wrong. Go and tell
No, no,
these
no.
learned, studied,
say anything.
academic authors of dictionaries that they are wrong.
You can say,
Go and tell them.
Merriam-Webster-
Come back and tell us what they said.
you can say
The
anything,
average
but how do you
dictionary-
prove
the
by
av-
experiment?
The average dictionary is for general use. Surveying is more specific and more accurate for the use of measuring the shape and size of the Earth.
So how come it's never been done then?
It's done.
It has
multiple
been done.
times.
Bullshit.
Look,
Okay.
go
You still base it off
go
prehistoric
research-
shit, off angular fucking view,
No,
which was all
go
presumed anyways.
Go research triangulation networks as was done in France, England, and India.
Triangulation.
And then come back
how
and-
does triangulation work?
Right.
You make triangles. Define a triangle for me.
Well, it's an object with three sides.
3 what sides? Excuse me.
So triangles doesn't exist in
Taylor,
spherical.
shut up.
Yeah, what you're trying to get me to say with straight lines. But
No,
a
no,
line
no,
can
no,
be
no. That's not
straight.
right. That's not right.
Taylor, zip it.
That's not right.
Atheist,
Wait,
Yeah,
wait, wait,
see,
wait, wait.
define a triangle for me.
Yeah, it's an object with three sides of usually straight lines. But
Oh,
from
usually
point to
straight.
point, there's
Yeah, usually
Did you
because
play on school or something?
guys, on a perfect plane on a countertop, piece of paper, they're perfectly straight in all dimensions. On the Earth, they're straight in one dimension, point to point, but they follow the curve of the Earth, and that's why
Then it's not a
spherical
triangle. Then I asked
trigonometry.
you to define a triangle, and you're just beating around the bush. So if you want to play with your sophistry, fuck off elsewhere, mate.
No, I'm not playing around. What I'm saying is consistent.
Well, answer the
You're
question.
using the-
Stop being a weasel
I
and answer
did.
the question.
I
What?
did.
Define a
You're-
triangle.
Yeah, I just did. You're using
you
the
didn't.
general purpose. Shut the fuck up for a second. You're using the general definition of a triangle. I'm using the
What, so they magically
surveying
change?
definition. Yeah, they
Triangles
do. They
change.
get the use of the triangle, the knowledge of the triangle changes.
No,
in a
I didn't say the
specific
use of it.
application.
I asked you to define the triangle. Define it.
I'm defining it as surveyors define it. Put three sides on the surface of the Earth.
He won't say straight sides because he knows fucking well that's all I want to hear him say.
Point to point, they appear straight, but the curvature of the Earth
They
must be
appear
taken
straight.
into account. How many? What's the sum of the angles of a triangle?
You're the one who's supposed to be defining it. Stop asking me shit.
Well, so you're allowed to ask me questions, but I can't ask you
Well, you
questions.
haven't answered the question yet. You're a liar, so answer the question.
I've answered every one of them.
No, you
On
haven't.
a
You
plane,
weaseled your way around it.
no, on a plane surface.
Yes, you have.
the
You
interior-
weaseled your way around it. Just say
Would you
it.
shut up and
3
let me
straight
finish?
sides. Three straight sides with
On
the
it.
sum of all internal angles equal 180 degrees. That's it.
Right. And
So
what,
now,
okay, now
how did you get straight sides on a ball?
extrapolate that to the surface of the Earth and tell me why triangles don't close to 180 degrees in reality.
That's your claim,
Cool.
dude. You
That's
don't
just a claim.
you don't get to
look.
put the burden on someone else for your claim. You claimed it. You fucking demonstrated.
No. This is again. I said
Yeah. Don't think you're going to dictate how this fucking conversation goes, dickhead.
go read a book on surveying. You
So
don't have
post
to
it up.
trust
Which
me.
book? You've told us about this book multiple times. Post it up because there's thousands of them.
Yeah, I'm not where
sifting
I
through
can
your
search,
elephant
but
shit. Come on.
I'm not where I can search. But the name of the book, an easy book to get, is Surveying for Engineers, the 5th edition. You can Google it. You can find it online for downloading as PDF. Read the first 3 chapters. And then you'll learn the language of surveying, and then we can have a
They
rational
assume.
conversation.
Yeah, do they
about
assume that the Earth is a
safety
sphere to begin with? Do they assume the Earth is a sphere to begin with?
Yes.
Through trying to close triangles on the surface of the
Do you find
Earth,
it difficult to answer questions? You know,
I'm getting there.
yes or no?
The triangles wouldn't close to 180 degrees.
Do they assume Earth to be a sphere to begin with?
No, they don't. They iteratively determine using. They do not. We do now
don't.
because
Okay.
we know. But initially they didn't. Initially they went, oh, the sum of the interior angles is not 180 degrees. Why? And then they figured it out.
Post
and
that
they
for
came
us.
up-
Post it where they were like, they weren't sure, they didn't know, they had no idea at all what the surface is, the nature of the surface is. And then they went out and did it and went, holy shit, we've got to tell the world, it's a ball. Post that now when that happened.
Go read.
Post
I'm
it.
not where I can
Post it.
I'm not where I can post anything, asshole. Go do some research. Research.
In other words, I'm not going to support my fucking claims, so you can just shut up. Moving on. Does Taylor still want to talk?
I sent him a video in the chat where he can see that level is horizontal and perpendicular to the vertical. And
guys, the triangles. I want to talk about the triangles. So, do you know spherical geometry by any chance? How to do that with math?
Okay, we're going to try it on you. Define a triangle.
Yeah. So, in spherical geometry, the
No,
triangle
I
is a
didn't
bit...
define a triangle. Or maybe you might have to do two, Euclidean and non-Euclidean. We'll see how that goes. Don't like triangles? Miss second class?
So the definition of triangle is 3 sections of 3 great circles that are like touching each other.
I don't remember learning that at school. 3 sections of 3 great circles.
Yes, because in school they doesn't teach you spherical geometry, I guess, because you doesn't went to university.
And you...
Yes, I did.
I didn't say you didn't. I asked you to define a triangle, and you said
I just did. There are 3 great circles that are touching.
So if I draw 3 great circles on a bit of paper, I get a triangle.
Yes, but I'm not sure how can you do 3 great circles on a paper. You might be able to do something with like
another fucking weasel. You're just as good as the other one.
But what do you mean? Do you know what a great circle is?
Yeah, I do know what a great circle is. So you're using, think about it, circular reasoning. You have to prove the ball in the first place.
I'm not talking about the Earth, man. I'm just talking about triangles. I don't know what you are talking about.
So define a triangle.
Yeah, I just did.
You did not. You said 3 great circles.
Yes, and they define a triangle on spherical geometry. And if you learn spherical geometry, then you know how that works and how to calculate with it. But I assume you did not learn that.
Oh, triangle. From the Cambridge
Tell me, within your...
A flat shape with 3 straight sides. Why couldn't you say something along the lines of that?
Yeah, but that doesn't work in... Wait. That doesn't work in...
It doesn't work where? It doesn't work where? I want you to
say... It's in spherical geometry.
In spherical
So what would a triangle?
Yes.
What would a shape like that? So what would a shape like that? Just was it? What would a shape like that on your sphere be called then? If it's not a triangle.
The triangle. You mean like a classical triangle? It doesn't exist in spherical geometry.
What if you were to like draw that, like actually
You
cut
cannot.
a piece out of your sphere, right? Are you saying that triangles don't exist?
Like classical triangles doesn't exist in spherical geometry. Yes.
What about in reality?
Like,
can we have a triangle shape in reality?
In reality, mathematical concepts doesn't exist in reality. They only
You can't make something into a triangle. You can't have a triangle shape of something. You can't.
Yes, you can, but
produce something in a right.
That's not the.
You can measure the angles of it, right? You can measure the angles of your triangle.
Yes, but that's still
reality.
not a mathematical idea of a triangle. That's just a shape.
Oh, nice. Like he said, mathematical concept doesn't exist in reality. So
Exactly.
their globe is just composed from
he's talking
mathematical
about
concept.
non-Euclidean geometry.
No, but their globe paradigm is composed from just mathematical concepts.
No. They are mathematical concepts
that they never existed in reality at the first place.
No. They are mathematical concepts
Don't
which
contradict
can be
yourself.
into models.
Hey, how can you base your whole life off predictions? What is wrong with you?
You can test those predictions. Like, for example,
you've got a ball that's a mathematical construct, and not a minute ago you said what? That maths is what? Say it again.
Yeah, maths is completely made up. It's just in our head.
So therefore, your ball is completely made up. That's it.
Because just in your head.
Good enough for me.
I agree with
Doesn't exist in reality. It's just in your head.
A perfect ball doesn't exist in reality. I agree with that.
No. The sphere Earth that you are thinking about, that you believe in, is just made up mathematics.
It's made
so
up
it
with
doesn't
mathematics
exist
too, yeah. But
in
the
reality.
predictions that mathematics makes are correct and they are accurate.
Yeah, one unicorn plus one unicorn equals
guys,
2 unicorns. The math is correct, but that doesn't say that the unicorns are real.
Don't drop out because this is mostly the result of it, because I cannot argue with you, because you cannot even grasp the basic concepts like mathematics and how to prove things and how the models work. Once you are having a grasp on that, we'll get back to these more complex things, right? So have a great evening and good night.
He just got his ass dealt, so he's going to drop out. See you, mate.
Oh, wait.
Sorry. Oh, you're back already? That was quick. Wow. I need a bigger stick, T-Dub.
That guy was in here for literally like 6 hours.
What?
Wow.
Yeah, he's been in here for about
Holy
6
shit.
hours non-stop, man. Busy.
I've been here for about 2.
Even with all the citations given to him about the plane horizontal reference, he wouldn't have it. I don't know.
Was it in here? Was it in here or in politics? And there was Donald C. was having an argument with Matthew Learns, right? The two globers were going at it. Matthew was trying to explain to him that a spherical triangle is not a triangle.
Yeah.
It was fucking funny. And Donald C. was just like double and... Eh?
He said the opposite, Donald? That is?
Donald was disagreeing with Matthew Learns. Matthew Learns was trying to tell him, no, a spherical triangle is not a triangle. Like, they were going at it, man. Donald C. was doubling down against the math professor. No, he's not a professor, but he's a math teacher, right, in the college.
No, but the funny thing is with that guy who was talking about the triangle, which is those 3 great circles intersecting with each other, forming a triangle, and he also said at the same time that triangles don't exist in their spherical geometry. So you could find a triangle in a sphere using those 3 great circles, but you couldn't say that, and he said also that doesn't exist. Just a contradiction.
I'd say perfect triangles don't exist, but I mean, we can form matter into triangular shapes and measure the angles between them, between the indices. But I don't know, man. Like, what the fuck? That was so hilarious.
We got to try it. Hey, Kembo. Oh, he's not. There he
What's
is.
up, Metric? What's going on,
Can
bro?
Can you define a triangle for me?
3 straight line.
Well, you did better than those other bullets.
You got to add up to 180. There you go.
There you
Right?
go.
You can't have a code baseline.
Oh,
Yeah.
wow.
There you go. I think that's my best right there. I think it's close enough.
Oh, shit.
Curved angles, yeah.
Excuse me.
And
Sorry.
level isn't what we think it is, right?
Yeah, that pilot guy is a fucking idiot.
Yeah, I mean, what the hell he was talking about? He said, well,
Spewing lies,
in the
man.
survey, level doesn't mean level. Did he say something like that?
Yeah,
What's
except within 10 miles, you can treat it like that if you want. Like,
Watch the video that I just sent, where you can see that level is horizontal.
So the manuals talks about they have to assume have to fly like that when they learn. We even had a grad student, a pilot that was going for the pilot certificate in here a while ago. He said, "I'm flying fucking level." He never dips the plane.
Yeah.
I don't get this. People are lying. The opposite.
he's talking about it's just trying to keep its center of gravity, right? So so where the center of the gravity of the plane is, right, that's perpendicular, right? That's to the surface, but the nose of the plane is actually sloping up, right? And the tail of the plane is also sloping up. So it's like this.
What kind of airplane is that?
It's called an airplane, not an air sphere.
We need a banana with wings. Make sure
Yeah.
it's bent up, though.
It's like a banana, fuck's sake.
Belly down. So tail up, nose up.
On a globe, to fly an aircraft in a perfectly straight line, like if it was hypothetically possible, right? So to fly an aircraft in a perfectly straight line, you would actually have to constantly change direction, right? You would have to manually maneuver like the controls of the aircraft constantly to keep going in that straight line, when going in a straight line is literally not changing direction. How does that fucking make sense?
Yeah, and they have to tilt the nose up of the plane to lift the plane to make it follow that straight line. If not, it will just follow the curve. And it's called airplane because it flies through the air above a plane. It's not an air sphere. It's an airplane. They should know that.
If you were to fly in a perfectly straight line in an aircraft, you would be like roughly gaining altitude 8 inches per mile squared.
Yep.
You be in outer space about like an hour or less.
Oh, but it's so minuscule you wouldn't even notice it. It's all based on your relative speed. Go and have a talk to any of the SR-71 pilots and see what they say. Oh, yeah, we had to nose down 66 feet a minute just to make sure, or was it 600 feet a minute, just to make sure we didn't take off up into who knows where.
Have you ever seen that video from that German pilot, that woman? that realized that the Earth is flat after she stopped working in
Gyroscope.
airplanes. Yeah.
She took a gyroscope on an aircraft. Yeah.
Yeah.
I mean, have you seen those fighter jets that just like skim right above the water, right above the freaking ocean, man?
I seen it.
They almost tip their wing and like splash the top of the water with the wing of their plane. I mean, they're that close. They're going that fast and they're navigating that much curvature. You know what I mean?
And I swear they never took account of any curvature at all, at any moment. They never took account of any curvature. They just follow that leveled surface of water. And it's easy for them, letting the plane just being just going through the air because of that air drag, because of aerodynamics. So it's easy for them. Then pulling that munch and pushing it to make the airplane go down and follow the curvature all the time. And they go supersonic. And notice when they go in this straight line, because there is no what they call it? That centrifugal force, because of that angular course that they will have to follow around the Earth. There is zero g-force. They are going in a straight line, literally. There is zero g-force. They are not making a circular path around the Earth. If it is, it will just create a slight g-force in the plane because of the centrifugal force. And turn the plane, you will get centrifugal force. You will get g-force that will get higher and higher, tighter the turn that you make.
What happened to our marathon globetard there?
My stick was bigger than his.
Hey guys, can you riddle me this?
Can we riddle you this? What do you got?
They are loud and obnoxious, they like music that rhymes, they're a fraction of the population, and they commit half the crime.
One more time, bro.
They are loud and obnoxious, they like music that rhymes, they're a fraction of the population, they commit half the crime.
Now, just before you answer this, if this turns out to be racist in any way, shape, or form, I am going to ban you.
No, it's not racist. It's
Good.
a riddle.
I'm just making it quite clear up front.
Yep.
I wouldn't have a clue. I've always been hopeless at these riddle things.
I was gonna say feminist, but okay. I think I'm wrong.
It's close.
I think the point is nobody cares.
What did you say?
I think the point is nobody cares.
What?
Hey, Matrix, do you want to give him the honor since he's not able to understand?
Why do they point it back to me? All right, what's the answer to your riddle, mate?
I think he's just clowning.
I don't think he's trying to answer it in a way that's not racist.
Yeah.
Hey guys, sorry, my mom came in the room.
So yeah,
Your mom came in the room, and
Yeah, man.
you're in a Discord server, and then you're worrying about your mom coming in the room.
Yeah, man. She can beat my ass any moment.
So what is the answer to your riddle?
I don't know, man. I'm just asking, like, if people can riddle me that.
Well, anyways, what's the weather like where you are, JE?
It's nice and sunny. It's hot, but not excruciatingly hot. Not too humid. It's
right now,
mostly
it's
sunny with about 300 chemtrails.
Right now.
I'm still concerned about the sunny bit.
Is it sunny right now?
It's sunny right now.
How sunny? Right
Same
now?
here.
As in sun right up. That's because it's like bright outside and shit, man.
We have the 24-hour sun here.
Ah, right. Same as Antarctica. Yeah, cool.
Well, no, I am in Antarctica, so I see the sun 24 hours a day, 365 days a year.
Oh, that's too good.
It's my fault. I invited the three amigos down here.
What happened?
It was your fault.
Your fault.
You brought him in.
Me? Who, the guy?
No. JE. It was JE's fault.
Oh, yeah.
It's my fault. I invited the three amigos down here to see the 24-hour sun that's down here 365 days a year here in Antarctica.
Oh, okay. Interesting.
I mean, it's definitely proof that we don't live on a flat Earth. I mean, so now the three amigos can go on to their Twoo Earth or whatever it is. And charge $250 to eat dinner over a video conference. Yeah, but that one guy, I don't know if you're supposed to pronounce his name Taylor or how he pronounced his name, but man alive, that I have to give him some credit. He was on for very close to 5 hours. I have to give him some credit for that level of
yeah, that level of stamina he had.
And to just say one ridiculous thing after the other, and no, that's not proof of the globe. Let me give you one. No, that's not really proof of the globe. Let me give you one. No, that one's not either. He just one thing after the other, and then he would say, "Oh, I guess it really doesn't prove the globe." My favorite part was when he said 3 sunglasses prove quantum entanglement. That was the funniest part.
Yeah, he took it back, but he didn't apologize. for lying.
And how many times he said that he would tell us tomorrow something.
Well, guys, time for me to go to work. You have yourself a great day, whichever part of it you're in, and I'll catch us all later on.
Right, man.
Later, bro. Take care.
I guess you all don't have the Labor Day holiday there, for better or for worse. I'm kidding, of course. I know you don't. Have a good day, brother.
Yeah. Cheers, mate. See yous.
Hey, Necro, what's going on, bro? Long time, man. How's everything? If you can hear me. Well, I guess he's not here at the moment. So, what's going on, guys? How's everything?
No, just getting dinner started, my man. How about yourself? How are you doing?
I'm good, bro. I'm good. Just I couldn't talk that much today. I just listened most of the time. But yeah, I heard that guy Taylor. Yeah, it was quite funny. Very funny. I think he kind of conceded a little bit when he was talking to Says Who, and I think he also maybe apologized one of the thing because he sent the citation of the paper or whatever, and he never read it.
Yeah, that's the only part he apologized for not backing up his claims.
Right. Well, you know what? I wouldn't be surprised if he's gonna come back tomorrow,
Oh, he
or
will.
maybe in the future. Yep, in the future.
Oh, he will. He will.
Yep.
I gave him some citations and materials. He's going to read through. He's going to come back. It's going to have another go, round 2, 6 hours.
Yeah, but see, the thing is this, right? Like, well, we're not denying the refraction, but the way you explain to him, like, you know, what type of refraction we talking about, and what he's thinking, two completely different things. Because, you know, he believes that refraction, you know, was somehow the object is being refracted, right? The object being blocked by this curve already, right? But somehow refraction how bend light around that and let you see like the whole object, right? And that's what he believes. But the picture that he posted, earlier with the train, bro, that's like that's like heat distortion, right? Remember the train he posted earlier? And I don't think he understand that whole point, what we talking about. We never even got to that, right? Because you were trying to break down to him so he can understand, but I don't think he understood that part.
Yeah, it was quite the hurdle to go through with him about some simple thing. I even asked him about which model he's using. I couldn't even tell me that. Which refractive model? He said any refraction doesn't matter. They're all the same.
Well, how many refraction we have? Like about what, 5, right? 5, 6, maybe. The looming, the stooping, the sinking, the floating.
Immersion, yeah, so yeah.
Yeah,
A ton
there's
of
a
them.
bunch of them out there, right?
What annoyed me about the
But
medium, he kept saying medium, multiple mediums in air.
yeah,
When air is one medium.
yep. Who we got in here? Elijah? Is that Elijah from 24/7? Elijah, is that you?
And yo, Campbell, I'm really sorry. I was here. I heard you, but I was playing an online game and I couldn't pause it to remove the mute. I'm so sorry, brother.
Yeah, no, it's all good, bro. Yeah, I haven't seen you in a long time, bro. Hopefully, everything's all good on your end with you and your
And
family.
summer, so it's just beach all the time.
Cool, cool. Hey, so did you ever go to go on a vacation with the family?
Yeah,
You did?
yeah,
Awesome. That's good, brother.
yeah.
Yep. So when you were on the plane, did you see any curve?
No, never.
Not slightly, on the edges maybe. Through the window pane.
Yeah, on the edges of the window.
Yeah.
If you try to focus to see it, but you know it's just the edges, like when you see something distorted in the edges of any glasses that are meant to correct the view, you will see different picture than the center. So because that's the curve on the lens itself. So like the window.
Yeah.
Yeah. There's one kid the other day, a few days ago, he came in here. It's like, yeah, you can see the curvatures from airplane. I'm like, well, can you show us the proof? Right? Like, are you sure you're seeing the curve? Right? And he was trying to fight his way out, but then I posted one of the Neil deGrasse Tyson, right? From Joe Rogan podcast. Like, you don't even see the curvature from, supposedly what you call the Red Bull jump, you know. So how are you going to see the curvature from airplane?
Yeah, and that is supposed to be a large section of that curvature that is hiding the boat, because when you're on a plane, you see larger distance than what you when you are on the surface, because the horizon side to side, if you are on the surface, if you're on the beach, it's you see bigger than the distance if you are on a plane, if you are higher altitude. So that curvature that we're hiding that boat, we never see it from here, from the surface. You never see it from the top of a mountain, and you never see it from a plane also. That was supposed to be a curvature hiding a boat completely. Even a building.
Yeah.
In some cases, mountains. In other cases, yeah, it's curvature. But that distance from the observer to that boat is little fraction of that distance that you see in the horizon, just here on the surface. From a side to side, it's bigger distance than what you see from you to that boat that's being obstructed. So if
Right.
there is no curvature from side to side in that horizon, it means that there is no curvature from you to that boat.
Right. Yeah, because the boat only like a few miles in front of you. That's it, right? But the distance from the boat to your left or to your right, it's greater than the one in the front of you.
Much greater.
Right?
Yeah, exactly.
Much greater. Yep.
And also, if you it will be also much greater than that distance on the surface than on the plane than on the surface, because when you are in high altitude you see much more greater distance, because that obstruction that you had because of perspective that made that surface of water rise toward your eye level and mix with the merge with the sky, it was, you make that angle bigger. So when you get higher in on top of a mountain or in an airplane, so that angle is getting bigger, so that horizon will be so much farther away from you. It means that distance from you to the horizon is bigger than what it was in the surface, and also the distance of the horizon from left to right, from the extreme left to the extreme right.
Right. Hey, you want to know something funny, Necro? There's a guy also named Necros, but he's not from Morocco. He's from Brazil. And he came in here a few times, right? But the last time he came in here, you know, he started talking about, oh, but we can see the curvatures from what is it? From Mount Everest. And then, you know, we looked it up. You know, how high it is, whatever. If I'm correct, I don't remember. I think maybe I'm not sure. I don't want to throw the number out there, but it's basically it's lower than you know, the plane altitude, the commercial flight, like 35,000 feet. It's way shorter, right?
I understand you.
Yep. And then I'm like, you know, we try to explain to him, and we ask him, bro, so I just flew, you know, from Texas to Florida, back to Texas. You know, when you get on the plane, the pilot tell you, you know, when you get to the cruising altitude, he, you know, he said it 36,000 feet up in the air, right? So if you can't see the curvature from the 36,000 feet right up there, how can you see the curvature from Mount Everest when the distance, when the elevation is way lower, right? And he trying to argue with me over and over again, right? I said, well, why don't you just, you know, show us like a, you know, either a picture or video or something, right? And that thing he did show like a fish island or triangle lens, right? You know, the reason why they use that because they want to capture more you know, more view or whatever, right? So then we pointed out to him, but he finally conceded. He finally conceded, like, okay, I made a mistake, I'm sorry, blah blah blah.
I had a person like that in some YouTube channels, Arab YouTube channels, when I was just watching videos in Arab channels. There was a guy who was scouting all the Arab channels, just go in the comments to say that it's a lie, and he could see the curvature of the Earth from a top of a mountain that is high, like 3,000 3,000 meters or 3 kilometers, and he could see also the buildings being tilted to the back because of that curvature. So it was to that point. And what made me just say that he is an agent, because it wasn't for a week or a day or a week or a month or a year. No, it was for years. And I bet that if I go to the newest videos in the Arab channels, I will find him again. And I think that that kind of person is just an agent sent just to disturb the viewers, who comments, who post their comments in the channels and the videos. So he tried to disturb them and tell them that they are liars. He could see the curvature. The Earth is a globe. The Amir or Prince. There is a prince in Saudi who went to space they sent him to space, and he said that it's a globe. So they used him as an argument, like he is a witness for that curvature or that sphere Earth.
Yeah. Hey, I want to show you some videos. Some idiots came in here claiming that they can see the curvature. Well, favorite YouTuber, one of the favorite YouTuber, whatever, went to went to outer space, right? Went to space, and they can see the curvature up there, right?
Dude
And
Perfect? You talk about Dude Perfect?
hold on, let me see. I got the video right here. Let me find it. Yeah, YouTuber. Let me search for it. Went to space right here. This video right here. What's that? Right here. Yeah, let me share it real quick, right? And we actually live stream in here and watch the video together, um, and we caught it, right?
Yeah, Dude Perfect,
We
like I told you.
yeah. Let me see. Where's that? Where's that image? Let me see.
They debunked.
I'm
They
on my.
debunked them. They showed from the windows the horizon being horizontal, completely straight.
Yeah.
Yeah, they debunked them already. Even that billionaire who also went to the, I think, 60 miles. They
Right.
debunked him, and they showed that the horizon is horizontal, and they came with Neil deGrasse Tyson to say that there was not there wasn't high enough to see the curvature. You can't see the curvature from 60 miles.
Right. But the kid, right? The kid that brought this up or whatever. Well, he's sworn up and down like, oh yeah, you can see the curvature. But when you watch that video, right, and it showed the curvature on ground level already. I screenshot it, but I'm on my other phone right now, so let me see.
I
Yeah.
think I had a meme about that. The from the Earth's surface, you see the curvature, and with the same camera, you see the from space also from the edge of space, like they say, and you see it. You
Right.
see the curve of the horizon in the surface also because of the camera.
Right. Yeah, I have the screenshot somewhere. Let me see. I'm gonna find it.
The thing is, what I like is when Felix Bongard said by himself that he saw the curvature of the Earth. He said that he saw it.
Yeah, that was a joke, bro. That was a joke. I mean, he was lying, obviously.
Yeah, we know, because the funny thing, who is lying between the two? Neil deGrasse Tyson, who is telling them that you can't see the curvature from 60 miles, much higher from where Felix Bongard went, because he went just 32, I think, or 30 miles.
Yeah.
If you can't see it from 60 miles, how could you see it from 30? That's the point. Who is lying? And they all they both worked with NASA. So Neil deGrasse Tyson or Felix Bongard, who said that he saw it. And the funny thing is when Neil deGrasse Tyson was in that, I think it was in a school or something like that, where he had that globe, that inflatable globe, where he told them that Felix Bongard didn't go high enough. So he pretended to not remember the name of Felix Bongard, knowing we know that it was a script. that he read the name of the guy that he was about to talk about him in that show. He read the name many times, so he know the name, and he pretended that you know that guy who went with the who did the jump, Red Bull jump. I know, like he didn't remember the name. You know the name of the guy.
He knows the name. Yeah.
From
Yep,
the top of your head.
Yep.
But he was acting. It's just an actor. He was acting. It's a part of the scenario, or like if you want to say the script, and he had to do it like that.
Yeah, I just posted. I found it. I found it, bro. I found it. That screenshot I took. Right. If you look at you know, in the side chat right now, you could see.
Yeah, I see it.
Pretty much, you know, the curvature, you know, on ground level already. Right. So obviously, when you get up there, you're still gonna see the curvature, right? But it's not real curve, right?
Yep.
It's the lens distortion, you know. And a lot of these idiots, like they blindly believe that, you know. And I guess you know, the mainstream doing a very good job to brainwash these people, right?
And the funny thing, it's the same amount of curvature in both pictures. The same amount of curvature. So it means that it's definitely not a curving line. It's just a straight line, and because of the lens, it has to curve it at the same rate.
Right. Yeah. Pretty funny, bro. You know, a lot of them just come in here and talk about, oh, you guys are stupid. Oh, flat earth. You flat earthers. Yo, you don't know science. You science denier. You know. We seen the curve, and they trying to show it to you, and then you debunk right there, right? And they spiral. They get scalloped. Oh, what about this? What about that? What if you know, we just disprove your curvature?
I just remembered something important. So there is a flu now among the Globers. I don't know if it was an article or a video that they watched that talks about gas pressure, and that tries to tell how gas can be attracted by gravity toward the surface. The point is, whenever they will talk about that, they won't talk about the gas phase of the molecule. So they will use hydrogen and oxygen, like for examples, but they will just show you experiments and papers about tests done, but by cooling the molecules. So they turn it to another phase. They turn it to liquid or solid state. So the molecules will just have different attributes due to that different temperature. And it's not exactly the same thing that we are talking about, because we are talking in specific about the gas phase of the different molecules. Doesn't need to be hydrogen. It can be any type of molecules, because different molecules, they have those different phases. Even iron, if you heat it enough, it will melt, turn to its state like liquid, and it will evaporize after that, turn into I don't remember the name of that molecule construct. If it's iron oxide or something like dioxide, like I think it's iron dioxide, the gas state of the gas phase of that solid material that we use. Even diamond, you can turn it to its to gas phase. If you just heat it enough, you add some oxygen to excite the heat inside the tube test or something, and the diamond will turn to will evaporize. You will no more have any diamond.
Right. So
when
wait. So they came out with an article that gravity hold gas down here. They came out with an article
that gas molecules can have attraction property toward the ground, so they can follow that vector, but they don't talk about gas. They use those molecules like we know them because usually people, and if you talk to anyone about hydrogen or propane, in their mind it's just a gas. Like they never realize that, for example, in your propane tank in your house, inside the tank, it's not gas. It's pressurized propane turned to liquid. It's in a liquid form. It's in a liquid phase inside the tank. Shake the tank, you will hear a liquid sound inside.
Yep.
Yeah.
Yep.
That's propane being pressurized enough and cooled to turn to its liquid phase to put high amount of propane inside a small volume. Because if it was gas, it won't be. You can't hold it there. It will just be a small amount of propane. Like when the bottle is just empty, you still have small amount of propane inside the tank, inside the gas tank, but it's just in the gas form. It doesn't have any high pressure to try to escape out because it's equalized with what's outside the tank. So it doesn't have that push that can push the gas out outside the tube to help you ignite it with your lighter. So the propane is in the liquid phase inside the tank. It's not gas. Yes, propane, but it's in the liquid phase. So when you open the valve, that liquid will start just boiling and it will turn to gas, then escape the bottle. Then you will have that gas that you can use. Like in the lighter, it's the same thing. But if you have a transparent lighter, it's exactly the same thing as that iron tank. The lighter, inside the lighter, it's not gas, it's liquid.
Right.
So they are.
Yep, we can see it. Yep.
They were confused by the different phases because those persons used molecules that are in general. Whenever we see them in nature, we see them in gas phase. So in their mind, they can just be gas. They can't turn solid or liquid, but you can turn them solid or liquid. If you cool them enough, if you cool that propane enough, you will have a block of ice propane.
Right.
Like solid chunks of nitrogen or liquid nitrogen. It's just the same molecule which that we can find everywhere as gas state or gas phase of molecules. But if you cool them enough, you can turn it to liquid nitrogen that you can use to make that those white clouds. If it hits the room temperature, it just starts boiling hard enough, and it will make those white clouds. Yeah.
I see.
So don't fall on the. I'm sorry. Go ahead.
No, go ahead. Sorry. You finish.
I just wanted to say, don't fall on their trap because it's just a trap. They use those molecules, but they don't use them in their gas phase. And the thing is in contention between us and them is the gas phase. It's the only thing in the entire existence that need closed container to contain it. So to contain gas, you need a container. That's why it's called a container. It's helping us contain something that is just moving freely everywhere all the time, and that's not following any specific vector, because if it was, we will just follow that vector and put a bucket. Like, for example, water follows a downward vector, and if we say, you can translate it as because of density and buoyancy, equilibrium, and those things, but it's not the point. So water, because it follows downward vector, you use just a bucket. You know that water won't fly from the bucket. But because you know that gas doesn't follow any specific vector, not right, it doesn't go just right. So if it does, you will just take a bucket and put it right side, the opening toward the right. So those molecules will rush toward that bucket, like water does. If you throw it from high to down, it will rush, and you pour it on that bucket, and it will just stay on that bucket. So we will make vertical buckets for gas if they go in specific vector, but they don't. And because they don't, you need a container.
Just wanted to say earlier, I posted on the side chat, there's a new laser experiment done by Taboo Conspiracy. This from today. It's really good.
Awesome. Thank you.
Oh.
28 miles.
28 miles.
Yeah.
Yeah. Refraction.
Yeah, of course.
Easy.
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 Hazizi. Oh my god. It doesn't matter how much obstruction or hidden height there is, it will always be refraction that makes the magic.
Yep.
Doesn't matter. You can give them 1 mile, 5, 10, it doesn't matter. Fraction solves everything. But yeah, beautiful experiment there.
Yeah, watching.
He's using P1000 and P900.
You seen another video him with the retired pilot. Here, let me see. I think he posted not too long ago. Yeah, 1 second. Right. Or maybe a while back. I seen it somewhere. I seen it pop up on my feed. Or maybe a little while ago. Right. But it's kind of new to me. And when I was getting ready for work and I just watched it, he did an interview with the one of the pilot. Let me
How did
see.
that go?
What's the video? Well, I missed some part and stuff because I was getting ready, but I'm gonna have to rewatch it. Like just like testimony with people that have experience, with the aircraft or whatever, and flying up there. Yeah, maybe. Let me see. Oh, right here, the F-16 pilot, right here. Oh, it's like yesterday. He uploaded yesterday. Yeah, there you go. I'm gonna post it in the chat. Basically, right underneath your video.
Oh, they have
The one
16
that you
pilot.
posted.
Let me see if I remember
Yeah.
seeing that.
Yeah, he uploaded
Oh,
yesterday.
yeah, this
matter of
one.
fact.
Yeah. Bob
Yeah.
interviewed him. Yeah.
Yeah.
And it's funny, he didn't realize that before he was told. After he was told, then he realized Another globe. Wasn't a globe.
Right.
It's just they're doing the job. They don't think about it. Something.
Yep. But I think funny enough, man, some of them probably like, even they never heard about flat Earth, right? This, let's say, in the early, 90s or early 2000, I bet you anything. Some of the pilots, up there flying, and then they thought to themselves, well, how could this place be a ball? Because I'm flying straight. I'm not changing any elevation.
No, I don't
Except
think
that you don't think that?
No, I don't think that. I think that because the indoctrination was global, it's hard for people to just realize that the fraud by themselves without any starter. I think
I mean, yeah,
we need
it
this
could be,
starter.
but I'm just saying maybe some of them, like small amount, a few of them, but yes, the indoctrination it's very deep, most people, they just, do what they do and they believe what they believe, right? They never even, thought about that at all.
Just by sitting like that and starting to question the globe, it's very difficult without
Yeah,
any
it is.
starter, without anything to tell you the opposite idea. It's really difficult to find people who just realize that it's not a globe just by themselves. They never heard any other idea.
Right.
Because there is
But
nothing to push them to question that belief that they had.
yeah,
Not
hey,
like
but you remember
religion.
that guy? You remember that guy Star? You remember? From the Islam server. Remember when we used to be out there? You remember?
Yeah,
Remember?
yeah.
He told us he was a flat earther since the 90s.
Since the
Yeah, but
90s.
remember the guy Stars? He go by Star, as
Yeah, I think since the
yeah, he told
90s.
us that he was a flat earther since the 90s because of the Quran, the scripture. Yep.
Bizarre.
You remember him, right? When we used to go out there when we had the VC over there.
Yeah, I think I remember the name, but I don't remember the person who it was exactly.
Yeah, that was the guy. He I was so surprised when he told us the story. Um, he was like, "Oh, I've been a flat earther since the 90s." I'm like, "How?" He's like, "Oh yeah, the scripture." Yep. He always believed that the earth is flat on that part because it came from scripture. Um, but see, the thing is, most of the Muslim over there, they were easy to talk to for the most part. There's some dickheads in there too, but a lot of time, they came into that VC, and they made our job so easy. They listen. They willing to take a look at the information we provided. Right? They're not very combative. This VC right here, it's could be a lot trickier.
Yeah.
A lot of people that come in here, they refuse to look at the information, but they want to sit over here and argue with us. Oh, Q, were you there too, bro? Q, were you there in Islam server too? Yeah, I thought I seen you here and there, right? Were you? Yeah, you were there. Yeah, you were there for a little while, Q. I think it was Q, Root, DJ, Necro, T Dub, T Dub too.
Yeah.
Yep.
That's where we
Yep.
started off.
Yep. Till we came over here, and then we didn't, yeah, we didn't have enough muscle to do back and forth. Yeah. I think if you know the 24/7 main crew whatever help us out, I think it would have been, yeah, I think we would have another VC over there. But I think you know, later on in the future, if we want to go back and claim that VC again, I think they would give it to us with no problem.
Maybe, I don't know. I mean, they deleted the VC after a while.
Yeah.
Not the guy who helped us, but another guy there, that one of the other admins. You know, as a globe he hates, you know, spies, flat earthers, I guess. He noticed we went over here to PNR, and last time I was over there in their server in our VC before it got deleted, he started talking in a ill manner, like you know, like oh you. I don't know. I forgot how he said it, though, but it was like an ill manner, like "Oh, you over there now at PNR," like blah blah blah. Like it seemed to me they have some beef between each other. The owner of PNR and their server.
Yeah,
something like that. Something like, I mean, are we expanding?
I remember.
What do you want?
Yeah, I was there too, bro. He spiraled, bro. He was mad. He's like, "Oh man, you not loyal and all that stuff." I remember. Yeah, you
Boy,
guys
man,
not loyal. Like, how could
he had
you?
no
How
respect
could you
at all.
leave us? Yeah.
He showed
I
no
mean, he
respect
played the
when
guilt trip.
spoke to us or to me as well. He spoke in a like in a very bad manner.
Yeah.
I didn't like that, so I was like quiet. So I was like, I left. Whatever, do whatever you want with the VC.
Yeah. Well, I was there, so you know he was clowning around, so I clowned back. Yeah, I pretty much clowned back, but as soon we show up that day, everybody came, bro. Everybody. Well, I think T Dub was there too. DJ was there. Maybe you were there too, but you know, if you say you left, yeah, you probably left then. But yeah, I remember they were they were mad at us, you know, for leaving
I
the
was there
server.
a lot. Yeah, I was there every day in the beginning.
Yeah.
When I joined, every day since then. But yeah, I mean, the topic itself, it's not easy to talk with those kind of people, I guess. When they view the reality in a subjective matter and just by the book, and that not being open-minded, that's the hard part. When they're not open-minded even to accept new information, they think we are, I don't know, what do they think? Thinking that we're spreading lies or something. They don't want any part of it. Calling us kafirs, you know. The word they use, the Arabs. Kafir. The kafir. It's an insulting term. Even. And even Necros, he was called out. I mean, they jumped on him as well, like calling him non-believer.
They hate Necro, bro. They hate Necros.
He's not a Muslim man. He's not a Muslim man. He follows only the book, not the hadiths and the. He doesn't follow any tribe, man. No, it can't be, man.
For them, you need to follow other than God to be a Muslim.
Yeah.
For me, if I just follow God and the word of God, I'm not a Muslim. Not Muslim enough. Not good enough for them.
Yeah, crazy.
Yo, but hey, this time, they come over there just to wait to talk to Necros. They come in there, be like, "Hey, where's Necro?" I'm like, "No, he's not here." Okay, and then leave. And then next thing you know, they come back and, "Hey, is Necros here? Can I talk to him?" I'm like, "No, he's not here." And then as soon as Necros show up, they all came. Yeah, T-Dub used to be there with us too. Yeah, I remember. Yep. And yeah, well, that one time when we were in here, T, that was like, okay, let's all go over there. All together. We'll bounce back and forth, back and forth. And I guess that was the first and the last time we bounced back and forth. And then since then, we didn't really go back there.
When you see those kind of reaction, that shows you one single thing: how good the indoctrination was on those type of people. It shows you
Which
that
server was that?
they were really indoctrinated, and it worked on them 100%, and that triggers their cognitive dissonance each time they find someone who's not following what they are following, what they believe. Because for them, what they believe is just the truth and nothing else. They can't be wrong. Their fathers can't be wrong. Their grandfathers can't be wrong.
Yeah, I mean, yeah. But still, like, pretty good amount of them, man, are like, they were easy to talk to about the flat Earth stuff. Um, they're not as bad as other VC that we go to. But I think a lot of time it's easy if we only have like a few of them. But if it's like more than 4 or 5, oh yeah, that's when they start talking at the same time, and we have to moderate. And as soon we mute one of them, they go, they left, they went to the other VC, they got unmuted, came back. Oh, that was so annoying too.
Yeah.
Which server were you talking about?
The Islam server, politics and Islam.
Oh,
Remember,
right.
TW, you used to
Oh,
go
yeah.
with us. Remember? Yeah. Yeah.
Yeah. Did we leave that server or something? What happened there?
Yeah, we left there. Well, remember the last time you said, "Hey, let's bounce back and forth and see what happened," between
Yeah, yeah.
this server and that server. And matter of fact, we all went over there that day after, after you made that statement. So we went, "Oh, okay, let's go check it out." And we were there, and that's it. I think after that, we never really gone back like that. So nobody's over
Did
there
they
to,
shut down the channel or something, or what happened?
Yeah, they closed down the VC after a while because nobody's there anyway. So
Right.
mhm. But I think like later on in the future, if we want, if we have enough people or whatever, we can go back and claim that VC. Either Cyclone or one of us, can go get that VC back if we want to. I believe they would give it back to us. But the problem is that we don't have enough people to go do it.
It seems the VC participants among like the home server are low. Like, I mean, be able to spread us that thickly across several servers, it doesn't seem viable. A lot of old regulars left. They just haven't been back. Like 4 years ago, it was just fully packed with, there was just a lot of people in there all the time. I could, just like name a few, like that were. It's still some like there's still Miggy and Jedi, Crypto, right? Like the OGs, like some of the OGs are still around, but there was a lot that aren't. Like Chocolate from like from the FED panel, he used to be in 24/7 heaps. Like and yeah, there was Eli and there was Battle Mod. There's a guy called there's a few that you probably wouldn't even know the names of. There was Ed. There was there was a lot. There was another guy. I remember his name now. He ended up going across to EPS or whatever. No, what are they called? Something Angel. He was hanging out with those guys for a while. I remember his name now. But there's so many. Like the point is, there's so many names now that like were so regular. Like that there was a huge panel of flat earthers. They were pretty much all mods, and it was just constant, right? And if they weren't just, if there wasn't a conversation with the Glober, they were just talking amongst themselves, right? And mostly on topic, right? Early hours, of the states, when everyone's going to bed, there would, Battle Mod and other people would talk about cars and food and alcohol, whatever, right? Fun times they've had, whatever, like just waiting for a Globey to pop in. But for the most part, there was never never an inactive moment in that VC in the home server. Always someone talking.
Yeah, you think it's because the whole COVID, the jib jab stuff, it kind of broke up, like, it broke everything apart. The same thing even in in real life, in person, right? Like businesses or certain places people used to go, you would see a lot of people. Now not that much. I think the COVID stuff kind of like changed a lot of stuff. Oh, matter of fact, even grocery store, they used to open 24 hours, right? I used to get off work around 11, right? And then I go shopping. And it was still a bunch of people at nighttime at Walmart, right? Since the whole COVID stuff, guess what? If I get out a little late or whatever, by the time I got there, yeah, they already closed. So a lot of things change. Not just Discord. I think it's a lot of stuff. Places
Maybe,
people used to go. Yeah.
Life is, just the pressures of life and stuff is like taking effect on a lot of people, I guess. I mean, but yeah, I think it's whatever the reason is behind it, I don't know, but like fully, but a lot of the regular flat earthers that used to just hang out in that chat all day are gone. They're either gone to another server now, they focused on another server, or they're just focused on other things in life or something because they're it's not there anymore.
Yeah. Well, yeah, I mean, yeah, I think people just maybe they want to focus on other stuff, or they go, with a different group, different VC or whatever. But I'm glad I found the 24/7. I didn't know that community exists on Discord or online, right? Because back then, right, you can check out all the information. Everything was on, like, well, from what I remember, on YouTube. I'm pretty sure it was on Facebook too, but I deleted my Facebook a long time ago. And but after 2018, I got kind of terrified for a second. I'm like, yo, what happened to all these people, right? And I didn't know, they shadow banned the flat Earth and other topics and stuff, right? I didn't know, so I'm like, what happened to these people? And later on, I came across, I think it was either Eric DeBay or John Thor. That one guy, he's very good at editing, um, or remaster other people video, and he made it into his own editing. And I think I found out either from Eric DeBay or him, and then I'm like, oh, this is what happened. I was dumbfounded, because I couldn't search for anybody. Allegedly Dave, ODD. I have, if I search by the title, right, it wouldn't come up. I have to type in, the actual channel's name. And a lot of time, I don't. I have, I subscribe to a bunch of flat earthers, so I don't remember, the channel name. So that was a challenge too. But I remember Eric the Bay, ODD, allegedly Dave, um, couple other guys, whatever. But I found Witsit later. So Witsit, when he was on live stream and he mentioned about 24/7, and that's how I found it. You know what I mean? And I also heard story that Flatloy, shout out to Flatloy. Flatloy did an interview with Eric Dubay, and he gave 24/7 a shout out. More people start showing up because I used to interview people in the VC check in, and like, oh yeah, we found this place because of Flatloy. You know what I mean? So that was awesome.
Yeah, that needs to be done a lot more. And I mean, like, the server itself should be utilized for that. You should do the interview in there. Because then it will definitely get a mention. You know what I mean? Like, we'll even see that the interface being used for the interview is Discord, on YouTube, right? So I've suggested that before. I'm just lazy. I should be doing more P&R and stuff like, PR stuff. Sorry.
Oh, maybe you should go on interview, brother.
Yeah, no, we should be reaching. I've suggested that before in the past. Like, actually stage the event in Discord. Like, invite someone who's like recognized and like a public figure, that's putting out a lot of content, etc., etc. We've had Dave Weiss in there. Like, he's just dropped in, like, just for a chat, and same as Mark Sargent, Russian Vids. I got Russian Vids in.
Oh, Russian Vids used to go over there too?
Did once, because I invited him. I went on to his stream. Like, I was in his stream, on his chat. He was paying attention to what people were typing in the chat, his live stream, and I said, hey, I got he answered a couple of questions of mine, and then I said, you should pop over to 24/7 Discord, like 24/7 Discord sometime and have a chat over there. We'd love to have you in there. Yeah, and he did.
Right.
Turned up, like a couple of weeks later or something. He turned up. He said, yeah, and I wasn't there for it, but like, I was asleep or whatever. It was bad timing, but yeah, no, who else has been in there? Quite a few. If they weren't already part of the server and already making content, they've made content and then found us and come over and said hi.
Right.
Yeah. What's his name? The fellow that has the theory about the elephant mountain. And that's like an elephant, like he's sort of into the not Tatari stuff, but mud flood sort of stuff, right? He's found this mountain, and he says it plays anatomical features of being like a fossilized elephant. It's just grown over with trees and everything, and some sort of elephant creature. Like, it's just says all these characteristics. Internals and everything.
I think I've seen that, bro.
Systems.
I think I've seen that somewhere.
Yeah. What's his name? Stellium? Stellium 07 or something like that.
Yeah.
He's been in there. This is heaps, man, and it has the potential that, like, for more people to do that, and like Flat Lloyd was I know with that. It was awesome that he got us more attention like that. Yeah.
Well, I would say Flatloy, he's one of the best flat Earth representative. That guy does not get mad, and I used to hear him come in here, and he handled this Globy so well, and because all the dude did was just insult, and basically insult and get scallop, and Flatloy handled that really well. And if it was any of us, no, I don't think we could handle it. And he just did an amazing job. So if anybody from the 24/7 want to go on interview, I think Flatloy would be one of the best to do it. And he's well educated too. So he's a
professional educator.
I agree.
He's a professional educator. Yeah.
Yeah.
He's so good because he is so calm. Every time you talk to him, you can explode, and he will remain calm and respectful in his discussions from the start to the end.
Right.
And never saw him just derail in any discussion. And his logic
Right.
also is good.
Yeah. Definite. Yep. I do agree. But hey guys, I'll talk to you. I'm probably gonna jump back on a little later, but I gotta go now. So you guys take care. Necros,
Have a good one, brother.
Q, J, T Dub. You guys take care. I'll talk to you
Too,
later.
man.
Okay.
Cheers.
Have a good one, brother.
Later,
Take care.
brother. Okay.
People got to remember too, like Discord was long ago, was relatively new, and it was just being discovered, and like so, and it became sort of popular, and now it's kind of like there's other competing platforms and social media groups and whatever, like, so sort of like off a little bit just in general, just like with traffic, you know what I mean? Like, it's probably still growing in traffic, like as far as registered users, but I mean those registered users are using it less, maybe, so not that same flow flux of people just jumping on Discord. Oh yeah, like, oh look, flat Earth, like it was really busy traffic once upon a time, busier than it probably is now. There's more users join, more servers open up. So even if the same amount of users are actively using Discord, they're spreading their time over more area. So
All right, laddies, time for me to hit bed. Thanks for today. I'll catch you tomorrow.
see you, mate. Yeah, no worries, Chris.
Yeah, have a good one. Take care, guys. Yeah.
See ya. Seeing anything going on anywhere else at the moment.
watching 24/7 Flat Earth Discord live.